Welcome to Lesson 13, Implement Disaster Recovery by using Azure Site Recovery. This lesson concerns how to implement business continuity and disaster recovery in your Microsoft Azure hybrid cloud environment. We begin by configuring Azure Site Recovery networking. Next, we'll enable Site Recovery protection for on-premises VMs. Then, we'll define an ASR recovery plan and configure Site Recovery for Azure VMs. At that point, we're ready to implement VM replication, failover, and failback. Finally, we'll review ASR policies. We have much ground to cover as usual, so let's get right down to work. Well, first of all, what is Azure Site Recovery? Azure Site Recovery is a feature in Microsoft Azure, it's actually a product, called ASR for short, that gives you business continuity and disaster recovery capability within your Azure environment. Actually, you can go beyond Azure, as you'll see. You can cover your Azure VMs for sure, but you can also get VMs that are running in other clouds and physical and virtual servers in your on-premises environment. BCDR means how can you keep your workloads available in the event of a significant failure. If your workloads are already in Azure, that failure might be on Microsoft's side where the region goes dark, you see. If it's an on-premises workload, you might have a flood or a catastrophic power outage. So how can we keep our service online and available with minimum or no downtime? Now, the Azure Site Recovery product exists within the Recovery Services Vault. And in the Recovery Services Vault, we have ASR, but we also have a partner service called Azure Backup. And we'll learn all about that in this course as well. Backup is going to involve some downtime while you restore your failed machines. The purpose of ASR is that you can fail over. Specifically, you're replicating your source workload, the storage and configuration of those systems, and you're able to fail them over to another environment. So we can protect Windows Server as well as Linux hosts, as I mentioned, in Azure and other clouds, on premises. There's capacity to do physical and virtual machine site recovery. You should know that Recovery Services Vaults can geo-replicate snapshots so that you can still initiate a failover even if your home region is offline. And ASR respects availability zones and availability sets. So if you're doing an Azure to Azure site recovery and your virtual machines are arranged in availability zones and availability sets, you can absolutely keep that enabled and gain those high availability service level agreements from Microsoft. Now, I created a diagram for us that shows ASR high-level architecture. Let me bring out my drawing tools. Things might get a little messy here, so hang on. Now, ASR is very complicated because you've got on one hand your source or your production environment, and the idea is that you're replicating that environment into another region where you've got your disaster recovery environment set up. In the demo I have for you, I'm going to do the simplest architecture, which is called Azure to Azure or A to A failover, where your source and destination environments are both Azure virtual machines and a virtual network. However, I want you to understand that ASR can fully embrace the hybrid cloud, such that you can start with your on-premises environment as your source and fail over into Azure. You could do just the opposite, where your production environment is in Azure and you can fail over to on-prem. So there's lots of different possibilities there. So I want you to understand that straight away. Now, second, I want you to see that in the failover environment, Azure doesn't actually have your virtual machines configured. Let's just take the case of Azure to Azure failover for simplicity. In other words, you've got your production virtual network in my home region, which is East US, and I have my subnets arranged. It looks like I've got a two-tier application, a web tier on one subnet, a database server on another subnet. As you know, Azure VMs have dependencies, network security groups, network interfaces, this kind of stuff. And we're exposing this application to the world on a public IP address in Azure in front of an application gateway load balancer. Good deal. That's a pretty common pattern. When we set up ASR, we're replicating the storage from all of those machines. We are replicating the virtual network environment, as you can see. So over here in our secondary region, West US, I have another virtual network with the same private address range, the same subnet definitions. I would have to create another application gateway. But then you've got all of the workload. Workload is an important point when we're thinking of disaster recovery and ASR, because the chances are really good that you're not looking to replicate and failover a singleton machine. You have an orchestrated collection of machines. In this case, this application's not going to do anything unless you have both the web and data servers available and online, you see. So in the disaster recovery environment, when you're doing Azure as your disaster recovery site, it's important to know that Azure doesn't have these machines already built and running. Instead, it's just the storage, the OS disks and the data disks that are being replicated on that replication channel. And again, that channel can be Azure to Azure, it can be on-premises to Azure, it can be Azure to on-premises. We're talking about TCP 443 with HTTPS. So this is firewall-friendly traffic that does not require a site-to-site VPN or an express route circuit, all right? With me so far? Now, this particular topology is pretty cool because in the event of a failure in our primary environment, when we initiate the failover, it is at that point that Azure will build out the actual VMs using the backup, or it's not actually a backup, it's a replication snapshot that you choose when you failover. And at that point, those VMs, once they're up and running, then you're going to be paying the runtime costs. But as I said, the replication and once the storage is synchronized, you're not paying for running VMs. They're built when you failover the environment. And the reason why you're not going to have any problem having a virtual network here with the same exact private IP addresses is that as long as you don't try to put a peering or something between those two VNets, they're completely independent from each other. Now, to solve the problem of the public IP address, you might be wondering, in my primary environment, I'm DNS routing to a particular endpoint IP. Now my primary environment's down, so I initiate a failover. I've got a different, in all likelihood, a different public IP address in front of that application gateway. Well, the really nice pattern I like here is when you implement Azure Traffic Manager. This is a DNS-based load balancer, where it can detect whether the primary is online or not. And if it becomes offline, you can have it route traffic automatically to another endpoint that you've got configured. So this is just one of many architectures. Know that, okay? That this is a pretty complicated service. I'm just giving you the high-level similarities regardless of where your source and destination environments are. All right, so let's assume now that our source environment is in our local data centers. You might be thinking, well, okay, well, we don't have much of any by way of physical servers. Our physical servers are just virtualization hosts. Does ASR probably supports Hyper-V, Microsoft's hypervisor, but what about VMware? Well, actually, yes. ASR natively supports VMware-based virtual machines. However, there is a prerequisite that you've orchestrated all of your ESX hosts, your vSphere hosts, into a vCenter server. So note that requirement. You have a much easier time in terms of setup when you're using Hyper-V, and hopefully that should make sense given that Hyper-V is Microsoft's native virtualization provider. So you have what's called the Azure Site Recovery Provider agent that you install on your on-premises Hyper-V hosts. So there's less moving parts, or should I say fewer moving parts, when your on-premises VMs are virtualized with Hyper-V. But absolutely, VMware is supported. Regardless of specifically how your on-prem servers are arranged, Microsoft strongly recommends that you run the ASR Deployment Planner. The Azure Site Recovery Deployment Planner is a free download. It's just a tiny little executable. And you run that in a console window. You point it to your virtualization hosts. And you should let it run ideally for several days, because what the deployment planner will spit out as output is a really nice Excel workbook that gives you the readiness status. In other words, do you have any machines that for whatever reason are not good candidates for replication and failover into Azure? You see what I mean? What can you expect in terms of replication traffic with bandwidth? How much bandwidth do you need? What virtual machine sizes? You know, Azure has this entire library of VM sizes. How do you know what sizes are most appropriate for your VMware and Hyper-V VMs, you see? So ASR deployment planner is a critical planning step because the output of that is going to inform you should do in terms of sizing your VMs in your recovery environment, your site recovery environment. You'll need an appliance, a pre-configured virtual machine called the Site Recovery Configuration Server if you're going to do VMware or physical server DR. So you can do failover with physical servers. But honestly, I think ASR is principally for a virtualization-based business. That Site Recovery Configuration Server is pre-configured in VMware. You need to build it yourself if you're doing physical. The physical path is pretty interesting. It's unique because in order to replicate and fail over those physical servers, you're doing a P2V conversion, aren't you? Physical to virtual. And of course, hopefully it makes sense. You're not going to be able to fail back a VM. Let's say you're doing on-prem to Azure disaster recovery. And during failover, that physical server will be represented as an Azure VM. And when you do a fail back, are you going to fail back to the physical server? Speaking of failback, you'll have another virtual machine that you need to create called the master target server, and that's required to complete a failback. All of this is nicely documented, so I want to make sure that you know about the Azure Site Recovery docs at the Microsoft Docs site. You should just do a Google search for Azure Site Recovery docs, and you'll find in the table of contents lots of guidance for how this particular workload happens. And I want to repeat that there's no need for a VPN or an express route tunnel. The replication traffic occurs on TCP port 443, and we have TLS SSL encryption, HTTPS protocol. So there's no data that's being transmitted in plain text. What is a site recovery plan? Well, it's our method for orchestrating systematic recovery. When we do a failover, we may very well have, I don't know how many machines. Again, the idea isn't taking singleton machines and failing them over, although you can do that for sure. But instead, you may have a data tier, a business tier, and a web tier, and you need those machines to fail over in a particular sequence. So the recovery plan, or the site recovery plan, enables you to script the sequence in which the source protected machines will fail over. You can attach instructions, text instructions, that show up during a failover process to help your colleagues. And very importantly, you can host Python or PowerShell scripts in your Azure account. Specifically, you'll need an Azure Automation account. And the hosted script engine in Azure Automation is called Runbooks. So you'll host your scripts in there, and you can call or invoke those scripts before or after each group fails over. So for example, your first group might be your database servers. So Azure needs to deploy those machines, set them up, get them ready. And then before failing over the next group, you can inject a script that can do any kind of status checking, package, dependency management, whatever it is that you need to do. It's just, again, it's not just a script that you upload. It needs to be housed in the Azure Automation account as a runbook. Lastly, when you're initiating the failover, you want to failover in the site recovery plan. This may make more sense in a moment when I show you this in demo. The Azure portal will allow you to failover individual machines, but you want to make sure to go into your recovery plan to failover the entire workload. The Azure to Azure ASR is definitely the simplest ASR architecture because it's all in the cloud. There's nothing on premises, particularly with physical hardware, that you need to configure. You'll need a cache storage account, and you'll create a DR or disaster recovery environment in another region. It used to be you needed to maintain 2 separate recovery services vaults, but nowadays you can do everything from your single source recovery services vault. It's very convenient. Let's look at the high level of the ASR replication and failover process. Once you satisfy your prerequisites and you set up replication, you let it run. It may take a while for that initial synchronization to happen. Your workload is ready for failover when your servers, your items, show up as a protected, or show up in, I should say, the protected state. Microsoft strongly recommends you practice regular test failovers to make sure that it works. And when your machines come up, they come up in the correct order, etc., etc. And what's nice about the test failover is that it doesn't disturb your source environment, and it allows you to clean up the failover environment with a single click in the Azure portal. When you're doing a real failover, again, this is something that Azure leaves to you as a customer, so you initiate this process. You choose which replication snapshot you want, and that's actually an important point, because when you choose your snapshot and let Azure perform the failover, you may find that whatever problem it is that existed in the workload is still there. So at that point, you can choose another snapshot, and you set in your replication policy how many snapshots you want to keep. In other words, how many VM states or server states or workload states, really, do you want to retain in your vault? When you're satisfied, you can use the commit command, and that prevents you from doing another failover and choosing another snapshot. At that point, your source environment should be down and your failover environment should be up and functional. When your source environment is back online and you're ready to fail back, the failback process consists of you reprotecting your workload, which is just enabling replication but in a reverse direction. And then the failback is simply a failover operation in which you do a direction reversal. Simple as that. Now, after you fail over to the source region, that's going to stop replication. So the very final step would be to re-enable protection in the forward direction. And there you go. Hopefully that makes sense. Specifically, the ASR replication policy is an object in your recovery services vault that defines, number one, the snapshot frequency. You see, the replication process is going to take every changed bit from your source machine storage and replicate them over into the failover environment. Well, those get manifested as persistent snapshots. Application consistent is the service level agreement that Microsoft offers that guarantees that when you load that snapshot, it'll bring the VM up to the state it was in, including memory state and application state at the time the snapshot was conducted. And you can read in the monitoring tools in ASR when it does its work, etc. The other thing you define in your ASR replication policy is the retention period for those recovery points. How many, how long. These are points from a costing perspective, because one of the cost metrics in the recovery services vault is how much data you're actually storing in there. Now, if you've used the Azure backup component in the Azure Recovery Services Vault, you know about the backup policy, which is analogous to the ASR replication policy. The backup policy is where you set your backup schedule, your instant restore snapshot retention, as well as your long-term snapshot retention. So that's enough of the theory. Let's get into the practice. Here we are on one of my local servers. Let me get into the browser and get into the portal and head on over to the Recovery Services Vault. Now, when you're using Azure VM Backup, you'll need a Recovery Services Vault in the same region as your virtual machines. And that's definitely still the case if you're going to do Azure to Azure Site Recovery. So you're going to want to make sure that your vault that you're starting with is in the same region as your Azure VMs. However, if your source environment is off cloud, then the location is just a question of how much latency can you stand. I mean, if my workload was in Australia, it wouldn't make much sense for me to configure replication in an East US vault. That makes sense? So let me come into my East RS vault, and we'll come down under Getting Started. Again, we have the two types of scenario that Recovery Services Vault can do. There's the backup and the site recovery. We're doing site recovery. And what we've got here is different paths based on where your workload is, all right? So we've got Azure Virtual Machines that's much easier. It's just you can get right into the replication because all of the prerequisites are taken care of for you in Azure. If you're dealing with VMware machines that are on-prem, you'll need to prepare your infrastructure, and then you enable replication and do recovery plans. If you're doing Hyper-V machines, same thing, prepare infrastructure, etc. So when you click into each one of these, you'll have different choices, different options to choose from. Like I said, if it's Azure to Azure, you can go directly into configuring replication, which, as you see here, where is your source environment? Are you using availability zones? Are you going to do disaster recovery, honoring those availability zones? 2, you choose your virtual machines. 3, you do your ASR replication policy, and you're off to the races. It's pretty simple. What about VMware? Well, this gets a little stickier because you notice that Hyper-V just has the 3 choices, but as of this recording, in late February 2022, notice that some of the VMware stuff is in preview. Now, you should understand that as a general rule, Microsoft Worldwide Learning has a policy where they do not put public preview features in their certification exams. So I doubt very, very seriously you're going to be asked detailed questions about Azure Site Recovery with VMware because of that. But let's just click into this Prepare Infrastructure for a moment. So it looks like in order to do this, we're going to need an ASR appliance. This is the configuration appliance that I told you about. And notice it's a 15 gigabyte OVA. So you'll need to stand that up as a virtual machine and register it with your vCenter server. When you sign into the VM guest OS, it's a version of Windows Server running a 180-day eval license. There's a built-in ASP.NET web application in that will actually present a UI for you. And you sign in with your Azure account and you register the appliance with your project here by providing the registration key, okay? And then you can follow the UI and go on from there. The physical workload is based on the VMware plan as well. Again, just want to look at the docs if you're looking to do site recovery for physical servers. The main use case here is for virtual machines that are either in Azure, VMware, and then lastly for Hyper-V, the prepare infrastructure step is much lighter. Instead of having a full virtual machine that you need to stand up, you just install an agent. Now notice here that when we're going the way of Hyper-V, it says download and run the deployment planner. I don't remember if it said this for VMware, but this is that ASR deployment planner tool. It's just a command line executable. See, it's a direct download. It'll bring a zip file down. And you just unpack this zip file, go to an elevated console, PowerShell or CMD console, and run it with the appropriate switches. So we have to say either that we've done the assessment already or we'll do it later. ASR Engine asks us, are we orchestrating our Hyper-V hosts with System Center Virtual Machine Manager? And what happens next is going to depend on whether we say yes or no. I'm going to say no. You define these logical containers called Hyper-V sites. And what happens is you create the site, give it a logical name, and then when you install the Hyper-V server agent software, you'll register that host into the site. This allows you to do staged disaster recovery. In other words, instead of replicating your whole army of virtual machines, you can do it site by site. Maybe there's just select number of hosts per site or one host per site. It just gives you that separation because you do need to think especially of that initial replication traffic and how much bandwidth that could potentially consume. Now, if we click Add Hyper-V Server, it tells us here, let's see, download the installer for the Microsoft Azure Site Recovery provider. And that's just an agent, a small agent. So again, this is just part of the benefit if you're already using the Microsoft hypervisor. And so download the Vault registration key and register the host into a particular Hyper-V site. So that's how you organize your Hyper-V hosts. And then again, you set up your target, which is going to be, if you're doing Azure to Azure, that's going to specify another region that you want to use for your disaster recovery region. And you'll need a virtual network that mirrors the source environment. So that can get more complex if you're starting from on-prem, which you would be here. So you would specify those settings, configure your replication policy, and then you're off to the races, like I originally said. You can follow the behavior of all of this stuff by coming down under monitoring, of course. You can raise alerts, you can look at metrics, but particularly I want you to see there's site recovery events and site recovery jobs, where you can drill into information, warning, and errors about replication health as you're configuring it. Site recovery jobs, again, every task that you do or that Azure does is going to be tracked in here. And notice that you can export these jobs. I believe they come down as a comma-separated value or CSV file. I also at this time want to give a shout out to log analytics, because instead of coming into these individual monitoring pages, more and more now in Azure, we're seeing all of our infrastructure monitoring collapsing on the log analytics workspace, where you can report on everything and use that unified Custo query language in order to get those answers. Wow, it's taken a while for Azure to generate that download, so let me cancel that and come back into the Vault. Now, I've already set up the replication. So let me show you. If I go under protected items, we've got backup items and replicated items. Let's go to replicated items. And I have two virtual machines in my source environment, Web 1 and Data 1. The web server and a database server. Now they're in a source virtual network, so let me quickly open up another portal tab and show you that. Let me go into virtual networks. It's called East VNet. And so I've got a web subnet and a data subnet, and the VMs are placed one-on-one on both of those subnets. And when you configure replication, particularly Azure to Azure replication, Azure will create a matching virtual network. You can see it here because I performed a test failover before I started recording, called East VNet ASR. Notice that it put ASR on the tag end of it. And notice that it's in my designated disaster recovery region, West US. I could clean that up if I want to, but that's fine. There's no peering. There's not going to be any conflict between my source and disaster recovery environments. Now, these are both showing up as healthy and protected. That's good. If we wanted to fail over an individual machine, like I said earlier, we can do that. We can come into this interface where you can get all of the failover controls. But if this is an orchestrated environment, which you already know it is, we want to make sure instead we have a recovery plan. So let's come down under Manage, and we've got Recovery Plans, Site Recovery. This is analogous to the backup plan, like I said before. I've done a test failover and I've done cleanup, and that's completed. Good deal. Let's take a look at the plan contents. Let me come into it. And let's click Customize so I can show you the interface. Unfortunately, and this is just my opinion, the recovery plan interface is not user-friendly, in my humble opinion. It doesn't allow you to rename groups meaningfully. If you want to move a machine from one group to another, you select it and then change group. It just got some strange control, in my opinion. So what you've got here is that your recovery plan starts with all groups shut down. So Azure will attempt to shut down the machine in the source environment if they're not already offline. And then all groups fail over, and it's listing all of the machines that are indicated. You determine what machines go into your recovery plan, and you can always add and subtract machines from your plans as you go on. See these ellipses over here? So you've got control over that. Now, instead of just all groups failover and it doesn't matter what order they come up in, this is where groups really play a good part. So I created a second group. Originally, there was just group 1. I created a group 2, and then I made sure, using these selection and change group commands, that in my group 1, the database server is going to failover first, and then once that's finished, we're going to do our web server. And lastly, like I mentioned before, at each group, you can add pre and or post actions. Let's say after our database server is failed over, we want to run a script that does validation. We can add that, say, as a post action, and this brings us into insert action. Manual action is just where you can provide text instructions to your teammates. Script, like I said, is where you're going to tap into your Azure automation account and you're going to select a particular runbook, okay? And it says here, the above selected runbook will be executed in both directions when you fail over from source to target, as well as when you do your fail back. And that may be exactly what you want. If it's doing checks, maybe it's a PowerShell script that makes sure that the database server's ports are available and it can ping. Whatever it is that you need to do is a fix-up action. All right? So that is, in a nutshell, the recovery plan. So lastly, there's the question of failover process. So we have an emergency where our source region is unavailable, our workload is flat on its back. We need to do a failover. Again, test is where you do a quick failover to your disaster recovery environment, make sure that it works and so on. It doesn't shut down the source machines, and then you can clean up the DR environment with one button. When you do a real failover, you have to clean up the disaster recovery environment yourself. So let's click failover. Failover direction is east to west, and fail back, you would do change direction. You choose your recovery point here. I only have one. Shut down machines, that's normally what you do, yes, so I'm going to select that. And that's all there is to it. The idea is within minutes, we should see those VMs created and up and running in the West US and my disaster recovery environment. And when we're ready, if we're satisfied with that, we can commit that change, go about our business, and then when we're ready to do our failback, we'll need to reprotect, which creates the replication channel again, but this time reverses the directionality. Do a second failover, making sure to reverse the direction, commit again, and then finally reprotect in the original direction. So let's come back to the other instance I have here, and let's take a look. So it looks like, let me refresh the view here. My data and web machines are still running. Let me do a hard refresh. There it is. I did a refresh, and now it looks like our source machines are stopped and deallocated. So far, so good. In the name of monitoring, let's switch back to our vault and come down under Site Recovery Events. Nope. How about Site Recovery Jobs? There we go. So we've got an entry here that's showing our in-progress failover. Let's drill into it. So we can see specifically where we are in the environment. Recovery plan failover. It's evidently building those virtual machines now. If we click Environment Details, now it looks like it's hit Group 1. And again, looks like it's hit Group 1. So we're getting there. Let's come back to our virtual machines blade. Let me refresh. Nope, the VMs still aren't surfacing in my list, but I'm going to keep refreshing. All right, looks like it's successful and finished. So let's come back to virtual machines again. It was just a couple minutes there. Pretty impressive. So we can see that my source data 1 and source web 1 are both down in the east, and they're up in the west. Great. If we come back to our site recovery plan, site recovery, Failover completed is the job status. Again, now we can click failover to choose another snapshot if we weren't happy, or we can commit. It says once you commit, you cannot change the recovery point of the machine. I'm going to say that's okay. So I'm going to call it a demo right now, but just the rest of the process is exactly as I mentioned before. We need to reprotect the workload in the opposite direction, as it says here. The target is going to be now east because we're out in the west right now, and we'll click OK. And that will initialize that deployment, and we'll want to wait for a protected status before we can do our failback. There you have it. Welcome to Lesson 14, Protect VMs by using Hyper-V replicas. This lesson is all about configuring disaster recovery for our Hyper-V virtual machine-based workloads. We begin by understanding Hyper-V Replica and configuring the Hyper-V hosts for replication. Next, we'll learn how to manage the Hyper-V replica servers, configure replication behavior, and ultimately perform various failover types to ensure the VM disaster recovery solution works as expected. Sound good? Let's begin. Let's consider the use case of Hyper-V Replica. This is a disaster recovery feature that began with Windows Server 2012 and now continues with us today in Windows Server 2022. Its use case, as I just said, is disaster recovery, or DR, not high availability. Please understand that. Although we should have minimal downtime when we perform a Hyper-V VM failover, it's not going to be the degree of consistent service that you have, for instance, when you're using highly available virtual machines with Windows Server failover clustering. So again, we're using Hyper-V Replica for disaster recovery so that if there's a problem, a corruption, some issue with our primary instance, our primary VM, we can initiate a failover to bring up a matching instance in the same or another site. We might have to reconfigure a little bit of DNS, but you've got yourself a VM that's functional and synchronized with the storage from the primary. This is a synchronization service. It performs asynchronous replication from one VM to another. Now, that secondary VM is in an off state. I know we're not in this lesson talking about Azure VMs where you're paying every minute that your VM is running. Here, on-prem in your local data centers, it's likely not like that. But yes, it is a standby instance whose storage and configuration are synchronized with a primary VM, but it is in an off state. In terms of authentication, you've got the easy and the hard way. I'm being a little bit simplistic and cheeky. Kerberos does HTTP authentication. You could also use certificates for HTTPS authentication. I say easy or hard. Easy because the Kerberos is just turnkey. As long as those servers can get to each other and can communicate on the proper ports, they're fine. The certificate option is going to require that you've got a public key infrastructure. I mean, technically you can use self-signed certificates, but that's not going to work in a production environment. Now, Microsoft engineered Hyper-V Replica to be as low overhead as possible. In other words, the barriers to entry here for protecting your VMs, pretty low actually. For instance, your VMs can be standalone or clustered. The VMs can be part of a work group or an Active Directory domain. So you could have your Hyper-V hosts being domain member servers and the VMs be workgroup servers. Those VMs and hosts can be running different versions of Windows Server. This is not a Windows Server 2022 technology. And then you'll see we can actually test failover, which I hope you and your team are doing regularly, to ensure that A, you know how to do the work, B, by performing fire drills, it should make the real production failovers less stressful, and C, it's a good practice anyway. Now let's take a look at a topology diagram that I've created for us that illustrates the Hyper-V Replica architecture. Got my drawing tools out here, so I'm going to draw right on the slide. Let's take a look. On the left-hand side, we have our Site 1 environment where we've got A Hyper-V host, we have a virtual switch. You know, Hyper-V has 3 types of virtual switch. It doesn't matter for our purposes which we're using. It's just that we know that our VM is in turn connected to the virtual switch as the host is. That Hyper-V virtual machine is running some version of Windows Server. Now we're concerned with all of the storage, the VHDs, the system drive, any data disks that you may have attached to the VM. And then there's the VM's configuration itself, okay? And all of that is going to be replicated. Now over here I have Site 2. Now technically this doesn't have to be another physical site, but it often is. If you have a wide area network or WAN cloud, you know, that's fine. I've never tested having the Hyper-V host in Azure, but it seems to me that as long as you have supporting bandwidth and a layer 3 connection to an Azure virtual network, I'm talking about a site-to-site VPN or an express route circuit, that would work just as well, actually. And that kind of brings up another subject that we don't need to go into. It's not mentioned on this part of the AZ-801 exam objectives. But there's also in Azure, Azure Site Recovery or ASR. And this is a cloud-based replication solution. And Microsoft hasn't published the details, but I suspect under the hood, ASR is using the same Hyper-V replica service that we're using that's built into Windows Server itself on premises. But anyway, the bottom line is we configure the target host to serve as a replica server. And I'll show you the step-by-step in the demo upcoming. But we're going to have an initial hit with replication depending upon how big those virtual machine, virtual hard disks are. In fact, Microsoft already thought of that and gives you as a hybrid cloud administrator the ability to put these VHDs somewhere else, specifically closer to the target machine. It's called an offline media option or an external media option. Very similar, actually, to when you're doing setup for an Active Directory domain controller and you have the install from media or IFM option. In other words, given that that initial replication may be sizable and your Site 2 and Site 1 may not be connected with enough bandwidth to support that in an efficient way, that's why you've got the media option. But anyway, ultimately you've got a state of synchronization happening between your primary and your replica. And then, as I said, you can conduct failovers, which would shift the workload over to the secondary. And then we can reverse the replication direction. And then when we fail over again, that's called a failback, although that term is not used in the user interface. We're just simply performing a second failover once the primary is back up and running. We're reversing the direction of the replication, to state it another way. Configuring Hyper-V hosts. Well, what are some things to keep in mind as we're setting up our Hyper-V replica environment? Well, we want to think of firewall rules. The good news is that Windows Defender Firewall has built-in rules for Hyper-V replica, both for HTTP and HTTPS. As far as authentication, if you're going to do certificate-based authentication, that's going to require a public key infrastructure. Conveniently, you can do this internally with Active Directory certificate services. Another configuration question is your replication interval. Now, what's going to go into this? Well, first, knowing the options. Every 30 seconds, every 5 minutes, or every 15. It would be a question of, number 1, bandwidth. Number 2, how chatty or how volatile is the server. Because the idea is after that initial replication, it will just be deltas or changes from the primary VM that need to be replicated to the secondary. And depending upon how active that primary VM is, that would lead you to choose the appropriate interval. And you can change that after the fact. Yet another option is the number of recovery snapshots you want to store. Remember that we've got volume shadow copy built into Windows Server, so we can generate application consistent snapshots of the VM state. And that's going to capture not only the state of the file system, but also the running state of applications and in-memory data. It's a good thing. Lastly, we have initial replication, whether you're going to do that via network or external media, as I mentioned a moment ago. I want to do really the rest of this work in demo. So you'll see that a lot of these slides, I'm just generating a screenshot that I want to talk over with you initially, and then you'll see how it works in the demo. I want to show you the perspective of server 1 here as my primary, and I've got a VM called Nest VM, as you can see. And when we right-click that VM in Hyper-V Manager and come down to replication, we can do a planned failover. Now, what's that? Well, a planned failover is going to be a fire drill, for instance. It's going to be testing your failover, or it's also when you need to take the host or the VM or it's going to be when you need to take the Hyper-V host down for planned maintenance. So you know in advance that you want to do that failover. Notice we can also pause replication, view replication health status, and remove the replication partnership, all right? Now, on the second server, the one that is configured as our replica host, when we right-click replication, there's some different options, failover and test failover. So bottom line is you initiate a real, not a planned, but an unplanned, I say real because normally a failover is something that you don't want to happen, so it's unplanned. So let me just change my language here. So failover and test failover. Failover is going to be for unplanned, and test is going to be for, as I said, fire drills, that kind of stuff. But the benefit of test is that you'll create a second virtual machine instance that you can experiment with, and it won't bother your production instance at all. In fact, you don't have to shut down the primary VM. You do when you initiate a planned or an unplanned failover. And then, of course, you can delete the test failovered VM over here on the secondary. Now, there's also another option that's specific to the secondary, to your replica server, and that is extend replication. I'll have more to say about that in a moment. Here again, I'm just generating a screenshot showing you the appropriate option. On the secondary or replica server, we go to the Hyper-V settings dialog, replication configuration. We enable this computer as a replica. We then choose our authentication. That's either going to be Kerberos TCP80 or certificate TCP 443, and you need to specify the certificate in that case. And then in terms of authorization and storage, you can either allow replication from any authenticated server and specify the default location to store your replica files, or you can allow replication for specified servers. So your need for security and least privilege authorization would guide your decisions really on this entire dialog. What is extended or chained replication? Well, we know that Hyper-V Replica involves replicating a VM from a primary to a secondary host. Extended or chained replication is where you have replication configured on the secondary to go to a tertiary host. Now, some things to keep in mind. First of all, why? Well, number one, it gives you another layer of not high availability, but disaster recovery. Because when you're doing extended replication, you could fail over from your primary to your secondary, and then even if your secondary host is going to be unavailable due to a planned or unplanned outage, you can fail over from the secondary to the extended or tertiary host. Now, something to keep in mind is that the volume shadow copy powered app consistent snapshots are not going to be available to the extended replica. This is because your extended replica on the tertiary host can only pick up what's on the secondary's VHD. Now, the secondary, hopefully, is receiving app consistent snapshots from the primary. Another issue is that you cannot replicate from the primary directly to the tertiary. But ultimately, the value proposition of extended replication, as I said, is that you get another layer of failover protection for your Hyper-V virtual machines. About Hyper-V failover, let's review the types of failover again. I had showed you kind of quickly in the previous slide, and you'll see it again in the demo, but let's formally go through. Test is for DR planning and verification. Here, Hyper-V creates a temporary VM with no disruption to the primary. A planned failover is used for maintenance windows. For scheduled maintenance, You initiate this on the primary VM. Unplanned is for unexpected events. This is initiated on the replica VM. Planned and unplanned both require that the VM is in a stopped state, so note that. All right, in this demonstration, I'm going to show you how Hyper-V Replica works. Now, both of my machines here are Windows Server 2022, but I just as well could have one, say, Windows Server 2019, and the other one 2022. But remember, please keep in the back of your mind that Microsoft does want you to learn as much as possible about Windows Server 2022. So you'll find there may be some stray references to Windows Server 2019 on the exam, mainly in upgrade questions, but by and large, we're dealing with Server 2022 as you would expect. All right, so this is my fs1.contoso.com member server. I also have an fs2. I've configured firewall rules appropriately to support Hyper-V Replica. And let's open up Hyper-V Manager and see what's going on here. I have a DB1. This is a Windows Server 2022 virtual machine that is running server core, as you can see here. Let's just dive into it for a second. Actually, let me do a Control-Alt-Delete and let me sign in. I joined this machine to the Contoso domain, as you can see. Let's see, I've enabled remote management. I've just configured this as a basic garden variety domain member server, and it's running server core for a minimum size footprint. All right, so that's the machine that we want to provide disaster recoverability for. And FS1 is our host. If we take a look at our switch settings, I have an external switch called nested internal switch. And then if we come back to Hyper-V settings, I want you to see this. This is important. My primary server is not enabled for Replica. This is important. I'm going to configure this on my FS2 box. So let's jump over there. All right, so we're on FS2 now. Let's bring up Hyper-V Manager. I've set it up the same basic way. If I go to Switch Manager, I have a nested internal. It's actually an external switch. So I'm going to change the logical name. Not that it's a big deal, of course. But in order to set up replication with FS1, here's where the money is. We're going to right-click, go to Hyper-V Settings, and we're going to configure replication. It looks like I've already done it. So I've enabled this computer as a replica, and I'm going to do Kerberos because I don't currently have a PKI set up. And then for authorization and storage, I'm at the time going to allow replication from any authenticated server. And I've got the path to where the replica files are. Now, this is a local path, but you just as well could specify either a UNC network path or a drive mapping if you want to centrally store those replica files on your LAN. Now, alternatively, you can allow replication only from specific servers. You would provide either a specific FQDN or, as this says here in the text, we could do something like star.contoso.com, which would allow from any server in that DNS domain. And when you do that, you also create a logical construct called a trust group. I'm going to leave the default setting that allows replication from any authenticated server. So let's click OK. Good. So now we're going to be doing some ping-ponging, actually. Now, technically, I'll try it. Sometimes I have glitchy problems when I try to do all my management separately, but I'm going to go ahead and do it here anyway. Why not, right? I'll live dangerously. I'll right-click the root node, and let's connect to FS1. Okay, that was pretty painless. And if we select our FS1 server, let's right-click DB1 and enable replication. All right, so we've got our welcome screen. Next, our replica server. I'm going to look up FS2. There's the NetBIOS name there. That's good enough. It resolved the fully qualified name. It detects that we're going to do HTTP. If you want to compress the data, you can leave that flag turned on. Next. This is going to enumerate all the VHDs attached to the VM, and you can deselect any you don't want to replicate. As it says here, like if you have a dedicated drive for a paging file. I'm going to select just the one. There's just the OS disk. Choose our replication frequency, as I said before. Next. This is asking you about, do you want to just have the latest recovery point, or are your business needs to where you may need a previous recovery point? Especially nowadays with this crypto locker nonsense, if your machine, your VM is a file server, and you get crypto lockered, you may indeed want to roll back to an earlier recovery point. So that's something to keep in mind, and notice that you specify coverage provided by additional recovery points, your recovery time objective, and your VSS snapshot frequency. And it looks like 4 is the default here. I'm going to just, in my lab environment, maintain the latest recovery point. We'll click Next. And then lastly, we have the question of, are we going to do our initial copy over the network, or are we going to do external media? And if we're going to do external media, where is it? Well, I'm going to go over the LAN. And I don't want to schedule replication, although that would work if I needed to do this maybe off hours or during a period of minimal usage on the network, or frankly, during a scheduled maintenance window. I'm going to do start replication immediately. Let's click Next and then click Finish. And replication's been enabled successfully. Let's see here. The network adapters for the Replica VM are not connected to any network. You can manually configure them for them. Okay, so if we click Settings, this pops open the nested virtual, the DB1 virtual machine, the one that's being replicated. And notice it says DB1 on FS2. And if I want to give it network connectivity, which I do, I will select the virtual switch on FS2 that I just specified a moment ago, I think. So let's click OK. So we see here that the DB1 is running as usual on the initial, the primary machine. And if we go over to the secondary machine, we can see that machine here, but it's in a state of off. And if we go to the settings, we can verify that that network adapter is hooked up to the appropriate vSwitch, as I mentioned. All right. If we want to take a look at rep status, we can do that a couple different ways. One way is we can right-click the virtual machine and do a View Replication Health. And this is verifying. We do want to see normal with a check. And then it tells us the statistics. It's relatively small because I'm running server core and there's nothing else installed on that machine. That's good. And we can save those statistics as a comma-separated value file if you want to. Now, I also, of course, can go to good old Event Viewer. I like to open the MMC consoles directly, eventvwr.msc. And the event log we're looking for here is going to be under Application and Services Logs, Microsoft Windows. And if we come down to Hyper-V VMMS, specifically the admin log, and this, we don't see anything. There's a warning from a little while ago. Auto-generating a self-signed certificate for server authentication. Oh, that's not directly related. The most recent one is that initial replication completed successfully. So in the name of troubleshooting, this is where you want to be. The Hyper-V VMMS log, particularly the admin log. See if there's anything else. Just informational stuff and network options, storage options, nothing yet. Okay, good. So let's finish this demo by looking at some failover scenarios. If we go back to the primary, go to replication, this is, remember, where we can do our planned failover. Let's start with a test failover. We initiate that on the replica. So on FS2, let's right-click the machine and go to Replication Test Failover. It says we can create a separate VM to verify that the recovery point is able to start. Now this drop-down would give us a list of all available recovery points. I have just the one. And when I click Test Failover, note that it just goes into action. We've got a virtual machine called db-test that's in an off state. If we go to its settings and look at the network, it's not connected, so we'll have to connect it to the network. But I like the fact that it comes up with a different name to avoid conflicts, and it also comes up not connected to a Hyper-V vSwitch, which is going to minimize the likelihood of any shenanigans happening with duplication. If I go back to FS1, I just want to verify that my primary instance is still running just fine. So that's the test failover. We could start this up, verify that it's working and running, etc., etc., etc. We can see down below on the summary screen. It may be small on your screen, but I can already see the logon, so it looks like it started up just fine. I'm going to go ahead and just turn that off, and I'm actually going to delete it. We don't need it anymore. So that is the test failover routine. Now, as far as the standard failover or planned failover, let's take a look at that next. Both of those options are going to require that the VM is down. So I'm going to need to shut down that primary virtual machine instance before I'm able to do either a planned or an unplanned failover. Okay, it's off. And now if I right-click Replication Planned Failover, we're going to start the replica virtual machine after failover. Normally, yes, that's what we would want to do. And because we want to fail back, we're going to want to reverse the replication direction. In other words, we want FS2 to become the primary and FS1 to be, at least temporarily, our replica. So I'm going to reverse the replication direction after failover as well. So let me click failover. It says that FS1 is not enabled to accept replication data. Aha! Well, there you go. That is something I simply forgot about. Now, what's that mean? Well, remember that when we initially set things up, FS2 was our replica. So we went into Hyper-V settings, replication configuration, and filled this out. Does it make sense now that we need to do that for FS1 in order to receive replication from FS2? So let's go back to Hyper-V settings, replication configuration, and I'm going to set it up the same way that FS2 is set up, with HTTP and replication from any authenticated server. Great. And here we see a standard reminder about the Hyper-V replica listener firewall rules. I don't need to see that again because I've already taken care of that. Now, where were we? We were doing a planned failover on the primary, weren't we? Yes. So let's go back to planned failover, reverse the replication direction after failover, and then hit failover. It's going to be a pretty fast process here, just a matter of seconds. And it says virtual machine on fs2.contoso.com has been started successfully. Great. So on the primary, it's off. On the secondary, it's running. And in a moment, there it is. Again, it's small, but I can see the screen. If you really want to see, if you're a skeptic like I am, we can make a connection. And there's press Control-Alt-Delete to unlock. So we've got that machine up and running. And just for grins, let's go to settings and make sure, yes, it's still connected to the nested external switch. Now, as far as a failback goes, let's go back to replication. We can view, we can do a planned failover in the reverse direction. And of course, we're going to want to set reverse again because ultimately we want FS1 to be our primary and FS2 to be our replica. So when I click failover, we get another error. Now, I did this one intentionally. This reminds us that the virtual machine has to be turned off for both planned and unplanned failover. All right? So let me cancel out. Let's do a graceful shutdown of that machine. And now let's do, in the reverse direction, a planned failover and specify a reverse of the reversal. All pending data has been replicated. Access the virtual machine on the replica server and choose the failover task in the replication menu to complete the process. Okay, so in this case, the failover server is FS1. So let's do failover, a real failover. And we're not going to reverse. It can be a little bit confusing. Again, this may just be me. With me, it's the majority of the time the problem exists between my chair and keyboard anyway. But sometimes it can be, if you remember Abbott and Costello, the old American comedians with their Who's On First, check that out on YouTube or Wikipedia. Abbott and Costello. I don't mean to give a Western-specific pop culture reference. I don't want to isolate anybody. But if you check that skit out, you'll understand what I'm talking about being confused about which direction are we actually going in here. Yikes. Well, let me see what's happening here if I don't reverse the direction. Virtual machine on FS1 has been started successfully. Yeah, so this, I think, is assuming that now we're back to FS1 being the primary and FS2 being the secondary. And so we can check event log. We can go back to replication and view replication health if we want to. The current primary is FS2, the current replica. Okay, choose reverse replication to resume replication for DB1. Yeah, it's in a warning state. So yes, I done goofed. So I've got some additional work to do. I'm going to spare you that work because I'm convinced you've got it down. But ultimately, I may need to horse around a little bit, going back and forth a little bit more with this replication stuff. But remember that you can always come back to view your health to get a quick check on who's the primary and who's the secondary. I should have hit reverse. That was my mistake. I should have done a reverse replication when I did that, and that would have sorted me out. Welcome to Lesson 15, Migrate Local Storage to Local Servers or Azure. We begin this lesson by learning how to use Storage Migration Service to transfer Windows Server file shares between on-premises and Azure environments. Next, we understand the Storage Migration Service cutover process. Then we'll review how to use Storage Migration Service to migrate local file servers to Azure VMs. And lastly, we implement Azure File Sync to migrate local file shares to the Azure File Service. This lesson is chock full of useful hybrid cloud administration skills, so let's get right to work. This lesson is concerned globally with ways that we can implement a hybrid cloud environment, that is, our on-premises Active Directory domain and our Azure AD-backed Microsoft Azure environment in terms of data and how that data then relates to your users and applications. Now, if you have 1 or 100,000 files in your local file server repository that you need to put up, say, into Azure Storage, how are you going to do that? There's always many, many choices. Kind of warms my heart from a historical perspective is RoboCopy. This is a command line file transfer tool that's been part of my life for a couple of decades, I think, at this point. Now, if you have more experience with Azure than you do with old compiled executables, then you might be thinking, Tim, wait a minute now, what's this RoboCopy? Is that different from AZ-copy? And the answer is yes, very much so. AZ-copy is also a compiled executable. It's cross-platform. It runs on Windows, Mac, and Linux. There's different builds, of course, for those platforms, but it has the same syntax. But AZ-copy is good for file transfers into Azure Storage and out of Azure Storage, but it's using the Azure Resource Manager REST API. By contrast, RoboCopy was born on premises, and it works with server message block protocol. So unless you have a site-to-site VPN or an express route link between your local domain and Azure Virtual Networks, RoboCopy is not going to be too helpful. Of course, RoboCopy would always be fine for on-premises transfers. AZ-copy is a born-in-the-cloud tool that does support hybrid cloud, and we're dealing with HTTPS with AZ-copy, so you don't have that issue with TCP 445 and server message block. An example of RoboCopy syntax here, this example from the Microsoft Docs shows how we can copy only updated files and folders from a source location to an Azure file share. Now, the good news is we don't have to know what every single one of those parameters means. I just want to give you the general flavor. Whereas nowadays, I think if you're similar to me, I think you'd agree that PowerShell would offer a much more consistent syntax than these old compiled executables that have their own sets of parameters. There's not much of any standardization here. But what's nice about RoboCopy is that you can create automation scripts such that you can do these file transfers on a schedule or just when needed. And they have quite a few options in terms of how you're handling that, in terms of retry logic and checksumming. AZ-copy is the same way. You just should know them both by name by the time you sit for your AZ-801 exam. The main technology that Microsoft would lead you to if you have, say, terabytes of data that you need to migrate from on-prem data centers into Azure is something like Azure Data Box. Now, if your business has terabytes of data that you need to transfer from local data centers into Azure, you could use AZ-copy or RoboCopy depending upon your connection, but many businesses don't have the time, the bandwidth, or the willingness to deal with all of the variables that could go wrong during a large-scale transfer. So we've got Azure Data Box. This is really where Microsoft wants to lead their customers if the customer has large-scale data migration needs. Now, Azure Data Box, it's mainly implemented as an offline transfer vehicle in which you rent one or more of these appliances. They're physical appliances. And you perform, depending upon the size of the appliance, you load it up with your data. The Data Box disk has 8 to 40 terabytes of capacity, and that just direct connects into your workstation. The Data Box and the Data Box Heavy have much bigger capacities, 100 terabytes and 1 petabyte respectively. Those have redundant, very high-speed, multi-gigabit LAN interfaces in them. So the idea is that it should make short work of taking your local data, you pack it into the Data Box and then ship it to Microsoft, and they'll unpack the contents according to your specifications. Now, if you're thinking, well, that sounds awesome, maybe for the bulk of our data transfer, the Data Box solution would be good, but we also have data that is relevant, it's volatile. Is there an online transfer option? And there are, actually. There's two. There's Azure Stack Edge, which is a physical appliance, and Data Box Gateway, that's a virtual appliance. Both of those are ways to stand up either, again, a VM or a physical piece of rack-mounted hardware at the edge of your local network. And you can essentially stream data in an online fashion from on-prem into Azure. And what's especially cool about the Azure Stack Edge and Data Box Gateway is that you can roll in Internet of Things or IoT type technologies like IoT Hub and Stream Analytics, such that you can perform transformations on the data as it's moving from your local data centers into Azure. Now, AZ-801 is not going to get into the weeds about Data Box, so let's just look at the high-level workflow. You start by ordering your Data Box from the Azure portal. Assuming it's one of the bigger ones, the standard or the jumbo size, you connect it to your network, power it up. There'll be a local web portal interface that looks a lot like the Azure portal that allows you to sign into your subscription and model how you want your local data positioned in your Azure subscriptions. When you're finished with the transfer, you return the device to Microsoft, they will unpack it, and then you verify the data transfer. Simple as that. I would say the centerpiece of this lesson is understanding storage migration service, and the specific use cases we're concerned with are situations like, mainly, you have local Windows Server file servers, and you have need to transfer the file shares to another machine. Maybe the source machine is just physically too old and you're going to decommission it. Maybe it's a version migration where your existing file servers are 2016 or Windows Server 2019. You want to be running on new hardware, a new version of Windows. Another idea is you want to reposition or lift and shift one or more of your local file servers directly into Azure and have them run as Azure Infrastructure as a Service VMs. What are the ingredients to implementing storage migration service? Well, you're going to need some compute power that orchestrates this work because, as you're going to see, storage migration service can actually go beyond simply transferring or migrating file shares. You can actually transfer the configuration of your source server and then have the destination server assume the identity of the source. It's pretty cool. This is what Microsoft calls the cutover process. And their guidance in the docs is if you're doing this at scale, you're going to want to have a separate machine set up as an orchestrator server. Otherwise, if it's a small environment like my lab environment, I'm going to use my source machine as an orchestrator server and just take the hit CPU, network, memory, and disk-wise that way. Another ingredient or requirement, really, is what I should have put on this slide, is Windows Admin Center. So here we see an example of Microsoft giving us net new capabilities where the main UI is in Windows Admin Center. Whether this marks a trend, who knows? We'll see. Now, the firewall ports that are involved should be no surprise. A Windows Server file server is going to involve SMB, NetLogon, WMI, and DCOM. Now, if you've got experience already with Azure, you're looking at some of those protocols and thinking, there's no way in the world we're going to open our Edge firewall on those kind of ports to go into Azure, let's say. If you wanted to do the scenario of migrating file shares and server configurations to Azure VMs, well, I'll have a little bit more to say about that momentarily, but you're absolutely right if that's what you're thinking. More about Storage Migration Service. Here's an attribution link at the bottom of the slide. This is a screenshot from Windows Admin Center. I really like it. I can't improve on it, so I figured I'd cite it. And let me walk you through the high-level workflow of using Storage Migration Service to migrate file server storage. The naming here, in my opinion, I could just be looking at it the wrong way, but it seems kind of unfortunate because when I first heard of this, let me bring my drawing tools out, storage migration, I thought that meant volume-to-volume synchronization. Of course, there's other technologies for that, like Hyper-V Replica if you're in a virtualization environment. But here, as I said, we're talking about transferring mainly your file shares, but potentially the configuration of the server, depending upon what you're doing on the destination side. So it's a more limited use case than what I originally thought it was. And the storage migration service workflow is 3 steps. First, we create a job and then conduct an inventory so that the service understands and can enumerate all of the file shares and configuration data on the server or servers. Then the bulk of the CPU work here that the orchestrator is doing is copying the file shares and optionally the configuration to 1 or more destination servers. And then third, this is completely optional, whether you want to do a cutover. Now, you don't have to. If you wanted to keep the original file server up, that would be fine. Don't do a cutover, but of course you'll want to decommission the shares that are on the source computer. Now, if you do decide to do a cutover, please understand that Storage Migration Service will not touch any of the files on the source server. It's just that all of the unique identity information and configuration data on that server will be applied to the target, and your original file server will be placed in essentially a maintenance mode where it won't support any new incoming app or user connections. Because the idea is that you're decommissioning that server. You don't need it anymore. You've cut over that server's identity to another machine that in all likelihood is running, say, Windows Server 2022 instead of a down-level version of Windows Server. Does that make sense? I don't have too much to say in this scenario. This is the use case where we want our target server, our destination server, to run as a virtual machine. And again, I'd want to presuppose a concern that you might have if you already have Azure expertise. And namely, why would I want to devote a whole VM to be a file server when the Azure General Purpose Storage account has a perfectly serviceable file service that allows us cloud scale with SMB file shares? And you're absolutely right, of course, but these are just options. And which way you go, of course, is going to depend upon your business requirements and trajectory and so on. I want you to see also that if you've used Azure to any degree in the past, particularly some of Azure's built-in migration tools, I want you to know that a lot of this storage migration service in Windows Server represents an overlay or an abstraction of related services in Azure, particularly Azure Migrate. So in this situation, although we're using a Windows Admin Center UI to migrate, say, 1 or more local file servers to Azure VMs, under the hood, it's Azure Migrate that's involved because Azure Migrate server migration is an Azure service that's devoted specifically to this use case. Now, the main thing to keep aware of in this storage migration service application is that you're going to need persistent OSI Layer 3 connectivity into your Azure Virtual Network. This means in order to do a migration to an Azure VM, you're going to need either a site-to-site virtual private network or an express route tunnel. And that hopefully makes sense because of the protocol requirements that I mentioned earlier. In this demonstration, we'll take a look at migrating file shares from server to server using Storage Migration Service. So to set the stage here, I'm on a file server called FS1, and just let me hit up /FS1, and you can see I have two shares on this machine. One called scripts that has some automation scripts, another share called docs that just has some Office type applications. So it's just our example. We can migrate one or both of them, and we also want to think about cutover, whether we may be interested in that or not. We're going to need Windows Admin Center here, so you can see I've got this server, fs1.contoso.com, set up as a gateway, so we can centrally connect here, and I've also used the add wizard to bring in my FS2. Now, both of these happen to be Windows Server 2022 member servers. You should know that Storage Migration Service is not supported on domain controllers. So our source is reasonably enough going to be FS1, and our destination is going to be FS2. So let's connect to FS1, and let's look for Storage Migration Service. So let's give that a click. Now, one of the things I like about Windows Admin Center, it's just that it's so responsive from a web standpoint. In other words, these capabilities or these tools are implemented as extensions. And as you can see in the banner, we can realize the latest bug fixes or enhancements or stability improvements to an extension. Here, I'm just going to click Update Now. And that takes us over to the Extensions blade, where I can do a search for Storage Migration Service, and then click Update to update the extension. The Windows Admin Center interface will refresh once that extension is updated. So let's now come back to our server manager and come back into FS1 and come back into Storage Migration Service now that we have the latest and greatest version of the extension. Now, don't mind the text here. The fact it says migrate servers and file shares to Azure or Windows Server 2019 without requiring apps or users to change anything. Now, yeah, it looks like the engineer must have forgotten about 2022. That's all that is. Let's click Install. Maybe that bug will be fixed by the time you're watching this training, and then you verify yourself. Now, under the hood, Windows Admin Center is installing the Storage Migration Service feature on this server. And then let me zoom out a little bit because the zoom was kind of blocking the view a bit. Here is our overview page. And we can come down to the bottom here and create a new job. Oh, and I thought we had a new job dialog, but I guess not. So let's create a new job, and I'll call this File Share Migration. Looks like no dashes, only alphanumeric. And notice that the source devices, because we're concerned only with Windows Server for AZ-801 and AZ-800, that's all I'm focusing on. But notice here that one of the value propositions here of storage migration is that you can take file shares that are either on Linux machines and or NetApp storage arrays and migrate them to Windows Server. So this is just one of really three possibilities for this technology. All right, let me collapse the tools so we have more space to look. And if we look here, we've got across our top, we've got our three stages that I already told you about: inventory, transfer, and cutover. And then we can see our sub-steps right here, including the prerequisites, letting us know what we can migrate from, all the way back to Windows Server 2003, interestingly enough. It mentions here that domain migrations or cutover to domain controllers is not supported yet. Let's click Next. I'm going to provide some administrative credentials here. Doesn't like UPNs, interesting. So let me try old school. I guess it makes sense when you think about the history of server message block and DCOM and WMI. Those technologies would much more appreciate or understand an old Windows NT style username. I guess that makes sense, like I said. Are we going to include administrative shares? No. Are we going to migrate from failover clusters? No. So let's click Next. I'm setting this machine up as an orchestrator server here, so it says hang on while we install features on it. All right, add and scan devices. Let's click Add a Device. And it's device because we could bring in NetApp appliances. I'm going to do an Active Directory search for Windows Server. fs1.contoso.com is our server name. So let's select, click Add, select, and validate. We have a pass here, and if we take a look, my orchestrator, which is this machine, is getting a warning regarding CPU, but that's all right. I just have those 2 shares. Everything else looks like it's a pass. And now we can open the menu and click Start Scan to conduct our inventory process. And we're going to need to do that, of course, before we move to transfer. Now, the save and exit will keep all of your decisions that you've made thus far, and then you can revisit by going back to the jobs list and coming back into it. But at this point, we're just at step 1 of at least 2 here. I don't think I'm going to do a cutover in this demo because I'm going to need this FS1 in the future. All right, as expected, it didn't take long. We've just got under 10 megabytes of data consisting of 84 files. And we can peruse the device metadata down below. Now, I chose to include administrative shares here, but I didn't have to. The main ones are our docs and scripts resources that we can click in and view some metadata here. It's looking pretty good so far. Our config and SMB scan. Okay, yep, looking good. So let's click Next to proceed to step 2. Now, I'm using domain administrator credentials that will work on both my source and destination servers. So let's click Next. We have our required features on the orchestrator. All right, so on the transfer step, let's take a look over here. We have our credentials, then we choose our share. First, we do our credentials for the destination device. Again, I'm going to use the old school NT format, Contoso Tim, and then my password. Let's click Next. And what is the destination server? This is an important step, as I've already taught you. We can do a new Azure VM where the service will provision a virtual machine and a virtual network. But what I'm going to do is a local operation where I'm going to use an existing server or VM, and that one is called fs2.contoso.com. Let's hit scan. And I just have a 1-to-1 mapping. I have 1 volume on each server, C, as you can see. And then we can choose which shares we want to transfer. I want to grab docs and scripts, but not the administrative share here. Looking good. Okay, so let's click Next. Here we have some duration and metadata and validation. Are we going to migrate users and groups from the source server? And that actually would be important in terms of access control lists and that kind of stuff, the user and group entries. Retry logic, I'm just going to leave all of those at the default setting. Now, the required feature that's necessary on the target server is the storage migration proxy. I've actually already installed it, so I shouldn't have to worry about it here. I'm going to authenticate on that machine just to be safe. I'm going to use the old school syntax again. And click Continue. Yeah, so the proxy's already there, so that took a moment. So next we've got validate source and destination devices. All right. Let's select FS1 and validate. Got a warning on that. I already knew that that was about the CPU core issue. All right, let's click Next. And I think we're ready to start the transfer. What do you say? Let's start the transfer. This, again, shouldn't take long given the small number of files I have. Yeah, that took just a moment. All right, so we can see down below processed files, process size, succeeded. We can see some transfer detail here, some server message block detail, and we haven't covered Azure File Sync yet. We'll do that next. Now, if you want to cut over to the new server, that's what this third step is all about. I don't actually want to do this because I don't want FS2 to be overwritten and to become FS1. I want to keep FS1 exactly as it is, but I can run a quick verification. If I do a /FS2, we can enumerate the shares. I'm going to have to make sure we can enumerate the shares on FS2, and as you can see, docs and scripts are over there with their accompanying files. Now, because I haven't done a cutover yet, I've got a problem because, as you can see, I can also hit FS1. So I'm going to want to decommission these shares very quickly on FS1 so I don't cause any additional confusion. Now, that would be if we were doing the cutover. So what I'm going to want to do is decide whether I want to keep the FS1 shares in place or not. Probably not. But then again, if we want those shares to exist on FS2, we need to either update all references to the share path, or we could complete the cutover, which would force us to decommission FS1. Choices and choices and choices. Welcome to the life of the Windows Server Hybrid Administrator. So let's end this lesson with a consideration of how we can leverage Azure File Sync specifically to back up multi-site shared folders to Azure Files. Now, Azure File Sync, I'm a big fan of this service, and I'm grateful to say I was involved in a small way with the service's development. I participated in the beta and pre-beta preview term of this service, so I know quite a bit about it. The way it was engineered is so intelligent. It's going to serve as a great alternative to the storage migration service if you're looking to host your file shares in Azure. You don't need to worry about virtual machines. You can consolidate shares from multiple servers and multiple sites because, we're in an Azure global cloud. And what's more is that Azure File Sync will keep the files synchronized between your on-premises file servers and the storage account in Azure. However, this technology, Azure File Sync, or AFS for short, is not at all like OneDrive. It's not an end-user tool, all right? This is a back-end service that's meant to help you as a hybrid cloud Windows Server administrator. Now, some of the benefits that you can realize by implementing Azure File Sync provides a convenient way to back up your local file shares to cloud storage. It would happen in 2 steps. Step 1 would be Azure File Sync will synchronize your local file shares into the storage account. And then 2, you can deploy Azure Backup Vault to configure scheduled backups of your file shares. Very nice, very convenient. As I mentioned, Azure is a global cloud, which means you can use a single Azure File Sync service instance with one or more what are called sync groups, more on those in just a moment, to separate or consolidate shares across your sites. If you found that you've got a spaghetti bowl, as it were, related file shares, you can put them together in one sync group. Or just the opposite, you want to decompose shared data. It's just totally, the topology is totally up to you and your business. And I know I've repeated that quite a bit. Another neat feature of Azure File Sync is tiered storage, where your concern may be, I'm running out of disk space, free disk space on my file server. Well, with AFS, you can mark out a percentage of that data volume that you need to be open, and Azure File Sync will create a heat map based on the volatility of those files, and files that have not been so frequently used will be offloaded to the cloud. Now, the files will still be referenced in directory listings. They won't just drop off the face of the earth, so to speak. But what users see and what applications see in directory listings is basically a pointer. And when the user or application requests the file that's been tiered into the cloud, there'll be a recall process where Azure File Sync will download the file back to the local server. Pretty convenient. And lastly, we've got a highly available disaster recovery solution. Let's say our main file server in our headquarters location went belly up. Doesn't have to be that much downtime actually, because we literally could install the Azure File Sync agent on another server, connect to that sync group that the failed server was a part of, and download the files and make them available again. Now, of course, depending upon your bandwidth and how much data is in the share, that would be the main potential for latency. But that's a really convenient way to implement DR. Now, lastly, the cherry on top of the sundae, so to speak, is, as I started by saying, that Azure File Sync isn't for end user use. They don't even know that you're using this as an administrator. And the beauty is your users and applications on-prem will continue to interact with their local file shares the way that they always do. So that means no drive mappings, no changes to roaming profiles and work folders. All of that stuff continues to work, but you're realizing a whole lot of cloud benefit. Now, let me bring out my drawing tools again and walk you through. Actually, let me get rid of my drawing tools because I just remembered I have some annotations here. This is a diagram I created to show you the different parts and pieces that make up an Azure File Sync solution. First, you start with an instance of the sync service, the storage sync service. You may need only one of those because within that sync service, you then create one or more sync groups. What is a sync group? A sync group has two components in it, one and only one cloud endpoint, and that maps to a single file share in one of your storage accounts, all right? And then on the other side, locally, you install the Azure File Sync service agent and then handshake or connect those servers into the sync group as a server endpoint. Now, all the communication here is encrypted, HTTPS, so it's occurring over firewall-friendly TCP 443, so there's no need for either a VPN or an express route circuit. Isn't that great? So without any further ado, let me show you how this works in practical application. In this demonstration, we'll work with Azure File Sync. You'll see this is a pretty nice alternative to storage migration service. I'm going to stay on my FS1 file server, which, as you already know, I'm quite sure, if I do a /FS1, consists of a couple shares. Let's just say that we're going to start small and we're going to work on this scripts share, and we're going to put this up in the cloud so we can start to take advantage of these administrative scripts in the cloud, and we also would have a nice cloud backup destination and all the goodness that I've explained that Azure File Sync brings to the table. So what we'll want to do is go into the Azure portal, and we start by creating an instance of the storage sync service. And you may just need one of these, but because they are regional, as you can see down here, that may be a case where you have more than one service, depending upon your footprint around the world, you see. I already created an instance of the service, so I'm going to come out of there, and let's go into my Contoso sync service. Say that 3 times quickly, by the way. And let me walk you through how we set it up. If we come down under sync, we create one or more sync groups. Now, we have to remember that a sync group consists of only one and only one Azure file share. And that file share actually has to already exist. So I'm also going to want to open up another browser tab here before I forget. And let's go to the storage account that I want to use in this case, which in my case is timstorage001. And let's come down into file shares, and let's create a file share right now. I'm going to click File Share, and let's call this Local Scripts. And I'm going to leave all of the file share properties at the default there. If you haven't worked much with file share service, it's very convenient. As you can see, if we click Connect, you'd be able to create a drive mapping on Windows, Linux, or Mac OS. Now, this is going to be relevant in a hybrid cloud scenario only if you have an express route or a VPN because of the SMB issue, but it's really easy to consume file shares that are in Azure. So if you've got an Azure virtual machine, it's a lot easier because you're already up in the Azure backbone network. All right, so let's create a sync group. I'm going to call this one Scripts. And notice here we're immediately prompted for that file share, like I said. So we're going to select the storage account, timstorage001, And the file share already has to exist, as I mentioned before. That's local scripts. And we'll click Create. And now we have a healthy scripts sync group. Well, let's come into that sync group. And you can see it'll take a little while to show up here. But we're going to see that Azure file share. It's showing up as provisioning right now. We just have one of those. And then we can have one or more server endpoints, as you see down below. Now, in order to create your server endpoints, you need to download the software. Let me step out into the sync service, and if we come down to registered server, there's a download link. It's called the Azure File Sync Agent. Now, unfortunately, that agent is an MSI, so it's going to assume that your on-premises servers are Windows Server only. So please understand that, but it's not a concern for AZ-801 for obvious reasons. I've already downloaded that agent to FS2. I'm going to grab it off the C drive there. So let me do a /FS2, and let me see. /FS2 $C$, and let me go into users, Tim. I think I put it on the desktop. Here it is. So let me copy this MSI to my local desktop, and let's run it. It's called the Storage Sync Agent, and it's just a Windows service. It's got a little UI to it, and what I really like also is that it can be updatable through Windows Update. I don't have any proxy. Yes, I want to use Microsoft Update. We'll automatically update during our next maintenance cycle, and I'll allow data collection. Okay, pretty easy installation, as you can see here. And you're going to install this on each of your local file servers that you want to participate in Azure File Sync groups as a registered server endpoint. When that finishes, the UI should come up automatically, but yeah, it does. As you can see, we have an Azure Storage Sync Agent Updater utility here. So let's sign in. As you can see here, it's either the Azure Public Cloud or a government cloud. I'm not a cloud solution provider, so I'll just go through the auth flow here and sign in with my Azure Active Directory Administrator credential. Hopefully I'll type my password correctly. Once I pass authentication, I'll choose my subscription, my resource group that my storage sync service is in, and then my storage sync services group will click register. And that should do it. Remember, all of this is taking place on TCP 443, so we don't have worry about asking our network support team to open up firewall exceptions and that kind of stuff. All right, it tells us we can use either PowerShell or the Azure portal. Network connectivity test passed, so we're good. So let's come back to our sync service. Let's go to sync groups, scripts, and now for server endpoints, let's click Add Server Endpoint and select our registered server from the list. Now, the catch here is that you have to specify a local path, not a universal naming convention path. So I have to remember where my shares are. I think I put them, yes, on my C drive under shares. So my local path to that scripts shared folder is actually, let me paste that in here, C shares scripts. And here I'm getting caught here. It says, please note that you will not be able to enable cloud tiering on the system volume. Darn, that's a bummer. I wish I had had a data volume ready to do that. But anyway, if we were on a data volume, notice that we've got cloud tiering. And if you turn that on, the UI allows you to always preserve a certain percentage of space. That's going to determine how aggressive the offloading or tiering is. And then you can specify a date policy that to only cache files that were accessed or modified within a specified number of dates. So those are both ways that you can adjust the aggressiveness of cloud tiering. And then we've got initial sync. How are you going to handle conflicts and that kind of stuff? And then when you're ready, you can click create, and that will create the endpoint. And we can always come back and modify that in time, of course. But that's pretty much all there is to it, honestly. As you can see in the sync group, we have our Azure file share, and if we just come in here, it's basically just showing us metadata. And if we come in on our server endpoint, it does allow us to make configuration changes. And it also, here it is right here, files not syncing, cloud tiering, offline transfer, and it shows us some metrics charts. We're going to want to pay attention to that to see if and when those files sync up. So I'll keep that metrics chart on the screen and wait for the health of this server endpoint to go into a ready state. After a couple minutes, the health status has changed. I'm going to need to do another refresh here. I want to see the metrics chart pick up, because we should find within moments that the files from the local share come up into our local scripts file share. Let me do a hard refresh over here as well. There they are. So we can see that those local files have been now transferred, not transferred, but synchronized, such that they're available both locally as well as in the cloud, even if the metrics charts haven't yet fully refreshed. Welcome to Lesson 16, Migrate On-Premises Servers to Azure. This lesson opens with our understanding the Azure Migrate server migration environment and deploying the Azure Migrate virtual appliance. We'll then migrate both virtual and physical workloads to Azure by using Azure Migrate. Finally, we'll wrap up with some real-world Azure Migrate tips and tricks that'll help in your own workload migrations. Let's get started. What is the use case of Azure Migrate? Well, it's actually a unified tool set for several types of workloads. However, this part of the AZ-801 exam objectives deals specifically with server migration. And so we're concerned with assessing, replicating, and migrating Windows Server and/or Linux hosts from either other clouds or, let's just assume, your on-premises data center environment. And you see that correctly. Windows Server and Linux are fully supported in Azure Migrate server migration. Going further, you can migrate both virtual machines, as you'd expect, I guess, as well as physical machines. Azure Migrate can do P2V translation, or physical to virtual conversion. Azure Migrate server migration covers both Microsoft's own Hyper-V hypervisor as well as VMware. You should know as a requirement that your VMware, if you're going to migrate those workloads, you have to have your ESXi servers orchestrated in a vSphere environment. That's a requirement. Speaking of requirements, a common question for the Azure Migrate team at Microsoft is, do we have to have a dedicated connection to Azure? And the answer is no. Azure Migrate operates on TCP 443, which is a firewall-friendly protocol, and the encryption happens with TLS. So we don't have a dependency on either an Azure site-to-site VPN or an express route circuit. There are both agent-based and agentless topologies. Specifically, the agentless design is engineered for VMware workloads, for Hyper-V workloads, and VMware VMs for which you don't mind deploying an agent. The Azure Site Recovery, or ASR engine, performs the underlying replication. If you go the route of agentless migration for your VMware environment, then Microsoft uses a separate replication engine and a component called the Mobility Service. Now, of course, AZ-801 deals with Windows Server and deals with Microsoft products. So in the demo, I'm going to stay strictly with Hyper-V, and you'll see that we do install a small agent on our Hyper-V hosts. But it's not too arduous. What is this Azure Migrate appliance? Is this something you have to buy? No. It's a pre-configured Windows Server 2016 VM that you download from the Azure portal. You can get it in VHD format if you're using Hyper-V, or OVA format if you're using VMware. It's running on an evaluation license, and it's responsible for the actual discovery and assessment. Specifically, when you turn your Azure Migrate appliance loose on your local environment, the Migrate appliance reports on Azure readiness. Are these detected machines ready for Azure? Are they capable, or do they have features that don't meet requirements, or features that can't be translated into Azure analogs, that kind of thing? Azure Sizing deals with recommendations the Migrate appliance will give as far as VM size. That's a common task of the Azure administrator, isn't it? Right-sizing your workloads, making sure that your virtual machines are sized enough to give you appropriate return on investment. Speaking of return on investment, the Migrate appliance will also generate cost estimates. You can even perform dependency analysis, although this requires a little extra software. Specifically, dependency analysis involves the service map capability of log analytics. So you'll have to have a log analytics workspace and then deploy the log analytics agent to your on-prem machines. But the benefit is that you can visualize the dependencies on the VMs or physical servers to be migrated. So you don't wind up with that situation where you left a critical dependency behind after migration. You don't want to find out after the fact, that kind of stuff. Let's go over the top-line procedure for using Azure Migrate Server Migration to migrate on-premises machines into Azure virtual machines. Well, you're going to start by creating an Azure Migrate project. We can do this in the Azure portal, and I will do a demo on this afterwards. You'll want to download and install and set up the Azure Migrate appliance. The appliance does not have to join your local Active Directory domain services domain. It can be a workgroup machine, but you do, of course, want to attach it to your network, and there are some networking protocol requirements, etc., ports and protocols. It's nothing too severe. With Windows specifically, we're talking about port 59. We're talking about TCP 5985 for Windows Remote Management, or WinRM. Once your appliance is running, you'll sign into it, and you'll handshake into your Azure Migrate project using credentials that you'll get in the portal. I'll show you how that works. You then run a discovery and create an assessment. How do you do that? Well, you sign into Azure, so you've got RBAC permissions in Azure. You can create credentials as far as what will be used when Azure Migrate spiders over your network and starts enumerating your Hyper-V hosts, your ESXi hosts running under vSphere, and ultimately examining your virtual machines. You then configure replication, and the great beauty here is that you can take your output, that is your assessment that lists which machines are suitable for Azure, and you can tweak the assumptions that you're going to make when it comes to getting a price quote. If you want to use reservations, for example, as opposed to pay-as-you-go. If you want to use the hybrid use benefit, if you know in advance which virtual machine sizes are authorized, so you can pass those as arguments and have Azure Migrate factor those in, and you get the final say, of course. But you configure replication, and this is important because we're not going to have a significant amount of downtime. You want to have your on-premises or local machines synchronized with Azure-based analogs, such that when you press the migration button, it's basically like doing a failover. If you've used Azure Site Recovery or ASR in the Azure Recovery Services Vault to do disaster recovery using failover, I think I actually mentioned it. When you're using VMware with the agent-based option or the Hyper-V migration option, ASR is actually the underlying replication engine. So when you perform a migration, it is in fact performing a failover. It's just that we're not going to fail back to the source environment like we would with ASR. Very last step is we want to verify that the migrated virtual machines are functional and connectable, and we'll want to leverage monitoring tools in Azure to look at cost, performance, security, availability, all that good stuff. This is a novel idea. Virtual machines were designed and originally architected to be portable out of your data center into a cloud or from one data center to another. When you have legacy servers, or maybe not so legacy, but nonetheless bare metal hardware servers, we have questions, or I had questions originally. Well, how could I possibly get this physical machine virtualized and into Azure? What's required? Well, if you're going to use Azure Migrate, you can do that. However, you should know that neither Windows Server 2003 or SUSE Linux are supported. Now, it's probably an edge scenario because I hope you've long since moved beyond Windows Server 2003. Just wanted to mention that for the sake of completeness. Now, the assessment types that you can do, this part pertains not only to physical server assessment, but also VM assessment. You can tell Azure Migrate to do an as-is on-premises assessment or a performance-based assessment. The first, as-is, is where you want your Azure virtual machines to run as closely as possible performance-wise to how they do on-prem. This is good if you've already spent a significant amount of time tuning and tweaking your on-premises servers and specifically tuning them to the workloads that they serve. Performance-based, you get the best recommendations from Microsoft when you allow the assessment to run over a longer period of time. Hopefully that makes logical sense, because that way Azure Migrate can get a good picture of the server's performance during peaks and valleys, all right? So those are the two assessment types, and you can absolutely do multiple assessments. You can do an as-is on-premises and a performance-based. You can adjust all of your assumptions and you can make overrides. Remember, you as the customer are in control here. Now, specifically, if you're going to do a physical server migration to Azure, this is going to require a separate replication appliance virtual machine that you'll bring down into your local environment. You want to look this up in the Microsoft docs for more detail. Other than the presence of an additional appliance, the basic UI is very similar, regardless of whether you're migrating physical or virtual servers. Before we get into the demo, let's finish up with some notes that I want to leave you with. One would be something you can find in the docs. Of course, you can find all this information in the MS docs. Is that according to Microsoft, their appliance limits on a single Azure Migrate appliance are 10,000 VMware servers, 5,000 Hyper-V servers, 1,000 physical servers. As I said, when you're doing a performance-based assessment, the longer you let Azure Migrate assess, the higher confident results it'll give you. You'll see in the demo that the assessment results have a confidence score, and if you do a very quick assessment, you're going to have a low confidence. If you let it run over potentially days or weeks, maybe even, you're going to give Azure Migrate a lot more data to go on and give you high confidence recommendations. Again, I want to repeat that monitoring here is crucial for cost, performance, and security management. And the specific tools in Azure I would have you look at first would be Azure Monitor and Log Analytics, paying particular attention to the Insights area of Azure Monitor. And then there's Microsoft Defender for Servers, which you get a license for when you onboard your Azure virtual machines into Microsoft Defender for Cloud. Now let's get into the demo, and I'll walk you through this whole process. You're looking at the desktop of a Windows Server 2022 machine I have in my on-premises environment. It's a domain member server named Local Hyper-V 1. And if I bring up Hyper-V Manager, you can see I have a very simple lab setup here where I've got just a single virtual machine called Nested VM1. And if I jump into virtual machine connection on it, you can see that it's just a garden variety Windows Server 2022 machine set up with some additional software packages, etc. So that is the nested VM that we look to migrate into Azure, all right? So again, to sum up, in my on-premises environment, I have a Hyper-V host named Local Hyper-V 1, and I'm interested in migrating this nested VM1 that's running on Local Hyper-V 1. Got it so far? Okay. Switching over now, this is what the Azure Migrate appliance looks like. And as you can see in the lower right corner, it says Windows Server 2016 Data Center, Windows License Valid for. I tried to activate the appliance, and it's administratively disabled. Microsoft must not want you to have the Azure Migrate appliance for longer than that time period. But you'll find when you stand up that virtual machine in your environment, there's a shortcut on the desktop for the Azure Migrate Appliance Configuration Manager. Now I'm getting a little bit ahead of myself here because I haven't actually shown you how I downloaded that Azure Migrate appliance. Your work is going to begin and end here in the Azure portal. So I'm signed in as an administrator, and I'm going to go to Azure Migrate. And what I want you to see first of all is that Azure Migrate is a consolidated migration host. And we have a number of migration goals here. Each one has the same basic pattern for the most part. Databox is an exception. Databox is where you have a large volume of data that you want to get into Azure. You can basically rent a hardware storage device from Microsoft, fill it with the data, ship it to Microsoft, and they'll unpack it in your subscription. There's a web app flow here, there's virtual desktop infrastructure, there's databases. All of these are similar in as much as they have an assessment phase and a migration phase. For server migration, we come up here to servers, databases, and web apps. And the user interface isn't the best, in my humble opinion. You can have multiple projects, as you see in this projects pill that I opened. But if you want to start with a new server migration project, it's just a question of giving it a name and a geography, and then you add your assessment and migration tools. The project I've been working on, I've already got a migration almost complete. I wanted to do the work on the front end to show you what it looks like, and I'm going to describe how I set it up, all right? So first you have your project. Mine is called Hyper-V Migration. And initially, the assessment tools and the migration tools are empty. I haven't, when you start, you're not going to have anything. And you choose your tools. See, add more assessment tools. The tools are going to, of course, lead you by default to Microsoft tools. Specifically for server migration, you'll use Azure Migrate server migration tools. If you're doing a database migration, there's a different set of tools. And there's some third-party partners that Microsoft has as well that you can use. Of course, for the exam, Microsoft's not going to ask you about any third-party tools. So for this server migration project, Hyper-V migration, I'm using only the Microsoft native Azure Migrate tools. So as you can see here, we have discovery and assessment, and then we have migration. Now, again, initially this is empty, and you start with Discover. And what you do is you can either use the appliance, which is the preferred way to go, or you can download a comma-separated value file that's a template. And that's just meant if you already know the metadata, the basic stats of your on-premises servers that you're looking to migrate, you can just fill out that CSV file and just expedite the process. But as this note says here, it says that use CSV to get a quick assessment on cost and compatibility. But for accurate assessments, you should use the appliance-based discovery, and that's what I recommend you do. So when you use the appliance, you answer the question, are your servers virtualized? And there's 3 paths you can go. VMware, orchestrated with vSphere, Hyper-V, or physical. And notice if you're migrating from other clouds like AWS or Google Cloud, you go the route of physical or other. Now, I went Hyper-V. So what you do here is that you generate a key that is basically an API key that handshakes your appliance into the project. I've already generated the key. Once you put your appliance name in here, you generate the key, and then you download the VHD. It's about 12 gigabytes, as you can see. All right, so, and then it says set up the appliance, configure the appliance, and initiate discovery, and then wait for the appliance to do its work. So that's the front end of things. So if we come over here, this is what the appliance configuration manager looks like. As I said, when you log into the appliance, you double left click this if it doesn't start already, and it's just a simple ASP.NET web application. And what you've got is, first of all, it runs a prerequisite check, specifically doing a time sync with Azure and updating the software to any latest updates. It's nice that it doesn't auto-update for sure. In step 2, you register with Azure Migrate. Now this is where you're going to take that generated key and paste it in here, and then sign in with your administrative credential. That will register the appliance with your Azure Migrate project. Next, you can create 1 or more credentials for discovery of your target environment. Now I'm looking at Hyper-V VMs, but it's basically the same for VMware as well. You just provide your vSphere administrator credential. But your credential in this case is going to be just Hyper-V host or cluster. You give it a friendly name, username, and password. And then you're going to map those credentials to your discovery source, okay? And when you do that, you can add a single item, you can do a list of multiple items, or you can even pass in a CSV file. And again, they give you a template to make sure that it's formatted correctly. And I just put in the DNS name of my Hyper-V host. Notice that the discovery is going to happen on the WinRM port, TCP 5985. So you want PowerShell remoting enabled on all these servers. And then you hit validate. and you want to have the status show as validated, almost finished, then you just start discovery. And what will happen is that on TCP 5985, the Azure Migrate appliance is going to go through all of your discovery sources, mapping in the appropriate credentials, and generating a report that you can surface up here in your Azure Migrate project. As you can see, it gives us right on this page, discovered servers, OS distribution. You create logical groups of servers, because likely you're going to do migration in waves or batches. And notice that we've got one Azure VM candidate detected, and that's the one that we were just looking at, as a matter of fact. If you're going to do dependency analysis, we can add the servers in here. Again, that requires some additional work. You have to load the log analytics agent on your VM and on your Hyper-V host, and then it's going to have to update. So that's why I'm not able. I did install the log analytics agent, but I have to wait for the next validation cycle before I'll be able to select it. Again, that just would allow us to do another assessment, this time taking into account service map dependency analysis. Basically, what dependency analysis shows are the services and processes running on that server, but also the ports, protocols, and IP addresses that are connected to the server as clients, as well as the ports, protocols, and IP addresses that the server is connected to itself as a client. Useful info, like I said. All right? Then when you're ready to create an assessment, notice that you can model your assessment in 4 different ways: as an Azure VM, Azure SQL, App Service, or VMware solution. We're going to do Azure VM. And when you create your assessment, you choose the assessment type and then the discovery source, which in my case is the appliance. And then here, Edit on Assessment Settings, this is where you can adjust your assumptions. What is your target region? What kind of storage are you looking at? Do you know in advance? Are you going to do a reservation or no? What kind of sizing are you looking at? Are you going to do performance-based or as on-premises? And if you're going to do performance-based, how much performance history? So you can do 1 day, 1 week, and 1 month. And as I said earlier, you're going to get better results doing a week or a month than you are with day. You can pre-select virtual machine series. Comfort factor is kind of a strange metric. It's nice that each one of these elements has a tooltip help that you can use. What kind of offer or licensing are you using? Enterprise agreement, whatever. What is your expected VM uptime? Are you going to do hybrid benefit? Those are all assumptions that go into your assessment. So then you create your assessment and let it run. And once you've got it, you can take a look at it. We can get to the assessment results by going over here to Overview. Here we can see we have one assessment. We've got one machine group I created with the one virtual machine in it. Let's first of all go over to Assessments. I created an assessment called Hyper-V Assessment. And if we go in and take a look at it, it gives us some Azure readiness. It looks like my VM, my nested VM, is ready with conditions. Gives us a monthly cost estimate for the VM and its storage. And then some modeling down there. Again, we can edit the properties. It looks like the confidence rating is low. Now that's expected because I did the shortest possible assessment that I could. All right. So if we go into assessment details, it just presents some additional info here. Specifically, what kind of VM size is being recommended? What is the detected operating system, boot type, disks, etc., 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 metadata. And then we have some additional, this is basically what we saw on the home page, cost details. Okay? So this is all useful metadata for sure. So we can get to all of our assessments in one spot. Okay, where do you go next? Well, let me go back to the project first of all. Here we are. Once you've completed your discovery, optionally your dependency analysis, and you've generated and tweaked at least one assessment, you're ready to come down here to migration. And this is going to consist of 3 steps. First, discover. In the discover process, we choose what our source environment is. In my case, it's Hyper-V. And this is where you need to install the agent on your Hyper-V host. So the Hyper-V environment has you downloading a little service called the Azure Site Recovery Provider. and you'll need to use the installer, and then you'll get a registration key file right here. This is the key file download link, and that's the download link for the exe. Note that you don't have to install the Azure Site Recovery provider on every VM. It's just the Hyper-V hosts. And that's going to allow, it's the agent that allows that replication to take place on those VMs. Now, if we went the route of VMware vSphere, are we going to do agentless or agent-based? And if we're going to do agentless, we're going to download Azure Migrate appliance and set it up and use it that way. If we're going to do agent-based, there's a couple more choices down here, replication appliance, etc. We don't have to get into the weeds of all these. Again, I'm staying pretty faithful to Hyper-V environment because we have to keep remembering that this is a Microsoft exam. All right, so the discovery process, as you saw, is basically where you install the agent on your Hyper-V hosts to prepare them for replication. The replicate step here is, again, we have to verify what our scenario is. In my case, it's Hyper-V. Import the migration settings from an assessment. Now, isn't that awesome? So that work that you did in the discovery and assessment process can now be fed into the migration here. That is awesome. And again, I created a server group, and then my specific assessment is here. Then we've got any virtual machines that were included in that assessment. I just have the nested VM1. Where is your migrated virtual machine going to live? We've got a subscription and a resource group. You need a replication storage account. Now notice that this storage account has to have soft delete disabled. The replication will fail right at the start if you have blob soft delete enabled. So I would suggest, because soft delete is such an important feature for the Azure Blob service, that you create a separate storage account with soft delete disabled for this process. Then we choose our destination network and subnet, whether you're going to do availability zones or availability sets. Here we're adjusting things like the VM name as it will exist in Azure. You can override your VM size. You can override your OS. Next, what disks do you want to replicate? It defaults to all of them, and this one just has an OS disk. Any taxonomic tags you want on that virtual machine, and then start replication. You with me so far? So that's likely to take a while depending upon how large the disks are on your machines to be migrated. And again, a nice benefit of that group option is you can logically arrange the servers and migrate them in batches. And we can get to that again by going up to Discovery and Assessment Overview, and you can go to Groups, and this is where you can review your group memberships, add, remove machines from them, and then you can run assessments, view assessments, so there's quite a bit that you can do in that particular interface. Now, I'm not actually replicating at this point, so I can't complete the step, but once replication reaches a state of synchronization, that is, the source server or server's storage is synchronized with what's in the storage account in your Azure subscription, then you're ready to kick off the migrate, in which case Azure will actually build the virtual machine. You see, what happens with Azure Site Recovery, but Azure Site Recovery doesn't actually build and run the VMs always. Instead, you're synchronizing the storage. And Azure is ready to deploy the VM when you do either a failover in Azure Site Recovery or a migrate in Azure Migrate. So when you hit migrate, then and only then, Azure will create a new virtual machine for each migrated host using the parameters and using the inputs that you specified and worked with in your assessments. And once that process is finished, you can stop the replication and then continue on your merry way with the Azure hosts. And then, as long as your testing goes well, you can decommission your source environment. Welcome to Lesson 17, Migrate Workloads to Windows Server 2022. This lesson is a survey of various Windows Server workload migration scenarios. Specifically, we're concerned here with migrating roles and features from one Windows Server host to another. We begin our work by migrating Internet Information Services websites to a second server running Windows Server 2022. Next, we'll follow that up by migrating Hyper-V hosts and Remote Desktop Services, or RDS hosts. we'll finish up by migrating DHCP servers and print servers to the Azure cloud. By the end of this lesson, you'll know quite a bit about Windows Server migration and PowerShell. There's lots of migration going on here for sure, so let's get down to business right now. Now let me give you some level setting here and just give you the storyline behind this lesson. I think I've mentioned it elsewhere in this AZ-801 learning course, but this particular skill set, this exam skill set, I find pretty interesting because of how thematic it is. And one of the themes that runs through the course is migration. And even more to the point, we're concerned with this lesson in migrating key server roles from one machine to another. Now, we presume that the destination machine is running the latest and greatest Windows Server 2022. That's Microsoft's motivation, I think, here, but that doesn't necessarily have to be the case, all right? Another theme that you're going to see in this lesson is that there's an older way and a newer way to perform these migrations. Older and newer actually probably aren't the best ways to go because honestly, the Windows Server migration tools have been around in Windows for a long time. So let me rephrase that and say there's at least two ways using Microsoft out-of-box tools that you can conduct these migrations. All right, so first we have migrating IIS websites to Windows Server 2022 from one host to another. And what Microsoft suggests in their docs is to do a synchronization using MS Deploy, which is the web deployment tool. This is, as long as you've got it set up properly on your source and destination servers, a very easy way to do both pull and push synchronizations. Now, you might just do one synchronization and then decommission the source server, or you might have a web application that's running through staged deployment where you want to have multiple synchronized instances of the server. Either way, MS Deploy can be helpful here. Now, the exam's not going to get into the high weeds of you setting this up because there is a fair amount of setup you need to do to get MS Deploy configured and to get IIS configured to handle this kind of scenario. What you're seeing here in the sample code is a representative run of MS Deploy using the sync verb, and we're taking the default website from our local host. We'd be running this on our source IIS server, and then we specify DEST for destination, and again, it's going to be default website. But notice that we're passing the computer name, the NetBIOS host name of the target server, and in this case, we're optionally doing some redirection to show output in a log file. But that's really what we've got going on. It's a way to pretty conveniently migrate IIS websites. There's also some logic built into MS Deploy where you can do dependency checking. That would be an obvious step 0 before you perform the step 1 of doing the migration/synchronization. Well, this AZ-801 objective is a little bit sneaky because it really is about migrating the virtual machines on one host to another. Now, we're doing quite a bit with failover clustering in the grand scheme of things with this training course, but here we're talking about non-clustered singleton Hyper-V virtual machines. And maybe we're decommissioning the source host, or it's a more or less just starting with a new version of Windows Server 2022 that's already loaded and set up on a target host. Doesn't really matter. But the idea here is we can use native Hyper-V PowerShell commands like move VM to do a live migration. And live migration has been a key Hyper-V feature for several years. So notice in the sample code, we're doing a move on VM1. The destination host, which is our Windows Server 2022 host, new server 1. We do want to include storage and virtual machine configuration, and then we specify a destination storage path for our snapshots and VHDs and supplemental storage files. All right? So both scenarios we've seen, using MS Deploy to migrate IIS websites, as well as move VM to live migrate Hyper-V VMs from one host to another, are both eminently scriptable operations. How do we migrate remote desktop services, or RDS hosts? Once again, if we dig down under the covers a bit, the exam objective is really talking about not host hardware so much, but specific RDS configuration, and even more specifically, migrating your RDS CALs, or client access licenses, from your old host, which may be running an earlier version of Windows Server, to presumably Windows Server 2022. That's going to be the scenario you see on your exams, of course. How do we do this? Well, in the RDS management consoles, there's actually a separate one for licensing, the Remote Desktop Licensing Manager. There's a wizard-based interface, the Manage Licenses wizard. Here you can see a screenshot from an older version of Windows Server, where the wizard will walk us through the secure migration of our client access licenses for RDS from one server to another. Now, with DHCP, again, there's an older, newer motif. We could manually do exports and imports on your source and destination DHCP server. We can use the DHCP MMC console, we could use PowerShell, but I finally want to bring to the table here formally Windows Server migration tools. Now this is a tool set. It's a collection of PowerShell commands. It's an old PowerShell snap-in. Now if you have history with PowerShell, you know that snap-ins are originally how the PowerShell language was extended. The downside, among many, to snap-ins is that they're all obfuscated. All of the PowerShell itself is compiled into DLL, so snap-ins are really not around anymore outside of legacy situations. And this is a legacy situation, and it makes sense that we would want to use the archaic snap-in architecture because we may be migrating DHCP or another supported role from a way down-level version of Windows Server, like Windows Server 2008, Windows Server 2012. You see what I mean? Now look at the list of supported server roles. Web Server, Windows Server Update Service, of course DHCP, Print Service, Hyper-V, failover clustering, branch cache, certificate services, federation services, RDS, routing and remote access. So a lot of, most of really, the core Windows Server roles are migratable through the migration tools. And so that was the bit of smoke and mirrors. I showed you some ways outside of WSMT that you can migrate, but you could also migrate IIS, RDS, Hyper-V hosts using these PowerShell commands. Now, although file services is a supported scenario for Windows Server migration tools, Microsoft's guidance nowadays is for you to use Storage Migration Service for file server migrations. And we actually cover how to do that elsewhere in this training. Now, depending upon how down level your source server is, servers that are running pre-Windows Server 2016 versions, you're going to be relying, at least initially, on an executable, smig deploy. You have to create what's called a deployment folder, and there's some other stuff you need to do with that executable. But if you're running Windows Server on, you can just use the PowerShell commands natively, and that's what I'm going to focus on in the demo. So as you can see here, smig deploy, just like any of the old-fashioned compiled executables, has its own custom syntax, unfortunately. So we've got /package, /architecture. You don't have to memorize all that for the exam, but just be aware that that executable is required when you're doing role migrations on old servers, Windows Server 2008, Windows Server 2012. Now, I let the cat out of the bag by saying that you can use the Windows Server migration tools to do this, but yet again, I want to compare and contrast and show the original way, or the non-migration tools method, where you're manually migrating. In this case, as you can see in the screenshot, this is the Print Management MMC console. And if you right-click the root of the console and select Migrate Printers from the shortcut menu, this launches the Printer Migration Wizard, where you can see it's a simple file export import. So basically you can export all of your queues and drivers to a file package, and then import the queues and drivers from a file package on your destination server. As long as those machines can reach each other on all ports, you're good to go. In this demonstration, we'll focus principally on Windows Server migration tools, but I want to start actually by opening up the Print Management Console just to show you a little bit of the old school, the non-PowerShell, the non-scriptable manual method, a representative one anyway, to migrate server roles. So if I right-click the Print Management Console, by the way, if I look here at my local print server, I have the built-in, the XPS and PDF software printers and one hardware printer down here, a TCP/IP port printer. Say that 3 times quickly, by the way. So if I right-click Migrate Printers, I'm going to export printer queues and printer drivers to a file, and I'm going to do that locally. And then I'm going to click Next, and we'll put that on my desktop. I'll call this FS1 Printers, and then click Next. And then we'll click Finish. Now, this is a binary file. If we look at the properties, it's a .printer export file. So it's a nice, convenient package that picks up all of the definitions, metadata, and drivers for those machines. And that obviously the file size is going to get bigger the more printers you have. I have just the default ones and a tiny little Hello World printer there. So on the destination server, we would do the same thing. We would right-click Migrate, and we would import the queues from the file. So that's a manual method. And most of these services also support a manual method. So let's take a look at DHCP. So I'm obviously on a domain member server called fs1.contoso.com, and I've got a scope here, just a hello world type of scope with a few addresses. I don't have any active leases right now, nor do I have any reservations. I am delivering some scope level options here, the standard ones, like your default gateway, DNS servers, and DNS suffix. And I want to transition this scope over to FS2, which is another Windows Server member server. Now notice that I'm not mentioning the version of the OS. It's not as important here. Once again, for comparison contrast purposes, if we right-click the server node, we can go see the backup and restore here. We can back up to a location. I'll back up to C shares, and then I'll create a folder called DHCP. Click OK. And if we take a look at that location, let's go to C shares DHCP. This is going to be the package and artifacts that contain all of our server scopes for IPv4 and IPv6. That would pick up everything. And then on the destination server, we can do a restore operation. So those are manual ways to go. Enough about that. Now, about Windows Server migration tools. Here, let me bring up VS Code and let me walk you through this PowerShell file I developed for our learning. Okay, so I'm starting here with the scenario of migrating an IIS website. And there's quite a bit you need to do in terms of preparation. So I have some links here. timw.info/WD is one short link. timw.info/675 is another. And both of those are tutorials that walk you through and also importantly give you download links to what you need. Specifically, you need the msdeploy.exe command line tool on your system. So as you can see on line 8 here, you'll definitely want to run a dependency check so that anything that could potentially break the synchronization or migration, you can reveal that and then fix that. Here we're invoking on line 11 the appcmd, which is the native command line front end to the Windows IIS server. And we're just running a backup of the source website just as a good safety check in case something goes catastrophically wrong. You'll want to make sure the msdeploy remote agent service is running. And again, you wouldn't have that service unless you installed the appropriate dependencies. And then ultimately, this is very similar to the command I showed you in the slide a moment ago, where we're using msdeploy. There are a number of verbs. I'm using sync here, where we're taking the default website from the local server and we're putting it on FS2. So that's really all I wanted to cover with that scenario. Now formally, let's get into the Windows Server migration tools. Now, if you're going to focus on the PowerShell, that is, if your source server is at least Windows Server 2016, which I'm going to assume here, we can directly get those commands installed using Install Windows feature. The name of the feature is Migration. Let me quickly check. I know I have it, but I'm just going to run this again. And you're going to want to set up not only your source server, but also your destination server as well. So actually, let me up arrow and let me throw this statement in curly braces because I'm going to make it a script block. And let me do an invoke command against FS2. And let's make sure that it's installed over there. Okay, it is. Oh, I did the wrong thing. I said FS2, but I did FS1. That's not what I want. Okay, it looks like that's not installed. Well, I'm glad I checked that. Yeah, so we're going to want to make sure to satisfy dependencies, as I said, not only on the source server, but also the destination server. Interesting. Okay, well, we'll take care of that momentarily. For now, you can see that in order to bring the migration commandlets into scope here, because it uses the old PS snap-in architecture, we can't just do, for instance, a get command like you see on line 24. That'll fail. You have to specifically add the snap-in, and the DLL is called Microsoft.windows.servermanager.migration, and it gets installed when you install the role here, or the feature. Then, and only then, we can enumerate the commands. It looks like I need to add that snap-in. Important first step. I just said that, for heaven's sake. Oh well. You can see that there's only 5 commands. And I think the ones that we're going to focus on are just export and import and get. So to start with, we can take a look at the local server and evaluate if there are any roles on the server that are eligible for migration using this tool. That's get smig server feature. So we've got a little inventorying happening on the system now. All right, looks like we've got DHCP and branch cache. Now, I still have more work to do to set up IIS, and when I satisfy all the necessary prerequisites, that would show up as an available role to be migrated as well. And then hopefully, as long as you've run update help and you have local help, you can get examples of each of these commands. I use this all the time to get some syntax help and some application guidance. Get help, the name of the command, -examples. All right, now let's get this party started with migrating DHCP. We're just going to do DHCP in this example as a representative application of using Windows Server migration tools. I want to make sure to stop the DHCP server on the local machine, and Microsoft recommends that you back up your server IP settings, as you can see on line 30, but that would only be if your goal is to decommission the source server. Now, if you know much about storage migration service, or if you've already watched my lesson in this course on storage migration service, you know that there exists in these tools the capability for the destination server to become the source server. So if we wanted our target server to use the same IP configuration as the source, that would be a case where, again, IP config, line 30 is a recommended optional step. It's not required. But what is required is that you would add in additional parameters when you're doing your export. So on line 33, we're doing export smig server setting. The feature ID here is one of the supported roles. We're doing DHCP. I'm going to put those export files in a shared folder specifying a local path. I do want verbose output, and then I'm using comment syntax here. That's why that's showing up in cursive. And frankly, just in case you've wondered, the cursive is coming from the font I'm using. I use a font called Operator Mono, just FYI if you're interested. Now, -user all -group means that if there's any local groups where you want to preserve the membership that are related to the service, those commands are necessary. I don't care about that. I'm going to revisit those user and group memberships on the destination server manually. And ipconfig is if you want to clone or migrate the network settings. I don't. That's why I put those options there behind a comment signifier. All right. So let me right click, run selection. Now notice that for security purposes, we have to protect that export package with a password. So let me type that in. That password gets stored as a secure string, which means that my terminal is not going to show any of the plain text data. Now, if we plan to decommission the source, which I absolutely do because this isn't a case of split scope. This is where I'm taking the full scopes on this source server and we're going to host and activate them on a destination, and we don't want any conflicts happening. And you know also, because I've done some training on it in this course too actually, about DHCP authorization in Active Directory. So on line 36, this is going to allow us to programmatically remove authorization for my FS1 server. So net shell, net sh, DHCP delete server, and then you need the fully qualified DNS name as well as the IP address. Good. So now it's time for us to work with the target server, and we can do that right from here. I'm going to enter a remote session, as you see. We'll want to install the relevant roles and features. Yes, indeed here. Let me get rid of restart because we're not going to need restart. I'm going to do both a DHCP and a Windows Server Migration Tools installation on this machine. And once that is finished, the last couple steps should be pretty clear. We've got on line 45 on our target server, FS2, we're going to do an import SMIG server setting where the feature ID is DHCP. And notice again, I've commented out some options. If you were going to migrate networking, you would need to add those additional parameters and values, but I'm not. So at the least, you need to provide the feature ID name, the path to where the archive is, verbose, and as you would expect, I'm going to need to provide the password as well in order to decrypt that secure package. And I'm throwing in force here as well. I don't know if I necessarily need that, but I'm going to add it anyway. Okay, that took a little while to complete, but yes, we can see success is true, no restart needed. Good deal. So let me clear the screen here. Let me go back to the root of drive C to give our terminal a bit more space. And let's now do our import SMIG server setting. Now, it didn't like force. I wondered if that was going to be a problem, actually. In fact, let me condense all of this code and bring it down into just one simple line here. So DHCP path. We're not going to need quotes necessarily around this string because it's just a single term, but I'm feeling a little bit superstitious here. So let me run that. Okay, I think I know what the problem is. It's what I said earlier about the snap-in. So I'm going to have to bring the commands into scope. Ah, those darn snap-ins, right? And once those commands get loaded into memory, into our run space, let me press enter. There we go. We can try line 45 again. There is our password, so let me carefully type that in. Press enter. If we could back up to where I installed the Windows features. All right, so now that we've established a connection to FS2 and we've installed the DHCP role as well as the migration commands, the rest of this configuration I really want to do on the target server. We're going to stop the DHCP server service, add in the migration commands with add PS snap-in, and then lastly, import SMIG server setting, feature ID DHCP. Notice we're providing the universal naming convention path to the migration folder, and we're hitting verbose. Now, when I try to do this in a remote session, it kept bombing out, and I tried tracking down a good answer, could not find one. The best one was actually to run these not in a remote session, but on the remote machine locally. So let's switch on over to fs2.contoso.com. Looks kind of messy, as you can see here. Let's see, where do I want to show you? I ran the add PS snap-in and import SMIG server settings locally on that target machine. I unlocked the encrypted password file by supplying the password. And it looks like this particular run failed. The Windows feature DHCP is already installed. We're going to have to use the force parameter and try running the commandlet again. Okay, so let me up arrow and let me just add the force command. Again, we'll unlock the password. The reason why I like to leave this messy stuff in my training, I don't do it always, but I'm doing it here because I found in this experience, this issue tends to not run smoothly the first time for most people. And I know as a student, it's really disheartening to see somebody's demo always go perfectly, so expect that there's going to be a bit of refactoring and so on and so forth. Now, in this time with the force, it looks like the success was true. So let's verify by opening up the DHCP console. It looks like the success flag is set to true here. So let's verify by opening the DHCP console on FS2. We're going to need to authorize the server. Let me do that graphically here. fs2.contoso.com. Let's bring that guy in. And then lastly, we can see there's our scope. There's our scope options. So migration complete. Welcome to Lesson 18, Migrate IIS Workloads to Azure. In this lesson, we begin by migrating local IIS web application workloads directly into Azure as Azure App Service Web Apps. We follow that up by migrating local IIS workloads to various other Azure Container Services, particularly Azure Kubernetes Service, or AKS. Let's get to work. What we're concerned with in this lesson is how do we, as Windows Server hybrid administrators, help our developers get our IIS-based web applications into Azure as efficiently as possible. Specifically, we want to know, is the IIS workload suitable for running in Azure and where? Now, of course, there's so many destinations in Azure. Our exam objectives are going to help us in terms of scoping us down to a single option, and that is the Azure App Service Web App. Now, App Service is the collection of platform as a service resources in Azure where you can host your web applications, your API definitions, and stuff like that. Code as a service if you're doing function apps. The web app in App Service is particularly useful in terms of being able to dynamically scale, integrate seamlessly in CI/CD processes. It's a great offering for sure. Under the hood, the compute can run Windows Server or Linux. So although we're starting with IIS in this lesson, you'll see shortly when we look at containerization, you may have a Java workload, for instance, that uses Apache Tomcat. You can bring those into Azure App Service with Linux running under the hood as opposed to Windows Server. We also have to consider not just the suitability of your app to run in Azure, but things like dependencies. In this example, we have IIS with a SQL Server backend. This lesson is concerned strictly with the web server or the web application specifically. There are tools in Azure for sure that support migration of database workloads. In fact, there's a bunch of Azure role-based certifications specifically focused on Azure SQL and data platform in general. So now that we understand our goal, let's take a look at the specific tool that Microsoft created to help us in this IIS web app to Azure migration journey. The tool is App Service Migration Assistant. This is what you need to know for your AZ-801 exam. And specifically, the App Service Migration Assistant is a Windows desktop app. So you're going to need to run it on a Windows client or Windows Server machine that performs an assessment on your IIS web app to see its suitability for migration into Azure App Service. There are a number of assessment problems that could be surfaced. The tool is going to be looking at port bindings, protocols, certificates, what authentication type or types the app supports, what you have in terms of app settings, database connection strings, and frameworks. Note that as of this recording in early 2022, only ASP.NET and PHP are supported frameworks for App Service Migration Assistant. We can expect that that support is going to expand because you may already know that App Service supports other frameworks besides just ASP.NET and PHP. We're just getting started here. So in addition to the assessment, which gives you detailed advice on how you can refactor if you need to or reconfigure the web app for compatibility with Azure, the App Service Migration Assistant can actually perform the migration as well, which is really convenient. Now, if there's a downside to the App Service Migration Assistant, there's really two. One, the limited frameworks that are supported, but again, give Microsoft time, and I know that will expand. And two, the fact that there's a scalability issue. Because this service is running as a desktop app, then you're going to be constrained to that desktop server or desktop workstation's hardware. So we're not talking about large-scale migrations. For instance, in Azure, there's a hosted platform product called the Database Migration Service, or DMS, which can do parallel at-scale migrations. We need to know the high-level workflow on how to perform an IIS web app to Azure App Service migration using the tool, and here it is. Of course, we have to install the App Service Migration Assistant and perform an assessment. We'll then mitigate any issues that show up. The Migration Assistant performs the migration not by moving bits itself so much, but giving you an ARM template, an Azure Resource Manager JSON deployment template, to set up the environment in Azure to which you then can publish your code to. Once you've got the Azure App Service up and running and you've deployed your code into it, then it would be a question of tweaking and customizing the app service and then monitoring using application insights to do monitoring of your application proper and Azure Monitor to do resource monitoring of your app service underlying app service plan. Now you may be wondering, aren't you going to do a demo? Yes, I'm going to do a single demo at the end of this lesson in which I show you both of these migration paths. Now there's quite a bit of assumed knowledge, unfortunately, in this AZ-801 exam objective because you may or may not be familiar with the Docker ecosystem and working with containers as opposed to virtual machines. We don't have the time or scope to do a deep dive here, so let me stay at a pretty top or high level as we look at how you can work with Docker workloads in and out of Azure. Let me bring my drawing tools back up. And starting at the left in our local on-premises environment, your developer using the Docker tools that are installed on their workstation create Docker images that are, we can look at it as a binary deliverable that contains all of the resources and dependencies for a single application, all right? So as opposed to having a virtual machine that has your application, in this case an IIS web app, and then you have the surrounding OS environment on the VM, containers in Docker are much more secure because there's less attack surface. It's just the application binary and its dependencies. And it's a deployable unit, ideally, that you can deploy to any cloud or any environment that has the Docker daemon or the Docker runtime service installed. The developer uses the Docker command line syntax and the Docker domain-specific language to create what's called a Docker file. That's a plain text declarative definition of what you want your image to look like. Maybe that resulting image is going to be a Windows Server image that includes the IIS web server and your application code, for example. That image is the unit of deployment in the Docker ecosystem. Well, where are you going to store that container image? Well, you're going to want to push it using the Docker command line tools into a centralized container registry. And coincidence of coincidences, there's an Azure product called ACR, Azure Container Registry, that gives you and your team secure access to this cloud repository that only your people can access. Speaking of your people, they can use the docker pull command to download images from the registry. They can use docker push to upload images from their machine to the registry. You can do the same operations in a DevOps context with Azure DevOps or with GitHub Actions, where you can programmatically schedule pulls and pushes depending upon your workflow. Once the container image is pushed into the centralized registry, how do you actually create new instances of that image? Well, in Azure, there's several choices. There's Azure Container Instances, which we could look at as a cloud-hosted Docker server. Without you having to have a Docker server, you can just spawn or start, or to use the Docker syntax, run those containers directly based on images that are pulled from the registry. We're focused in this lesson on these options over here. Our question right now is, what if we have an existing application, a web application that's not containerized, and we want to take advantage of the fast development and get source control for our Docker files? We just want to embrace the 21st century. So we want to containerize our existing application, put it in a central cloud-hosted registry, and then deploy that code as singleton containers framed within an app service, or if we're looking for container orchestration, we have Azure Kubernetes Service, or AKS. So how do we do that? Is there a tool in the Azure Migrate ecosystem? Well, you know, of course, yes. First, just to mention in passing, Azure Kubernetes Service is Microsoft's hosted Kubernetes cluster platform. And what is Kubernetes? Well, it was originally developed by Google. Now it's pretty much just out in the industry as a vendor-neutral standard. But this provides a cluster approach to do high availability and massive scalability for your container workloads. All right? Whereas the Azure Container Instances are basically for one-off deployments, or you can do multi-container deployments with Azure Container Instance, but there's not this enterprise class availability that you get with Kubernetes. So this is showing where from on-premises we've containerized, let's say, an IIS container and a SQL Server container, pushed those images to our registry. And then because our AKS cluster is already in Azure, it's super easy to create services and manage those services centrally with AKS. And yet another advantage of using Azure Kubernetes Service is that we can integrate with Azure's own identity platform, Azure AD, monitoring, Azure Monitor, and you can grab secrets and store secrets in Azure Key Vault. Onward. The specific app you need to know for your AZ-801 is Azure Migrate App Containerization. This supports microservices architectures, which really is, in a sense, sometimes a code word for using Docker containers, where instead of having a single monolithic spaghetti bowl application, you've decomposed your app into smaller parts that can be updated and scaled independently. This also, again, is a code for using CI/CD, continuous integration, continuous delivery pipelines. Now, the app containerization tool allows you to containerize ASP.NET Web Apps or Java Web Apps on Apache Tomcat. It is itself, Azure Migrate App Containerization, a web app. So when you load it up, it comes into your management server or your management workstation as an IIS ASP.NET app. And what you'll do from that app is do an app discovery in your local environment. And the tool can work with your locally installed Docker build tools to build either Windows Server or Linux container images and then deploy them either to AKS or an app service. The app service web apps can either have code pushed to them, which is what we did in the previous section, or we can push a container image and host that running container in the context of the web app. Let's do a demo where I can take all this theory and put it into meaningful practice. All right, let's get this demo started. I'm going to give you a tour of IIS app migration. First of all, just to set the stage, you're looking at the Azure portal, and I've gone into Azure Migrate, which is really a central repository for most of your migration goal use cases. You can see on the left-hand settings, you've got data box for moving just raw data. We're doing web apps right now. If you're looking to move Azure Virtual Desktop, that's the VDI option. If you're looking to migrate databases into Azure, and then lastly, there's a catch-all bucket here that says servers, databases, and web apps. It's principally server migration, but you can bring along web apps and databases on those servers. I think that's why Microsoft calls it that. But we're concerned with web apps, and you can create a project here in Azure Migrate, but then it's going to have you choose your assessment and migration tools. And these tools are going to be different based on your migration goal. For a web app migration, we're going to want Azure Migrate Web App Assessment. Now, this is not allowing us to download, but it kicks you out to the docs where you can download the tools. This is a little misleading because it makes you think it's a single assessment migration tool for Windows, .NET apps, as well as Java apps and PHP apps. No, they're two separate apps that you would download and install. There's the App Service Migration Assistant, which is going to cover your ASP.NET web apps and your PHP apps running in IIS. And then if you're going to do containerization, that's the Microsoft Azure Migrate App Containerization. The App Service Migration Assistant is an MSI that you just directly install on your server. The Azure Migrate App Containerization download link will kick off a PS1 file, a PowerShell file, and you just run that file. Note that that file works only with Windows PowerShell, not with PowerShell Core, all right? So I have, let's see, first of all in IIS, I have as my default website, let me right-click and go to Browse. It's running on port 8080 locally. It's a simple ASP.NET web application that I deployed from Visual Studio. So it's nothing too complicated for sure. So, but it could be more complicated, and that's the idea of doing this assessment and migration. So let's pop open the Azure App Service Migration Assistant, and let's take a look. So it looks like we start with choosing a site. I'm going to choose my default website. Click Next. Now we've got an assessment report. It looks like we've got 11 success, 2 warning, and 1 error. Uh-oh. And notice that we get a description and details, and in some cases, a learn more that takes us out to the docs. What's the other one? Localhost DB server. A connection string was found using localhost. Well, we're not going to work with localhost once you're in Azure for sure. And then it looks like we've got an unsupported port binding here, 8080. Well, I can fix that, of course, if I go back to IIS. And this, again, demonstrates what you'll do in the real world. It'll be going back and forth between your assessment and rerunning the assessment until you've cleared up at least your warnings. Let me right-click and go to Bindings, Edit Bindings, and let me adjust this. I don't have a certificate right now, so I'm just going to do HTTP 80. And we'll come back to our assessment. And let's go back and start over by selecting our website, clicking Next. So now we have 2 warnings and an error. So it looks like we'd be able to deploy if we want to. Nothing that's blocking. That's fine. Notice down below you can always save a copy of your assessment report. It comes out as a JSON file. Let's click Next. Now we need to log into Azure using the device code flow. So let's copy the code, open our browser, paste in the code, sign in with our administrative account. I'm already signed in, so I'll reuse that credential. Yes, I'm trying to sign into the App Service Migration Assistant. And now we can come back to the interface, and we can choose our pre-existing Azure Migrate project that I showed you in the portal. Notice that you can create a new one if you haven't already created one. Let's click Next. And then we choose our deployment subscription and our resource group. I'm going to choose those. Our destination site name needs to be globally unique because it goes on azurewebsites.net. I'm going to call mine TW AZ-801 Web App 001, and hopefully that's unique. Your underlying compute is going to be your app service plan. I'm not in Central US. I'm going to choose my home region. Note that you can set up a database connection string, including a hybrid connection. Now, what's that? The hybrid connection would allow going over the internet with no dependency of a VPN or express route circuit to set up a single port connection between, say, a SQL cluster or a database server that's running in your local environment, and have that work with the app once it's in Azure. In order to do that, you'll have the Hybrid Connection Manager installed as a Windows service on your local environment, on the database server specifically. And that would allow that single port connection to go over the internet into your app service. So it's nice that Microsoft offers that. I'd mentioned a moment ago that database migration is a separate deal. And just a heads up, there is a desktop application called the Data Migration Assistant. I've got it right here as a matter of fact, that can do assessment and migration of your local SQL servers and model them against hosting them in Azure SQL Database, Azure SQL Managed Instance, or maybe you're doing lift and shift where your target will be a SQL server running on an Azure virtual machine. So anyway, either way, and notice here that the options are to export the ARM template, which is what I mentioned a moment ago in the theory. And this allows you to tweak that template and then deploy using however you normally do. Or we can do Migrate. And because we're already signed into Azure, it can create those resources and push the code into that site. I think I forgot to mention that earlier, so I'm glad in this demo to be able to mention it to you live now. So at the end of this process, we'll have a new app service plan that gives you the underlying compute. We'll have an app service on that Azure Websites.net domain, and it will have the ASP.NET application in it. Again, we probably have some fix-up to do in terms of references and connection strings later, but I mean, you can't beat the simplicity of that, right? Nice. While we're waiting for that to complete, let's take a look at the other tool for containerization, and that would be the Azure Migrate App Containerization Helper tool. Like I said, when you install this, it comes in as a web app on your client machine or wherever you've installed it. And so you fire up that web app. On my system, it's localhost port 44369. And it walks us through here, setting up your application type and target. Is it an ASP or Java web app? Is your target Azure service going to be AKS or containers running on Azure App Service? I'm going to click Continue here. We've got prerequisites. We have to accept the license terms. You need connection to the internet. The tool will do an update check. If you don't have the IIS web deploy command line executable installed, it'll prompt you to install that. And you also have to have PowerShell remoting enabled on the server. I do. So once this connectivity check succeeds, we should be able to move on to the next step. But let me walk you through it while we're waiting. Again, we're going to sign into Azure with an account that has deploy privileges. We run an application discovery. We can have the tool build out a Docker file and then build the container image and push it into an Azure Container Registry. And then lastly, we can actually deploy the container to AKS or to a new app service that's going to run that container. Pretty nice, huh? Let's go to our app migration and see how it's doing. It looks like it already finished. So we've got here some options to migrate another site, to manage your app. I'm going to click Go to your website, and that'll take us directly to that URL, which is your app service name.azurewebsites.net. Now, of course, Microsoft gives you the ability to customize your domain name and that kind of stuff. If I jump over to App Services, for example, we can see our TWAZ Web App 001. And the first things I would do, if this were my machine, I would make sure that I've got my custom business domain verified. I would absolutely want to create a TLS SSL binding on that name so I'm referencing the server properly. If I didn't already have Application Insights telemetry hooked up, I would configure that. We'd also want to go to configuration and make sure that our app settings and our connection strings are sorted out and stored securely in here. And app base, that's a good way to start. We could do our scaling out if we want to configure auto scale rules as the load on the web application increases. We can have Azure App Service auto scale out and in. So there's some really nice capabilities built in there. So let's come back here. Here is our web application. Notice instead of localhost, it's running AZ-801 webapp1.azurewebsites.net. Nice. So let me minimize my browser here. Let's close out of the App Service Migration Assistant and let's switch over to our Azure Migrate situation. Wow, I'm still checking connectivity to the internet. I'll tell you what, let me do a hard refresh. And that seemed, did that fix it? Yes. Okay, good. So I've already got Microsoft Web Deploy set up, so I'll hit verify. I've already got PowerShell remoting. Enable SSH. Scratch that enable SSH. Our prerequisites are satisfied, so now we can sign into Azure, just like we did in the previous workflow. Again, we've got a device code flow here. I'll paste that code in and then sign in with my administrative account, my Azure AD administrator account. Yes, I'm trying to sign into Azure PowerShell. Once that succeeds, we're ready to rock. We select our Azure Active Directory tenant, which in my case is timw.info. And then I make sure to select, once they're enumerated, the correct Azure subscription. I have a couple of them at this time, so I'll select my sponsorship subscription and click Continue. Now, do you see the pattern here? The pattern here is that these tools that Microsoft created are going to allow us, even though we're not developers, we're hybrid cloud administrators, we can do a lot of beneficial work to help our development team, and frankly, to help ourselves, because we're going to manage the target resources in Azure anyway. Get those apps into Azure with minimal muss and fuss. It's really quite nice. Now, I'm going to do a server discovery here, so I want to provide either an IP address or FQDN. I don't know what the machine's local IP is. Let me quickly open up a PowerShell console. Let's open an elevated PowerShell console and I'll do an IP config. This machine is running in Azure actually. You can see up here cloudapp.net 192.168.1.4. So I'll do a 192.168.1.4 and the username. I'll provide my credentials here. Hopefully I typed the password correctly. And let's validate those credentials and validate the server ID. This is going to be the list of servers that are hosting apps that you want to evaluate for containerization. Again, that needs to be ASP.NET Web Apps in this case, and I'm modeling this project on publishing as a new app service, running the container rather than raw code. Outstanding. The status is showing as mapped for that IP address and those credentials, so let's click Continue. Now we have the service running a discovery process. Looks like it found the default website, ASP.NET app. We can give the target container a name. I'll call it ASP.NET1. Application configurations. Looks like it found a connection string. We saw that earlier, that there was a rogue connection string that pointed to localhost. I'm not sure why that's there, but that's what that's talking about. And then we have a folder hierarchy, and here you have a choice depending on how robust your source code is. You may have need to attach what's called a volume, a Docker volume, with your container definition. I'm going to click Continue. And now we have the build step where we've got the opportunity to point to our Azure Container Registry. And again, if you don't have one, you can create one. I've already created one called AZ-800. Let me go back. I keep forgetting I'm in the portal. Let me go back to the Azure portal. I'm going to want to make sure to enable what's called the admin user. So let me do a search for container registries. And here is my registry. And I want to go to access keys. And the way that authentication works with your container registry, normally the preferred way to go is to use Azure AD and to use role-based access control. But this tool requires that you have the admin user enabled, at least for the duration of the migration. It looks like I've already got it enabled. And this is a shared credential that allows you to sign into the registry using the registry name as the username and one of these two API keys as the password. Now, of course, it's a sensitive operation because anybody who knows your DNS name, and if they have one of your passwords, they own your whole registry. So admin user, in my opinion, is one of those things that's special use case. You'll want to keep it enabled only when you have to. And when you do have to, you want to periodically regenerate your passwords in case there is a leakage. Okay, so let's come back. I've got my registry, so here is our container. We can get a review of what the Docker file will look like. And again, a Docker file uses the Docker syntax. It's pretty straightforward. There's a number of keywords here where we're going to start with an existing base image. It looks like in this case a Windows Server core image. And then it's going to load up web deploy, which is a way to take IIS source files and push them somewhere else, publish them somewhere else. Copy, entry point. This is standard issue Docker file syntax. We don't have to worry, get into the weeds about that syntax here. Let's click build. But as a general theme, I want you to see that when we're working with Docker in the context of Windows Server and Azure, notice that we are using, for the most part, native Docker tooling. This is something that's important for businesses to know, that when they want to use Docker with Azure, it's not like you have to use Azure proprietary tools. You can if you want to. There's the Azure command line interface, for example. For the most part, again, stay with your native tooling, because Azure understands Docker files and understands Docker images and understands that ecosystem. Looks like our build status is successful. And if we look at the details here, let's zoom in. So we have downloading the source, we have setting up Docker, logging into the registry, scanning for dependencies, running the build. Then we're pushing the image to the registry. There we have it. And if we go back to the container registry and come down to repositories, here is the artifact in question. And we can easily tap into that. For instance, if we want to do a container instance and just do a one-off deployment, we could come into the portal here. And if I scroll down under image source, notice that we can easily tap into the Azure Container Registry and pull that image. Isn't that convenient? All right, so back to our regularly scheduled programming here. Let's click Continue. And now we have to specify our deployment specifications. We've got our app service plan. I'm going to create a new app service plan in my sponsorship subscription. In my working resource group, I'll call this AZ-801 Container 001. Now, whoa, I'm a little bit surprised that we're defaulting to the premium plans. Those are the most expensive ones. Yikes. Not really a fan of that, but we'll let it roll for now. I better make sure after this demo to go fix that up. Of course, we can change our app service plan size very easily in the portal. We don't have need to integrate with Key Vault here because we're not parameterizing any secrets in our app config. We're not using Docker volumes, which are stored in a general purpose storage account in a file share, so we're good with that. Looks like we're ready to rock. We can specify deployment specifications like what our network port map is and our name. I'm going to have to fix up this name because that is not a globally unique name. So let me apply that. And then lastly, we click Continue. We've got our container deployment. So once we click Deploy, the end of the process will be our image that's in the container registry will be then run and placed within the frame of a new Azure App Service, which we can browse the very same way that we can the example that we published via source code. So that is the App Migrate app containerization tool. I hope you found that demo helpful. Welcome to Lesson 19, Migrate AD DS to Windows Server 2022 AD DS. We begin this lesson by learning how to migrate Active Directory domain services objects to another forest or another domain within a single forest by using the Active Directory Migration Tool, or ADMT. Next, we plan the migration of an entire on-premises AD infrastructure to a new forest. We conclude by upgrading an existing AD forest running down-level Windows Server versions to Windows Server 2022. Let's get started. Let's start this discussion by considering possible answers to the question, why migrate to a new Active Directory forest? In my professional experience, merger and acquisition is probably the #1 case. Your business may be company.com, and then you've acquired companyb.com. Are you going to maintain two entirely separate forests? Well, it's true that we can establish a one- or two-way forest trust between the two forest root domains, but the chances are you want a tighter, cleaner method of administration and security administration and access administration, so you probably want to absorb those acquired domains into your forest. And in keeping with Microsoft proven practices, Microsoft strongly recommends staying with a single domain forest wherever possible yet. And this is because Active Directory can scale to such a large size. And with things like password policies, there are far fewer reasons why a business would be forced, essentially, to have multiple domains or multiple domain trees within their forest. Corporate disintegration and reorganization is another case. We have to remember that a new forest or a different forest means a completely separate DNS namespace. And if the acquired company or if the unit of your company who has their own forest and domain is being disintegrated, taken apart, by definition, you need to do something with those objects. We're thinking in this lesson of security principal objects like user accounts, group accounts, service accounts, that kind of stuff. We'll also in this course pick up other type of workload migration, things like taking your Windows Server file servers from one environment and migrating them to another. One thing at a time though. Another driver to consider migrating one domain to a new forest is if you have need to rename. You might have realized years too late that the name you chose for your original forest root domain was not optimal. I actually had that happen in my career many years ago. I worked at a private high school here in Nashville, and I wasn't the person who made the decision to name the internal Active Directory domain school.local. But because the school used both Mac and Windows computers, you might know where I'm going here. The .local top-level domain is used with multicast DNS and especially problematic in Apple environments. So we had a fully deployed domain that we needed to migrate to change the name off of .local. I hope you don't have security issues that require a domain and or forest rebuild or migration, but that is yet another reason why you might want to do that. So given these drivers, we remember that AZ-801 and AZ-800 are not architecture skills, they're more Windows Server hybrid administrator. You're probably thinking, okay, I'm not the one who made the decision. We need to migrate domain A to forest B, but how do we actually do that? This is where AZ-801 focuses. And specifically, the tool you need to understand for this part of the exam is good old ADMT, or the Active Directory Migration Tool. Let me bring my drawing tools out here. This is a screenshot I created on one of my servers, and I just want you to see, yes, this is an old-fashioned Microsoft Management Console. The current version of this tool, as of this recording in 2022, is 3.2, and the tool really hasn't been touched in many years, although it still remains perfectly functional. So what we have with ADMT is a front end that, as you can see here, if you right-click the ADMT icon in the MMC console, consists of a number of wizards that cover different migration patterns. User accounts, group accounts, computer accounts, and then there's some recording service account, managed service account, So it's basically what I said before, your identities or your security principles in a source domain. You need to migrate them to another domain. The good news is that ADMT is mature and it's relatively straightforward. It doesn't require a whole lot of infrastructure. When you install ADMT on one of your infrastructure servers in your source domain, it will require a connection to a SQL Server instance, and it doesn't have to be a fully licensed SQL Server. It could be just the SQL Express, as a matter of fact, but it does use a SQL database on its back end. And we'll walk through its use in the demo, so that's about all I really need to say about this right now. Well, I'm just going to say a couple words about this because we're really covering this AZ-801 skill throughout the entire lesson. The idea here with domain and forest restructuring assumes that we've got our source domain and we're migrating some or all of its contents to another forest, you see. So here we have forest 1, here we have forest 2. And it's not a question of migrating the entire domain. Please understand, we cannot do that in Active Directory. Instead, we would need to deploy a new domain or mark an existing domain in the target forest, and then separately migrate the assets that we want to get out of the source domain. You understand what I mean? And the reason why this exam objective is talking about new Active Directory forest is basically what I said before. Nowadays, there are very few solid reasons why a business is going to want to have multiple domains or even multiple domain trees within a single forest. And whereas we absolutely can migrate objects from one domain to another within a forest, that really has a very thin and fairly weak use case given the presence of trusts that exist within the forest anyway, transitive trusts. And if you understand how Active Directory security groups work and those options, it's just you're creating extra work. So the use case here is we're assuming that we're going to migrate these objects from one forest to another. So given that, let's continue. Now this is much more relevant now that we have a new release of Windows Server, namely Windows Server 2022. Now you don't have to memorize all the specific versions of Windows Server that can be upgraded. That's all trivia that we can find just by doing a quick search at the Microsoft docs. What you need to know for AZ-801 is the high-level workflow on how you would transition a domain that's running domain controllers that are, say, Windows Server 2019 or Windows Server 2016. And you want to bring those up to spec, as it were, and have your domain controllers running 2022. So how do we do that? Well, could you do an in-place upgrade? Yes, but Microsoft's proven guidance is to do what I'm going to show you here. Let me walk you through and then we can discuss some of the pros and cons and gotchas and that kind of stuff. Microsoft's guidance is add at least 2 Windows Server 2022. The 2K2 is just my clever shorthand because I didn't want these little text boxes to be too filled up with text. So you're going to deploy at least 2 servers, these may very well be virtual machines, into your source domain and make sure that they're running the latest and greatest licensed edition of Windows Server 2022. And those servers will come in as member servers of your existing down-level domain, all right? You definitely want to prepare your forest schema and domain environment as well. And we can use the good old AD prep tool on our Windows Server 2022 member server to prepare the forest and domains for the introduction of a new version of Windows Server. Next, we promote those Windows Server 2022 member servers to be domain controllers in the domain, and yes, it'll work just fine if you're in 2016 or Windows Server 2019. Once you have the new servers running Windows Server 2022 up as domain controllers, you'll want to transfer your flexible single master operations roles to the new servers. And then lastly, demote the servers that are running down-level Windows Server, have them be just member servers, and then you can do whatever you want. Lastly, you'll want to make sure that you've unlocked all of the capabilities of Windows Server you can, so you want to make sure that your functional level, your domain and forest functional levels are set to Windows Server 2016. Now notice that there's no functional level past Windows Server 2016. That's the latest though. So if you're running an earlier functional level, you'll definitely want to boost those. Let's do a demo. In this demonstration, we're going to take a look at some various techniques for migration, Active Directory migration. We're going to take up how to use the ADMT, or the Active Directory Migration tool, to migrate user accounts from one forest to another. So right now you're looking at the desktop of a Windows Server 2022 domain controller called mem1.acq.com. And I've loaded up a bunch of relevant MMC consoles here, including Active Directory domains and trusts. And we can take a look at my acq.com forest root domain, and we can see I have a two-way transitive forest trust in anticipation of the ADMT work that we're going to do. I actually had to do quite a bit of background work to get these two forests, namely acq.com is our source forest, and contoso.com, that's our destination forest, set up to facilitate here. We've got, as I said, a two-way transitive trust that I've got set up. Let's see, what else do we have? In DNS, if I connect to my local server and take a look at my conditional forwarder here, I've set up conditional forwarding such that if we're looking for contoso.com, we're going to go to their authoritative domain controller, and I've set up a conditional forwarder on contoso.com that if a lookup happens for acq.com, come over here to mem1. You see what I mean? So I'm just covering my various bases here in terms of trust relationships, connectivity, name resolution, this kind of stuff. And lastly, let's take a look in Active Directory users and computers, and let's see what we have as far as accounts to migrate. Specifically, in my acq.com domain, I have an OU called IT Services. I have a fictional user named Roger, and a global security group called IT Admins that includes both Roger and domain admins. Now, this brings up important questions that are a bit beyond the exam scope. Things like, well, what are we going to do with SID history? If you're familiar with the SID history attribute, we may want to dump that so that when Roger comes over and when this group comes over, we have to redo membership and access, but can prevent an unwanted privilege escalation, particularly for accounts with well-known SIDs. So that's one thing. And another thing is that your hackles might have went up when I showed you the two-way non-selective authentication that I have between my forest root domains. Again, that's just going to be temporary for the duration of this migration. But still, understand, we can do a selective forest trust as well. We don't have to even make it bidirectional as far as that goes. All right, good deal. Now, we don't need to walk through the whole installation and setup, but to do ADMT, you'll want to install or have SQL Server available. This is going to be either SQL Express or a full instance, and that instance doesn't have to run on this server as long as you can get to it from across the network. Another thing you're going to want to do, particularly for handling user passwords, is to install the Password Export Server, or PES. This is a separate MSI that you install in your source domain controller. And then once you have that up and running, you'll need to create an encryption key, a password export key. Here I've got a whole bunch of semi-random PowerShell for you here. I'd like to draw your attention to line 9. Once you have ADMT installed, you can use the ADMT command line tool, and you're going to do ADMT key option create, your source domain, your path and name of your key file, and you'll want to protect that key file with a strong password. This password export key will be used to protect passwords during the migration process. So basically, you create your key first, and then when you install the password export server, it's just a DLL basically. It will allow you to browse to where your key file is, and then you're good to go. All right? Okay, so here I am in Active Directory Migration tool. The only node here is a list of reports. This is such an old school interface, like I said. To actually interact with ADMT, we need to not even select the root node, but right-click it. So we've got various wizards. We don't have the time, scope, or necessity to go through every one of them. I want to draw your attention in particular to user and group migration wizard and password migration wizard. In this example, let's do a user account migration wizard. They all function very similarly. They're all using the classic wizard interface, as you can see. Let's click Next. Type the names of the source and target domains and domain controllers. Okay, well that should be pretty easy to do. As you can see, I've specified ACQ and mem1 as my source environment, and contoso.com and DC1 as my target environment. Let's click Next. We can either hand select users, which is convenient but not particularly scalable, or we can prepare an include file. That's really the preferred way to go if you're working at great scale. I'm going to just do a select users, and then we'll do an add, and I'm going to resolve Roger's name in the directory and click Next. Now, what is the distinguished name of the target OU? Fortunately, we have a browser in the target domain, and I'm going to put Roger in the IT organizational unit and click OK. And there we have the LDAP syntax. It's LDAP URI, or URL, I guess you'd call it, that uses the distinguished name syntax to resolve that path. Let's click Next. Now, what kind of password are we going to do? Are we going to migrate his existing password, generate a complex, which is the default, or don't migrate anything? I'm going to migrate the password. And the source DC is this machine, so I don't have to browse or make a change out of this list. And I already have the password export server DLL installed, and I've already created and stored the encryption key. If the service is not running, which it evidently isn't on this machine, we get an error, but let me open up services.msc. Again, I need to be able to type services.msc, and let's jump down to P, password export server service. Well, yeah, it would help if that service were started, right? So let's start the service, and let's try that again. There we go. Now, how do we want to handle migrating accounts? We've got target account state, enable, disable, or just have the state match the source, which is fine because Roger's account is enabled by default. What about disabling? Do we want to migrate the user SID history, or are we going to start afresh? That's, again, beyond our scope, but the question here about the SID history attribute is, would it create potential for unwanted privilege escalation if you migrate those user SIDs? So I'm actually just going to start from scratch with Roger. That's fine. So I'm not going to migrate his existing SID history. And let's click Next. What other options do we want to include? User rights assignments, associated user groups. Do you want to bring those along for the ride? Update previously migrated if you've made changes to the source group in the meantime. Do you want to fix up users' memberships? I'm going to choose everything here except translate roaming profiles and update previously migrated objects, because this is my first migration. This is where you can exclude certain schema properties. To do that, we choose exclude, choose the object type that we're talking about here. And then this is just a question for you and your team. You may have extended the schema in the source environment. You want to make sure that those custom attributes are excluded from migration. That's just an idea that came off the top of my head just now, but that's fine. How do we want to handle conflicts? Hopefully I don't have a Roger account in the destination environment for sure. There's not going to be a UPN problem. I know that for sure. The default is just to not migrate the object, but you can kind of bulldoze your way through by choosing migrate and merge, choosing one of these options. I'm going to do not migrate, and then we've got finished. It's pretty straightforward, as you see, even when you're working at great scale. Now, some of this, of course, is going to be the compute power of the ADMT server. But as you can see, we have one user and one group. It looks like copied 0, copied 1. Okay, well, what's the log say? Well, sure enough, and you know what? I actually didn't plan this either. This is really interesting. the target object Roger Carr already exists. So I've got a conflict there. And because I chose to bail out of the migration if there's a conflict, there you have it. So this actually was what the late, great Windows Server architect Bob Ross used to call a happy little accident. So I would need to resolve this and rerun the user migration for Roger, maybe specifying, well, there's actually a bigger problem here because it seems to me that this Roger Carr would have the same user principal name as my Roger. So yeah, so anyway, so that's a good real-world example of something that can come up as an ADMT problem. Now let's quickly verify that at least the group has been migrated. Let's come back to our admin console and let me right-click Users and Computers. And let's see, can we get over to, no, it looks like we can't get across the trust there. So let me switch on over to DC1 and let's open up dsa.msc to open up Active Directory Users and Computers. Yeah, and sure enough, there's that Roger Carr, but we can see IT admins that has in fact been brought over. Of course, there's no groups or users in here. Domain admins was stripped out because we didn't migrate that object. And the Roger account that should be in here failed because of the problem I explained a moment ago. So as you can see, this is what we've got going on here, okay? And as you can see here, the SID history attribute is empty. This is going to track the security IDs of the groups that account. This is a bad example because it is a group, but all of the memberships from that object that exist over time. All right, to finish this demo, let me bring up my PowerShell script, and let's just take a look at some additional PowerShell, just again, to make sure that we're doing our work here with an eye toward automation and so on and so forth. What about the case that I explained at the end of the slides, where we looked at wanting to migrate our existing domain such that our domain controllers are all running Windows Server 2022? What are some things we want to keep in mind? Well, we want to keep in mind, as I'd mentioned before, forest and domain functional levels. And as you can see, we can do get AD domain and get AD forest to see what our current forest and domain functional level is. It looks like I'm already running Windows Server 2016. I know that's the case. Quite sure it's the case here for the domain as well. Yeah, so that would give you a check. You'd run that on your existing pre-Windows Server 2022 domain controllers. And then when the time comes, once you have your 2022 domain controllers in place, you can do a set AD domain mode and set AD forest mode to promote those if they're not running the latest version, the latest functional level, which is Windows 2016 domain and Windows 2016 forest, respectively. All right, here's an option here to disable SID filtering using the netdom command. Some other things just in terms of in-place migration. If your down-level domain has been using the old FRS file replication service, you can get a check, first of all, on whether you're using it or not. DFS MIG get global state. Whoops, got a misspelling there. It's DFSR MIG get global state. There it is. Current DFSR global state eliminated, succeeded. Yeah, so I've eliminated FRS. I'm using the preferred AD replication protocol, DFSR, and you just want to make sure that on your new domain controllers, that is to say your Windows Server 2022 domain controllers, that if you don't have FS-DFS replication installed, you can do that as you can see here. To prepare the forest and domain for in-place upgrade, you just call AD prep, forest prep and domain prep on one of your new 2022 machines. Promoting a member server to a domain controller, you should probably already know all of this. We've covered this previously, and the concept of deploying domain controllers is all over AZ-800. And then as far as transferring your flexible single master operations role, you can first of all figure out which of your old domain controllers are holding which roles, again using the PowerShell pipeline in conjunction with get AD domain and get AD forest. and then we can do a transfer or seize operation with move AD directory server operations master role using the syntax here. This would transfer them all to my DC1 server. Then we've got demoting legacy DCs. You're basically uninstalling ADDS domain controller, demoting ops master role if they haven't already been demoted, and removing the directory partitions. So as I said, this is just a bucket of PowerShell that accomplishes a couple goals for me as an instructor and for you as a student. Number one, it keeps you with PowerShell. Number two, it's an alternative way to do the work besides the GUI. And number three, it seems to me the repetition of doing the work graphically and programmatically is a great way to be well on the way to mastering those concepts and then clearing your certification exam. Welcome to Lesson 20, Monitor Windows Server by using native tools. We begin our work with using Performance Monitor to capture and analyze Windows Server system performance data. In so doing, we create and configure data collector sets. Next, we centralize Windows Server monitoring and implement artificial intelligence-based predictive analytics by combining Windows Admin Center with System Insights. We finish up by managing the many Windows Server 2022 event logs. Let's get to work. I'm not sure how long you've been working with Windows Server, but if it's for any length of time, you already know that Performance Monitor is built into Windows, both Windows Server and Windows Client, and it's a convenient tool to monitor system performance. And when I think of system performance, I think of the main four compute subsystems. 1, processor, 2, memory, 3, disk I/O, and 4, network I/O. Input, output, in other words. We use Performance Monitor in a couple different ways primarily. We have a Microsoft Management Console, a GUI tool, and then there's the get counter PowerShell commandlet if we want to script and automate our performance monitoring work. Common real-world task with Performance Monitor, in my experience anyway, is to create a server performance baseline. Why would you want to create a baseline for system performance? Well, there's several reasons. You may want to evaluate a server against a possible hardware upgrade. I know in my experience as a systems administrator that if I'm going to request money to upgrade the RAM or the disk space or the processor or the network card on a server, my boss or whoever it is that's controlling the proverbial purse strings is going to want to see quantitative numeric data instead of just my hunch that the server is running too slowly. Another common use case for performance monitoring and baselining is to assess your on-premises Windows Server machines against cloud readiness to Microsoft Azure. You may have, for instance, SQL Server database servers running on premises, and you're thinking to yourself, okay, I know I want to run these as virtual machines. What size virtual machine would match the performance that I get on-prem? If, by contrast, your SQL Server VMs, you want to go to a platform solution and use something like Azure SQL Database, you still have the question of figuring out your performance baseline to help you size the Azure SQL Database virtual server in the cloud, you see. We are talking about in this training the hybrid cloud Windows Server Administrator, after all. And so I want to remind you that Azure Log Analytics is our Azure-based hybrid cloud monitoring platform. And absolutely, we can collect performance monitor counter data from our on-premises Windows servers, and then we can monitor that data as a group instead of historically Microsoft with Performance Monitor as a native tool. It has limited capabilities as far as aggregation goes. Let's take a brief look at the Performance Monitor or perfmon object model. What are you looking at here? This is probably one of the most basic topology diagrams I've ever created in my life. Well, what the square, the big square, is meant to denote is a physical CPU, processor, in other words. And in Performance Monitor, that's the top level of the object model. The object, the processor, the physical disk, the logical disk volume, this sort of thing. And then within that object, we have counters and instances. Counters represent metric values that are time sampled. They're sampled per unit time, and they're going to give you some numeric reading. Percent processor time is going to be a measure of the time interval in which a processor is busy doing work rather than sitting idle. Now, the instance is important because with processors nowadays, the chances are almost 100% your physical CPU die consists of X number of logical cores, CPU cores. And Performance Monitor can give you weighted averages or aggregates across, in this case, all cores, or we can target to the specific core on the CPU die. So I just want to make sure to review this vocabulary to make sure that we both understand it. And this can come into play, for instance, with physical disk and logical disk objects. A physical disk may have one or more partitions. In the logical disk ecosystem, we're talking about formatted volumes, your C drive, your D drive, your E. And then again, we're talking about object, counter, and then instance. Maybe if you're monitoring disk free space, the object would be logical disk, the counter would be percent free space, and the instance might be drive F. That makes sense? Well, when we're using Performance Monitor to create performance baselines, it's not going to help us if all we're seeing is live metric data on screen. We absolutely can counters and just watch them live. That's fine, and that has its space, but the data collector set supports scheduled and or on-demand data collection. And this is going to give you a report that can feed your need for a server performance baseline, for a cloud readiness evaluation, this kind of thing. The collected data in a data collector set can be one of a few different varieties. Counter metrics, percent processor time, like we were just dealing with a moment ago. But going beyond the metric data, we also have state or event-based data. We have what are called configuration data. This is basically the value state of registry keys and values, as well as event traces. And we can use Windows native event streams, or we can tap into custom event streams. The AZ-802 doesn't get into that level of granularity, but basically an event trace is like an event log, that when an occurrence of some predefined event happens, it leaves a trace. And those event occurrences are one of the options that you can collect in your data collector set. Now, the best practice is to run these data collector sets remotely. And hopefully it makes sense why. You don't want to artificially inflate your utilization values. Let's say you have two infrastructure servers, DC1 and MEM1, and you and your team are considering a memory upgrade on MEM1. Kind of a pun with the name there, I guess. Are you going to set up the DCS locally on MEM1? Or would you rather create the DCS on DC1 and have it remotely capture that data? You see what I mean? We don't want the CPU and RAM and disk and network overhead of the monitoring process itself to have an undue impact on the results. Now, Windows Admin Center, or WAC, has been a theme throughout this entire AZ-801 learning journey. WAC is a web-based console. It gives us multi-server, and not only multi-server, but multi and hybrid cloud server management. We can add in, for example, our Azure virtual machines and manage them right alongside our local on-premises ones. The fact that instead of a Win32 application like Server Manager, or for that matter, the Microsoft Management Console, Microsoft recognizes now that administrators may be dealing with multiple operating systems, and then there's nothing more convenient, really, than a browser-based tool, let's face it. So hence, Windows Admin Center has a lot of good going for it. As we see as a standard in web browsers nowadays, there's an extension framework in WAC. So if we're not seeing a certain capability that we want to monitor in our Windows Server environment, we can check the extensions list. Either Microsoft or a third party might have already developed an extension, and guess what? You and your developer team can create your own WAC extensions if you don't find what you are looking for natively. Now, in practice, I'm just going to inject a little bit of my own experience here. In practice, I find that Windows Admin Center modules, they contain normally a subset of the capabilities that you get in Server Manager or Microsoft Management Console. I'm sure that's going to change over time, barring any engineering or architectural limitation. This is also reflective of the fact that Windows Admin Center is under almost constant development and revision. So we can expect to see greater feature parity over time between what it offers in the web browser as opposed to what you get in the MMC. I want to cover, just in a drive-by fashion, some other Windows Server and Windows Client, for that matter, built-in monitoring tools. This is Resource Monitor, which I like to describe as Task Manager Deluxe. You know, Task Manager's been part of Windows since the very beginning. As you can see, just taking a look at the output here, it's divided into those 4 primary compute subsystems I mentioned earlier: CPU, disk, network, and memory. And we're able to get both list and graphical views of that data. And you can see that the top of Resource Monitor also has tabs that you can drill into each of those subsystems. This is an excellent tool for sure, as far as getting a really deeper level of live system performance. That's something else I want to make sure to say. That the Resource Monitor is great here for live data, but we still have those data collector sets for scheduled or ad hoc data collection, where you then can take that output as a persistent file and do work with it. Another tool is the Reliability Monitor. This is an old Windows control panel. And what I like about this is, at a glance, you can see the availability, the reliability and problem history of your Windows Server or Windows Client system. So in this example, I selected February 26th, and you can see that there was a failure event or a critical event. And we can see down below in the table an enumeration of what those events are, date, and then if there are technical details available, we may be able to fetch those. So this can give you a good idea if you come into work or log in to your workstation in the morning and you see some alerts on a server. This is one of the tools in your toolkit that's built right into Windows that might give you some insight on why something went sideways in that server's configuration. System Insights is a very interesting platform, if I do say so myself. I like to describe it as an evolution of Windows Performance Monitor. And why do I say that? Well, Performance Monitor is going to let you know what your server's doing in terms of those subsystems. And with data collector sets, you've got a longer running record, but it's still static data, isn't it? Wouldn't it be nice if we could integrate predictive analytics to give us not an idea of just current performance, but predictions based on previous usage patterns to take a look, for instance, at capacity forecasting in the future? This is really good stuff. So long story short, you're going to use System Insights not so much for current state monitoring. I just showed a whole bunch of tools that we can look at that for. But System Insights, as I said, because it's backed with machine learning models, Microsoft has a whole bunch of pre-built ML models. And if you don't know what ML is, machine learning is the predominant technique in artificial intelligence nowadays, where you basically create a file that's your ML model file, and it can make predictions of different types based on what it sees. It learns and relearns based on the environment in which you place the model, and then it's able to see patterns that you might not see as a human being, for example. It's very quick at detecting anomalies, this kind of stuff. There's a whole API called Windows ML for that. You can check out the Microsoft docs if you are a developer and you want to know. But all we have to know for our AZ-801 is that under the hood, we're tapping into artificial intelligence models to give us these insights. Now, we surface those insights in Windows Admin Center, or we can use PowerShell. I do want to say, though, again, how important it is to look at Azure Log Analytics as your central log and telemetry aggregation platform. You know, we have to keep reminding, or at least I have to keep reminding myself over and over, I'll just speak for myself, that this is the hybrid cloud administrator. So it's presumed that you do have an Azure subscription available. So we can aggregate these system insights forecasts, these predictions, across multiple systems by using log analytics, which I think is super powerful. Well, as I mentioned before, an event is the occurrence of some event. I normally do not like circular definitions, but in Windows event log, we have the built-in logs. And let me just say, events are an occurrence of some activity. And the built-in logs here that have been in Windows since really the beginning, at least Windows Server, although they're also available in Windows Client. Applications, systems, security, forwarded events. That's going to capture operating system events that are informational, warning, critical. It's been on the platform a long time. I don't mean to insult anybody's intelligence by explaining this, because you may be yawning saying, Tim, come on, I've been doing this work for a long time. And I honor that. But I also honor the fact that not every student has the same level of experience, you see. There's also a library of event logs that are called application and service logs. And it's really an extensible framework. It used to be back in the old days, you just had your built-in logs and that was it. And then, I'm trying to think which version of Windows it was. It might have been Windows Server 2003 or 2008. We saw this proliferation of dozens and dozens of separate app and service logs. So you've got logs for directory services for your Active Directory. You've got DNS and DHCP, and that's fantastic because we want to be able to surface those event occurrences. If you have logon failures, if you're doing auditing, of course you want that recorded in the event log. If you've got issues with DNS name resolution, the event log's a great place to look for insight, you see. So we have admin, operational, analytic, debug, and then depending upon first and third party server software that you install in the future, those software products might inject additional application and service logs. It's just something that you'll need to check. And then there's the whole question, we don't need to get into it as such, but there's the whole question that I'll drive by of event log management in terms of circular logging and maximum event log file size. Maybe we'll get into that in the demo, come to think of it, which is something that we can control centrally by using group policy. All right? And then lastly, viewing the event log events. There's the Event Viewer MMC console, there's Windows Admin Center, and as always, there's PowerShell. Now, I remember when event subscriptions were introduced into the event log system in Windows Server. And this was compelling at the time because it allowed you to forward events from one server to view them on a central server. So it was a way to aggregate events. But you know what I'm going to say. I'm going to say I'm hoping that you're not relying on event subscriptions, which are very manual and frankly, they can get cumbersome pretty quickly. Remember that we can use Azure Log Analytics as our destination for all event logs, and we can use the Kusto query language in order to write reports across all of our systems, some of our systems. Let me show you a very basic Kusto query here. The name of the virtual table for the security built-in event log is, appropriately enough, security event. And notice with just a couple pipe characters and a couple clauses, we can go across potentially hundreds or thousands of servers to round up occurrences of event ID 4672, where the level is 8. In our demonstration, I'm going to highlight many of the tools that I discussed in theory over the last 15 minutes or so. I'm on a Windows Server 2022 domain controller named DC1. We just as well could be on a member server or a member workstation because I'll be using both the Microsoft Management Console as well as Windows Admin Center. So let's start with MMC. I did what I like to do, actually. Let me save my changes. I have a custom MMC console that I've created called Admin Console, and I've just done an add remove snap in here to bring in Performance Monitor on the local machine, Event Viewer on the local machine, Event Viewer on my member server, and Group Policy Management, just for convenience so we don't have to keep flipping across different windows. So let's take a look at Performance Monitor first, shall we? So we've got the Performance Monitor proper. And this is going to show, actually here in this interface, it looks like it's not showing anything. But if I instead open up Perfmon, the MMC console, the built-in Perfmon console, we should see if we go to Performance Monitor, Microsoft normally loads up the percent processor time counter with the instance being _total. So as you can see, this is just simply showing us a time-sampled line chart where if we right-click our counter, we can do a number of different things: clear, add counters, save settings, potentially important. Notice that the output in Performance Monitor is an HTML file. And if we right-click and look at properties, it allows us to change the counter in question, the graphical display style, the scale. Let's see. Sample automatically, or you could sample every so many seconds for a duration. You can change between 3 types of view: line, histogram, and report. You know, being a colorblind person, I like the report view simply because all of the colors are a little bit unfair for me, to be totally honest. And these controls up here are just the same things in terms of what we saw. Let me change that chart type again. Let me go back to line. And let's go back to properties one more time, because there was one more thing I wanted to mention. What was it? Oh, source, yes. Notice here that when you're plotting live metrics in Performance Monitor, it defaults to showing you live data, but this is also a place where if you've saved log data, data collector set data, exports, and this kind of stuff, notice that you can show that historic data in a graphical way. And you even could establish via a connection data source, an ODBC data source connection, into log data that's in that database itself. So I just wanted to show that. So this really has its place. And I would say that Performance Monitor is pretty much directly related. If we head on over to the Azure portal, in Azure Monitor, we have the Metrics Explorer. So if we go to Metrics in Azure Monitor and select our scope, what it is that we want to look at, let's say go into Contoso RG, and I want to look at Client 1 metrics. We can bring that in, and then we can just choose the metrics that we want to see in the list here. And the specific metrics that you're going to see depend upon what the resource is. And this virtual machine is actually powered off, so that's why I'm not seeing anything at all in terms of those metrics. But this is the Metrics Explorer view in your Azure subscription, okay? All right, the AZ-803 tends to focus more on data collector sets, so let's take a look here. Notice that we have some built-in system data collector sets. One for Active Directory that's useful for domain controllers, one for general diagnostic, another one for system performance measuring. Let's take a look at that one. And notice that when you create these, you then can add elements to them, data collectors. Now, not these system ones, but there's a user-defined section where you can build up your own custom data collector sets, and absolutely you can populate them with different resources. As you see, we've got performance counter, we've got trace, and then there's some other ones here. Configuration, which most of the time turns into this is not a registry key or a value, this is actually in the SIM database, CIM. If you're familiar with Windows Management Instrumentation, and it's just doing basically some inventorying of a firewall. So I just want to draw these ones out to your attention. You also can go out to GitHub and you can see if there's any templates that you might be able to start with and load in rather than having to use either one of these built-in ones or creating one. Let me create a new data collector set, and I'm going to call this AZ-801 DCS. And create from a template is recommended, or we can create manually, advanced. Let me choose that. Where are we getting our data? Is this going to be an alert, or are we creating a logged resulting DCS? I'm going to do that, and I'm going to choose all 3 categories. And first, it's asking us here for performance counters that we want to log. And notice that it's a question, first of all, of choosing which computer. This brings up the point I made earlier about it being best practice that we may create a DCS that's not pulling data from this computer, but from a remote one like mem1. And we can expand our objects, as you can see here. And I can select a counter and choose all instances, or for instance, a particular CPU core. And so you can create as many of these counters as you want and adjust the sample interval. For event trace providers, this is going to require some more specialized knowledge. You're going to pretty much have to know in advance what it is that you're looking for. I'm just going to pseudo-randomly grab the Security Accounts Manager database down here. Let's click Next. And then we can choose registry keys that we want. It's just going to bring those in. It looks like we have to hand type those paths. Where would we like our log data being saved? It looks like it's defaulting to the system drive, perf logs, admin, and then the name of the DCS. And then we can change the credential under which the DCS runs. We can open the properties. We can start the data collector set now. We can save and close. So I chose to open up the properties. And this is just allowing you to get back to all of those choices you made the first time around. We can change the credential. We can customize the log directory and location and format. Schedule is important, like I said, because especially when you're doing a longer running performance baseline, if you're like me, you want to capture the server's state during its peak and valley utilization. So you may want to run a schedule to just do samples, time samples during the workday, during at night, etc., etc., etc. Stop condition, once you have manually started the capture, when do you want it to stop? Or frankly, if you do a scheduled capture, when do you want it to stop? You can just specify when you reach a maximum size, when the overall duration reaches a certain level, etc. And then lastly, we have some very basic automation. If you want to take some kind of action automatically when the DCS stops, it looks like here that we're limited only to the scheduled task library that's been part of Windows for many, many years. So those are all elements of the data collector set, as you can see. Now, if you're going to start one of these manually, notice that we can right-click and start, and you can see that it's running here. And then we have controls to stop, etc. And those reports are going to be tracked down here, again, under System or User Defined, as the case may be. Now, there's not a whole lot in my DCS one because it was running. Yeah, it contains fewer than 2 data samples, so there's literally nothing there. I'm going to right-click and delete that just to save a little bit of space and time. Instead, I spent some time earlier creating some system performance data collector sets. Let's just take a quick look at what the output is here. It just gives us some nice summary data, first of all, depending upon what you've selected. And actually, let's go back there for just a second to review. So the built-in system performance includes a performance counter that brings in, I would argue, maybe too many performance counters. All of those stars that you see here, those asterisks, denote all of the subcomponents under that object. That is a lot of data to be capturing for sure. In the NT kernel trace, what's this one doing? This is just looking at NT operating system events as they're happening. So this is a general purpose DCS for sure. And like I said, if we come down under the report and take a closer look, so we can see top process group. I'm not going to read all this, but I just want you to see and get a feel for this data. And each of these widgets has looks like a table of contents where you can drill down to a particular section there. Unfortunately, this tool is really showing its age, in my humble opinion, because if you want to capture a report, we have a print button, but that is some pretty old school stuff going on. I just want to throw in a heads up on using log analytics here. Now, there is a view data as a report, but that's just the same view that we were looking at before here. We can view data in Performance Monitor, we can view the data as a report, or we can open the actual data folder and get to the underlying contents. So you've got a report.xml and HTML and XSL. That's actually just formatting what you saw. But that's some pretty old school stuff, let's face it. Now, a moment ago, when we were creating that user-defined data collector set, there was the subject of alerts. You may be very familiar in Azure that how powerful alerts are. Well, what we can do here is for our user-defined DCS, we can go to New Data Collector, and we can create a performance counter alert. I'll call this CPU alert. So let's say that in the context of this data collector set, whenever the percent processor time for all instances, let's say, exceeds a certain threshold, if it's above, say, 70%. Now, I don't see controls for time grain like we have in Azure, where we want to make sure that a transient spike isn't going to trigger an alert. Let's take a look. Yeah, this is pretty basic here. Open properties. Let's see here. I've got the alert conditions. Oh, there is a sample interval. Okay. But still, if it's going to be above that value, let me actually get rid of the old entry that's in the DCS and just substitute it with this total percent processor time. We can log an entry in the application event log, and notice that you can chain another data collector set to automatically start if that alert is raised. And then it looks like we also have alert tasks where, again, this is pretty basic, these scheduled tasks. You can configure email or notification, etc. Really, it's kind of a history lesson, if nothing else, of how Windows behaves. Like I said, we want to be looking at the Log Analytics workspace in our Azure subscription. And in there, for our agents, we can configure those right here, appropriately enough, under Agents Configuration. And here we can see Windows performance counters, where we can bring in those counters that we want to track, and we can surface them and report on them and create alerts all in one spot. We're going to do event logs in just a minute. While we're here, I might as well show you here, where we can bring in Windows event logs and customize the streams, whether we want error, warning, and/or information for those event log data sources. All right? So here we are in Windows Admin Center. I have both of my servers, and I added my mem1 to the console. I'm actually signed in, as you can see on the address bar, DC1. It's my gateway. But I used the add with my credentials to bring in another machine. Let's take a look at DC1 specifically. Here we have our overview page that shows live data, again, live metrics data for CPU and memory and Ethernet. That's real useful. And then if we scroll down in the settings, down to System Insights, it shows the 4 capabilities, which are all enabled by default. Now you have to make sure that you've installed the System Insights feature on your machine. Here I am in my PowerShell console. I've run Add Windows Feature System Insights, and I've done that for both my DC1 and mem1 machines. So you want to come in here and make sure that each of these capabilities is showing as enabled. Now, because I enabled this not too long ago, I'm seeing the status description of check back later. We don't have enough recent data to actually show us. But eventually, we'll see graphics that show forecasted values regarding our CPU capacity, networking capacity, disk storage, and disk volume consumption forecasting. That's pretty sweet, isn't it? And when we select one of those, it shows us basically the skeleton of what the UI will look like once there's enough data to make predictions. We have our forecast for our CPU, and then we can see a history of events down below. Under Settings, let's see. This allows us to turn the predictions on or off, whether we want to sample daily. Let me set that down by the minute. I know I'm going to be a little bit aggressive here. I'm going to say, it looks like the minimum sampling interval is every 4 days. Well, it has to be greater than 4. How about 5? And let's save those settings. And then if we go over to Actions, it looks like we can inject some PowerShell scripts when different prediction statuses occur. That's kind of interesting. This all, like I said, is reflective of the continuous integration and continuous delivery that the Microsoft engineering teams are using with Windows Admin Center. So the last thing we want to look at is event logs. So let's come back to the MMC console. And we've got my event viewer here for my local system. And as I mentioned, we have our Windows logs, security, setup, system, forwarded events. And we can use, again, the old-fashioned tools to parse through these. We can right-click, We can create custom views. We can find events in the log. Again, we want to consider using Azure Log Analytics for sure. And then we've got our application and service logs that light up capabilities based on the services that we have available on that machine. All right? Cool. And lastly, notice that we can easily take a look at other machines by loading up the Event Viewer MMC console. We also can see events, so don't want to forget about that, in Server Manager itself. So if we look at my DC1 and do a search for events, I can find the events blade in WAC, where we can select a log channel over here at left, and we can do a free text search for entries and even do an export here. Let me see what looks like it's coming out as an EVTX. That's a proprietary format. And what's cool about EVTX is that you can load it into the MMC so that you can view that data there if you need to. Now, preview, that's something you're not really going to see in the MMC context for sure, is going to be pre-release functionality. Again, it's in keeping with the CI/CD stuff I mentioned before. Okay? Very last thing, and then we're done, I promise, is event log management from the context of group policy. So let's take a look here. I'm just going to pick on my default domain policy, but actually let's say that we want to look at our event logs and manage those on our domain controllers. So let's come into our group policy editor here and let's take a look at computer configuration, policies, Windows settings, security settings, and we've got our event log entries right here. And this is simply where you can specify limits. Now, in my opinion, this isn't as relevant as it was many years ago when disk space was more expensive and less plentiful. But as you can see, this gives you options for specifying maximum log size, as well as providing retention options for those logs as well. Welcome to Lesson 21, Monitor Windows Server by using Azure Services. This lesson bookends what we learned about local Windows Server monitoring in the previous lesson. Here, we begin by deploying the Azure Log Analytics agent to Azure and non-Azure-based Windows Server systems. Next, we instruct the Azure Log Analytics agent to collect performance counters from those agents. After that, we'll create Azure Monitor alerts and implement the Azure Diagnostics extension. We finish up by analyzing Azure VM performance and availability with Azure Monitor VM Insights. Let's get started. I often tell consulting clients and my students, but anybody in a business context, I say the present and future of Azure monitoring is in the Log Analytics workspace. And in order for your Windows Server machines, regardless of where they are, to report to a Log Analytics workspace, we need to deploy the Log Analytics agent. So this is going to include Azure VMs, including out-of-cloud VMs that you've onboarded through Azure Arc. We can do this in a completely automated way directly in the Log Analytics workspace, or for an Azure Arc-enabled server, we could use an extension. Frankly, if you're doing infrastructure as code, you can always include the agent deployment in your Azure Resource Manager template. Like I said, the Log Analytics workspace makes it really easy to deliver that agent to your Azure VMs. And of course, nowadays, we can do just about any kind of configuration management, compliance management, etc. with Azure Policy. If you're dealing with Windows Server machines that are out of cloud, or maybe in other clouds, could be an Amazon or Google Cloud, or on-premises physical or virtual machines, all you have to do is install the Microsoft Monitoring Agent MSI package. And I'll show you this in a demo, but that package, that agent, then is surfaced with a control panel item. So you can configure your Windows Server. This point actually pertains to whether the server is in Azure or not, it doesn't matter. But multi-homed configuration means you can configure the Log Analytics agent to report to more than one workspace. Why would you want to do that? Well, your business may be using a Log Analytics workspace for your main infrastructure monitoring, But then you may also have a second log analytics workspace that's used with Azure Sentinel for security monitoring. Performance counter collection in your Windows Server monitored machines is enabled in the Log Analytics Agent Configuration dialog in the portal. And I'll show you how all this works in the upcoming demo. The data is aggregated into Log Analytics in the perf table. You should expect to see a little bit of Kusto query language on your AZ-800 and AZ-801 exams because, as I started this lesson by saying, Log Analytics really is the foundation of all of your Azure hybrid cloud monitoring. And Kusto is the query language that Microsoft designed in order to make it as easy as possible to run reports on that monitored data. Let's take a look at a couple sample Kusto queries, as a matter of fact. This first one will return a table of average CPU utilization across all monitored computers. And you see that we start with a virtual table. Perf is going to store our Windows Server performance monitor counters. The where keyword is functioning just like it does in SQL, structured query language. We're doing row-based filtering. We can do aggregations. There's a summarize keyword. We can do computed columns. All of this should be familiar if you've used other monitoring and database access tools and languages like, as I mentioned, SQL. The pipe syntax, you notice that the pipe character is used to separate your clause. That makes me think of bash scripting. It makes me think of PowerShell. The Microsoft engineers who designed this language, I know, had all of these existing data access languages in mind when they designed Kusto. Another example, if you just want to fire hose it and see all performance counter data from a single computer, you could run a query like this, perf where computer equals hostname. I'm a big fan of Azure Alerts because as your Azure infrastructure grows, particularly if you're adopting a multi-cloud and hybrid cloud orientation, you're not going to want to, or you may not be able to rely on human memory and human effort alone to keep your environment within bounds. So I want to show you this diagram that I created where we depict the Azure Alert object model. So this is a way to automate looking for problem states in your hybrid cloud infrastructure in Azure. So we start this by defining an alert rule. And that's going to involve rounding up one or more resources. In the demo that's upcoming, I'm going to set an alert that watches virtual machines in a resource group and will trigger the alert if the virtual machine goes into a stopped state. So there's signal logic and then criteria for each of your alert rule. So the resource would be one or more virtual machines. The signal can come from one of a couple places. You could grab metrics data, which is time-sampled numeric. So we could, for instance, use CPU utilization as the basis of our alert rule, or free disk space. But what I like to do is event-based processing, where we're using the Azure Activity Log as our signal source. And the specific events, of course, are going to correlate to the specific resources that you're looking at, right? So in this case, we might say, look at, for all of our VMs, the activity log, and the criteria would be that the machine is in a stopped state. We're going to see that Azure Monitor tracks the status of your alerts through their life cycle. You notice that there's new, acknowledged, and closed. So there's a very basic, a fairly rudimentary tracking system built into Azure Alerts. There is an option when you create your action group to instruct Azure to create a ticket in your IT service management platform. That requires some extra work. You have to install what's called the ITSM connector in your environment, and not every ticketing system is supported by any means. You might just want to use webhooks, actually, to do an HTTP or HTTPS request to start the process of creating a ticket, a bug, whatever it might be. So speaking of which, the last phase here is that when a signal is created, new, the action group gets called into action, and pun intended. And that consists of two options. You can enable one or both of these. There's a notification step and an action step. Now, if you've worked with alerting in the past, just in computing and information technology in general, you think, yeah, big deal, notification. I've been getting email notifications from my devices and servers for years. Well, that's true, but the action means that you can run code automatically when an alert rule is fired, which I think is much more powerful and compelling. Let's take a look at the options here for action group options. As I mentioned, we've got traditional notification, email, but we can do SMS, text message notifications. If you have the Azure mobile app on your phone, you can do push notifications. That mobile app is available for iOS and Android. As far as options to run hosted code, there's the automation runbook. This is going to be a Python or a PowerShell script file. You might invoke a function, which is, again, just a hosted script file, but you've got more SDK support. You could call a C# file, for instance, or a JavaScript file. A logic app can trigger a workflow where you're doing maybe a number of things. Maybe you have a logic app that creates a ticket in your IT ticketing system, also creates an entry in your Microsoft Teams channel, and also does X, Y, and Z. You see what I mean? It's a great way to build simple to complex business workflows. I'd mentioned the ITSM ticket connector, and then we have, as a last resort, the most generic option is where you can just supply an endpoint, and the action group will send either an HTTP or an HTTPS request to that endpoint. In this demonstration, we're going to work with Log Analytics. I'll show you how to install the agent on your Azure VMs and non-Azure VMs. And then we'll also, after that setup, we'll spend some time with alerts and action groups. In the next demo, we'll actually do some work with the Kusto query language. I'm just setting things up here. You're looking at the desktop of my MEM1 Windows Server 2022 domain member server. And let me just jump right into the middle of things here. I'm looking at my Log Analytics workspace that I've created in my subscription. Here I'm in the Azure portal, of course. And I want to show you how you can most efficiently onboard your Windows Server virtual machine. So first of all, if we come down into the workspace settings under Workspace Data Sources, we have virtual machines. Now this is going to show Windows and Linux virtual machines that are in your tenant, in your Azure Active Directory tenant. Now note that there's not a restriction in terms of location. I say that because, working with Azure VMs, you know that there's oftentimes a hard dependency with location. The VM and the virtual network have to be in the same location, as do your virtual machines with your recovery services vault. So this is going to cross subscription lines, cross location lines, all VMs within your tenant, and the OS can be either Windows or an endorsed Linux distribution. And you can see I've configured Log Analytics to automatically onboard machines, but you can do it yourself right through this interface. As you can see, my MEM1 machine is not connected, so I can give it a click Connect, and Azure will deliver that agent to this machine immediately. Now, what's a little bit confusing, honestly, I had to actually pause myself to think about it, is that I have a MEM1 machine in Azure. That's what this one is that we're configuring now. But I also, unfortunately, have another local on-premises MEM1 machine. And that's the one that we're looking at the desktop right now that is not in Azure. It's a local virtual machine. So it just occurred to me that creates somewhat of an awkward situation, but we're going to roll with it. We're going to roll with it anyway. So let me come back using the breadcrumb navigation trail. It says connecting. I had mentioned a bit earlier that this interface would lead you to think that a machine, an Azure virtual machine, could report to only one workspace at a time, because after all, if we select a server, we can disconnect and maybe reconnect to another workspace. You don't have to do that. I'll show you how to do a multi-homed configuration if you want to or if you need to. Now, if we scroll up in the Log Analytics workspace settings, we have Agents Management and Agents Configuration. First, let's go to Agents Management. And this is where you can download the Log Analytics agent. Now, you certainly can download the agent from the Microsoft Download Center. You probably can get it from Winget or Chocolatey or any of those public repos. I've already downloaded the 64-bit agent to this machine. And I'm also going to need the workspace ID and one of the two API keys in order to handshake that client and configure it for this workspace. Now note that there's no dependency on VPN or express route circuits. We're using HTTPS, so we're on TCP 443, firewall-friendly protocol. So let me copy the workspace ID and let's run the MMA setup executable here. Don't be confused by the references here. Although this is the log analytics agent, notice that it says Microsoft monitoring agent. Kind of confusing. And if we come back to the portal, we're liable, if we look in the URL path long enough, we're liable to see references to OMS. OMS, or Operations Management Suite, I think that's what that stood for, was the original name of these cloud-based monitoring platforms. Microsoft loves to rename stuff. I think you know that. So I'm going to agree to the license terms. I'll agree to the default location. I'm going to connect the agent to Log Analytics. There it is, OMS. But notice that we also could use the same setup to onboard this local machine if I had a local System Center Operations Manager site, which I don't. So I'm just going to do Azure Log Analytics. And then we need, as I mentioned before, the workspace ID. And we're going to need one of these two keys. Now see the regenerate? That's really important to do periodically because you want to avoid leakage, certainly. And if the workspace ID and the key leaks, then anybody could onboard to your workspace. So I definitely regenerate mine every so often. As far as the cloud goes, I'm in the Azure Commercial Cloud, not a Gov Cloud or a Sovereign Cloud. I don't have a proxy, so I'll click Next. I like how the agent integrates with Microsoft Update. I'm definitely going to do that. And then let's click Install to finish the configuration. Okay, if you read the fine print here, it says right at the top that we can change agent settings in the Monitoring Agent section of Control Panel. So I wanted to make sure to show you that. Let me type Control in the Run box and change the view to Icons. And we can see Microsoft Monitoring Agent. So this is where you would go on the client device, on the Windows server. Specifically, we go to Azure Log Analytics OMS, and this will verify that the agent is successfully connected. And this is also where we can do a multi-homed configuration, like I was saying before. Okay? So that is that. Let me go back to the portal again. Now, as far as the agent configuration goes, as you can see across the top banner, this is where you can choose which Windows event logs you want to capture and what level of messaging you want. This list originally starts off as empty, so you choose from the ground up what you want to see. And this is going to pertain to all of the onboarded Windows Server machines. Then if I go to Windows Performance Counters, it's the same deal. One by one, you add a performance counter. I've added some of the traditional ones, and you choose a sample rate. If it's an IIS server, we also could collect those log files as well. So that's the basic configuration of your agents. So let's seamlessly go over to Azure Monitor now, and let's take a look at alerts. Now, what's really cool about alerts is that they're surfaced literally almost everywhere in Azure. I mean, you can set alerts related to your spend and spending thresholds. You can set alerts to be notified if Microsoft has an issue on their side. You can immediately trip off an alert. They're just such a powerful mechanism for doing business. Just because I think it's so powerful, let me show you. If we go to the Service Health dashboard, this is a great blade to know about anyway as a Windows Server hybrid administrator. Notice that for service issues, for planned maintenance, for health advisories, for each of these, you can take a look and see what Microsoft has cooking on their side. And notice that you can create an alert so that you can fire when an event shows up here. This list, by the way, is pre-filtered to your subscription, your deployed regions, and then it defaults to all of the Azure generally available services. So it's very convenient. Let's go back to Monitor. This alerts interface is really the central clearinghouse. It's where we can look at existing alerts and we can follow them through their life cycle. For example, I have a new informational alert right here, as you can see. And it says here, if a VM is stopped, fire an alert. And if we come in and look at that alert, We can see some metadata as to when it was fired, the date and time. It's taken a little while to generate some numeric data. We can come down at the bottom and see what's happening. This is actually an example of what's called a log search alert. It's actually another really powerful thing you can do in Azure with log analytics, is that you can make an alert definition based on a Custo query, and this one's exactly what I'm going to demonstrate in the GUI interface. This one is looking at the Azure activity table, that if a machine is stopped and deallocated, that's going to fire the alert. You see? Very nice, very nice. So I'm going to go to Create. Now notice that there's alert rule and action group. You'll wind up probably with a library of action groups. If we go back to the alerts page, this is where you can get to your alert rules and action group separately. Let's create the alert rule and then we'll create the action group in line. The first step, like I showed you before, is scoping to a particular resource. I'm going to scope to virtual machines, so let me open up the resource type and look at virtual machines, and then I'm going to come and select the resource group. And notice that's going to allow us to aggregate all of the VMs in there. I could just select them manually. Come to think of it, I'll do that. I'll just be intentional. But one nice thing about selecting the resource group is that it says here, include all future resources. Wow, that's pretty powerful. Let me keep that. That's really nice. So if we click Next, we can go to our condition. And like I said, we have our signal logic. And the two main ones are metrics and activity log. Metrics are going to be all of the numeric time sample data. The activity log is what I actually want. These are events related to virtual machines. And there's a log search that if you have a saved log search, you can use that directly as the basis of your signal. I'm going to choose activity log, and I'm going to do power off virtual machine. So it shows you some history over the last 6 hours just to give you some context. And then we have here event level. That's not so relevant. Status, we could do failed, started, succeeded. We can do event initiated by a service or a user. I'm going to just leave that very broad. And then when that alert is fired, we can bring in an action group. And I'm going to create a new one. Actually, let me close out of here and go to Add. Let me close out of here and go to Create Action Group. I'm going to call this, well, first of all, I'll put it in Contoso RG. I'll call this VM Action Group. The short name is limited to 12 characters. So I'll just call that VM Action. The notification step, you can either have Azure send email to resource manager role holders, or we could do email, SMS. So this is where you can layer in the different types of notification. You might have an alias email for your administrators, for example. There's a free tier to all these. Then when you exceed the free tier, you're charged. You can just do a search for Azure Monitor pricing for more info. I'll call this notification or just notif. And then, like I said, the actions is where this really can shine, because we can run code or send a webhook depending upon which option you choose here. If you choose Automation Runbook, we might have a hosted PowerShell script that does a start AZ VM operation. So if the VM is stopped and your compliance requirements is that a VM should never be stopped, in that case, the runbook or the function app or anything else that we wire up in our action group could be used to force, or at least attempt to force, that machine back online. So these are some of the value propositions of the actions. In this example, I'm just going to proceed. I'm going to validate the action group, check out my settings, make sure it looks good, and then click Create. Okay, so that brought us out of the action group dialog and now has our VM action group listed. We can go to Details to give the alert rule a name, Stopped VM Alert. Enable alert rule on creation for sure. That's what we want to do. So let's click Create. It says it might take a few minutes for changes to be shown. So we can expect that from now on, if a VM will be stopped, or if I stop a VM in that Contoso resource group, that would then trip off the alert. And I forgot to show you, in the interface, there's a 1, 2, 3, 4, 5 level severity index. And we could associate a severity level. We could actually change that. If we go back to alert rules, Here on the Alert Rules page, we can see our stopped VM alert. So if we want to go and modify its properties, we can simply click into it. Notice that the severity, I forgot to set that when I created the alert, but we can always go back after the fact and we can take a closer look at it. Before Log Analytics, the Windows Diagnostics extension was the only game in town in terms of monitoring your Azure VMs, getting into those event logs and those data sources. However, nowadays with Log Analytics, you might wonder, well, why do we still have this as an option? Why would we want to enable the Windows Diagnostic given that it's so limited? First of all, it's not hybrid cloud aware. It's available only for Azure VMs. Second, the Windows Diagnostics extension sends data directly into Azure storage. You also can have those data points, those metrics show up in Azure Monitor Metrics Explorer. And you also can subscribe to Windows Diagnostics events in Event Hub. But noticeably absent is the Log Analytics workspace. One advantage of the Windows Diagnostics extension is that it's free except for the data that you've ingested into Azure Storage or Event Hub. The data that's collected includes event logs, IIS logs, performance counters, crash logs, and custom app or service-based logs as long as they're file-based. Now again, to answer the question, really for the most part, I would say you'd go for Log Analytics agent across the board. I think that the Windows Diagnostics extension is useful for businesses that for whatever reason aren't yet using Log Analytics, certainly, maybe older Azure customers. Number two, maybe you're already doing log aggregation based on storage account data going from the Windows Diagnostics extension. And lastly, I did mention this to my friends at Microsoft a couple times, and they mentioned in particular that the Windows Diagnostics extension works really well with the Metrics Explorer in Azure Monitor, and Microsoft folks told me that directly. So if that's the case, if you're plotting a lot of live metrics, you may want to consider enabling both the Windows Diagnostics extension as well as the Log Analytics extension. They both can exist side by side. What is Azure Monitor VM Insights? Well, it's an Azure Monitor solution that makes it easier for you as an administrator to monitor your VM performance and health. I think that all of these Insights modules that we have in Azure Monitor were designed by Microsoft for administrators who say, look, I'm not sure what is most important or meaningful to look at with my Azure virtual machines. Simple as that. Now the thing with VM Insights, this actually goes across the board to all the Insights modules, is that they all have a hard dependency on a Log Analytics workspace. So you need one of those to get started. But once you do, I think you'll be pretty impressed because the Insights module is available for all Log Analytics client VMs. So this means not only your native Azure VMs, but also your Azure Arc-enabled servers, your off-cloud and on-premises machines that just have the Log Analytics agent installed on them. So there's a lot of visibility here. And again, I just want to repeat that what's nice about the Insights is that those interactive workbooks were created by Microsoft in order to surface what Microsoft identifies through working with their customers to be the highest impact metric and log data. So they can really save you as a Windows Server hybrid cloud administrator a lot of time and effort in trying to figure out what numbers and what log events are most meaningful. In this demonstration, we're going to look at VM Insights and then spend a little bit of time with Kusto query language. All of this presupposes that you've got a Log Analytics workspace and you've enabled VMs or onboarded your Windows Server agents to report to that Log Analytics workspace. So let's go to Azure Monitor. And I want to draw your attention under Insights. Look at all these different modules. They're workload specific. We're concerned only with the virtual machines Insight element. And so what we have here, first of all, on Get Started, is where you can onboard those virtual machines. And you can see I have one machine that's enabled, healthy, and being monitored, and 4 that are showing up as not being monitored. Now, I actually clicked Enable earlier today. I'm not sure why that hasn't finished enabling, because I know DC1 and RODC1 are running. Again, that's something I'll have to look at after I stop this demo. But actually, the first thing that you'll see, I guess I'm getting a little bit ahead of myself, when you come into Virtual Machines Insights is you need to link a workspace to the Insights module. So that's going to be the very first thing you do. And as you can see, I've tied Insights into my Log Analytics workspace here. Right, then it's going to be a question of taking a look at your VMs, your Arc-enabled machines. Any Log Analytics machine is going to show up here. And notice that you can onboard them for VM Insights by clicking Enable. It says here that it can take between 5 to 10 minutes to configure the VM and then have data to appear. Again, I'm demonstrating that that's taking a little bit longer on a couple of my VMs here for some reason. But anyway, that's getting you off the ground. If we go to other onboarding options, there's some other ways that you could do this. You can deploy the Log Analytics agent on the machine. You could create a Arc-enabled server. So these are just some options down here that allow you to get your machines onboarded as efficiently as possible. As far as what actionable data is surfaced here, we've got 2 pages in this workbook, one called Performance, another one called Map. Unfortunately, I'm so early in turning this on, it looks like it hasn't fully surfaced any data. So let me click here, get more visibility into your machines, try now, and then let me configure workspace. It looks like I still have some more configuration to do. So here, this is where I can point this submodule into the workspace. I know it's suboptimal for me to show you screenshots, but I think that's about the best we've got here. Let me go into Bing Images. And as you can see in some of these screenshots, what we have in the VM Insights module, it's what's called a workbook interface. And they're collections of data visualizations that could be based on a log search. They could be based on metrics data. And it's showing you, for instance, the text is probably too small for you to make out. I can barely read it. This one on the left says logical disk performance. So it's going to give you a bird's eye perspective of disk space utilization on your monitored machines. Down here in the lower left and right, these are metrics charts that show CPU utilization and available memory, respectively. And then over on the right, we have the service map. This is a dependency visualization that will show your virtual machine in the center, and then any machines or any processes, IP addresses that you're connected to as a client or are connected to you as a client. You see what I mean? So that ought to give you a nice feel right off the top for the kind of assistance that you can get in this Virtual Machines VM Insights module. So again, unfortunately, I've got some more setup here to do, and then there's going to be some time before the machines start reporting in. Before we go on to Kusto, I just want to say that over time, you may find that you're onboarding additional modules, particularly if you're using Azure Virtual Machines. Those machines are associated with virtual networks. So there's a network-specific Insights module here, where we can take a look at network interfaces, load balancers, public IPs, and then drill into these visualizations to get more data. For instance, down here, we're seeing a visualization that's showing in a histogram way how my load balancer is behaving. You see, data path, health probe status, NAT, etc. And that's the motif you'll find in the Azure Monitor workbooks. And if you find that these workbooks are so useful, you might want to start to develop some of your own. You can absolutely do that right here. There's a whole bunch of starter workbooks, but you can also clone or copy a starter workbook and modify it, or you can use a public template or develop a workbook template from scratch. That goes beyond what we need here. So to finish out, to get into the log search interface, we can go just about anywhere in the Azure portal. We're already in Monitor, so we just want to look for the setting called Logs. And that brings you into the Log Analytics Kusto query editor. And we're asked to look at a particular scope. I'm going to scope my Log Analytics down to just a single resource group because that's the one that has my virtual machines in it. And what happens is Log Analytics is a log ingestion service. So if we take a look, we've got all of these tables that are associated with stuff we've deployed. So I do have an Azure Load Balancer, for example. I do have a whole bunch of virtual machines and virtual networks. And there's that perf table that I was talking about before. If I open that up, we can see all of the columns. Now, this is really cool because if you've looked at performance counter data that's been exported, it's normally in some kind of JSON or CSV format. What's nice about Log Analytics and Kusto is that these tables are rationalized like relational database tables are. So we've got these various columns that surface different data elements from the performance monitor counters. If we want to get started with queries, though, and we don't have to spend too much time on this, but I just want to give you a flying head start, is there's some sample queries that you can get to right here on the Queries tab, and it's categorized here by resource type. So if we take a look under virtual networks, not virtual networks, virtual machines, let's see here, chart CPU usage trends, that might be useful. So we can load that into the editor and take a look at it. So if you saw any Kusto on your exam, it probably wouldn't be any more complicated than this. It's going to be a question of you seeing the query, recognizing what it is. Okay, I'm looking at a Kusto query, and being able to interpret what kind of data it's going to give back to you. Now let me scroll up a little bit. The way that this works here, there's a lot of comments that I'm going to get rid of because it's making my eyes cross, but the comments are just describing how the query works. We have the virtual table, and then as I said, you've got your pipe-separated statements. And this one's particularly interesting because it's going to render a time chart. That's one of the value props of this log service, because it can dynamically go between chart output and tabular results. Let me select that whole query and let me run. No results found in the last 24 hours. We can change the grain in a number of different spots. Again, my data, unfortunately, is too new. There's just not enough ingested. So what I'm actually going to do is copy out this query, and I'm going to go out to the Microsoft Log Analytics query playground. It's portal.loganalytics.io/demo. You might want to try this yourself. portal.loganalytics.io/demo. It's free. You do have to sign in with your Microsoft account or your Azure AD account. But what you're doing is looking at Microsoft's demo data in their Log Analytics workspace. It's one of their sample workspaces. Okay, here I am in the Log Analytics query playground. I had to go to a different web browser, so if you've got sharp eyes, you see it's a slightly different browser environment, so never mind that. Let me change the time range to something a bit farther in the past, and let's click Run. So there's lots of data in the Log Analytics query environment, so we would certainly want to customize that because that's not very useful. There's just so many machines. Wow. JBox 10. So we could do something like this where I could say where computer is JBox 10 and just add that as a clause in the query. And now we're looking at just a single server. And if we want to go from chart to results, that's totally okay. You see how neat that is? I just wanted to just take a couple moments to show you how powerful this query language is. And the fact that once you've found a query that is giving you the results that you were looking for, it's really easy to share the query with your colleagues. You can build an alert rule where Azure will run the query on a loop. And then we can export the results as a CSV file. Now this demo environment is read-only, so we can't export to Power BI or grab an Excel workbook. But if you were in your own subscription, you absolutely could do that. Welcome to Lesson 22, Troubleshoot Windows Server Hybrid Networking. We have two learning goals in this lesson. First, we troubleshoot hybrid networking connectivity. Specifically, this means we investigate routing problems and learn how to use the Azure Network Watcher diagnostic tools. Second, we troubleshoot on-premises connectivity. More to the point, we review troubleshooting strategies for problems concerning DHCP and DNS. We also learn how to perform a network packet capture with Windows Admin Center. It sounds simple, but hybrid networking is complex. So without further ado, let's get to it. Let's begin by considering some tools that we can bring to bear to diagnose routing problems. Some of these headings and these relevant AZ-801 exam skills may seem a little vague, so I'm going to do what I can to sharpen them down to where you have some concrete stuff to know for your exam. For example, you should know some key PowerShell network diagnostics commands. Test net connection is a fantastic Swiss Army knife. Chances are good you're blocking Internet Control Message Protocol or ICMP, so you're not going to be doing pings. Test net connection can work with ICMP, but as I'll show you in the upcoming demo, we can actually test network connectivity to another host using any designated port. There's also get net route. Let me say one more thing about test net connection. There is a trace route switch parameter that you can add to this. So either way, you're going to get detailed next hop information as far as which router interfaces your outbound packets are going. This could be, for instance, across a VPN, a site-to-site VPN, or an express route link, or by contrast, you could be working with Azure VMs trying to get out to the internet, regardless of the specifics. Now, you have to understand, you're not going to get questions on AZ-801 that deal with how to resolve routing issues on-prem, because this is a Microsoft technology exam. So we, by contrast, need to have a good grasp of how routing is handled in Azure Virtual Networks. Namely, you're using either Azure System Routing or you're using user-defined routing with or without Azure Route Server. I'm going to show you a demo in which we use the Packet Monitor tool in Windows Admin Center. That's a pretty compelling offering where we can perform packet captures from that web console and be able to inspect traffic between two systems at the packet or Ethernet frame level. There is in Azure the Network Watcher tools, and actually you can do a packet capture in Network Watcher as well. I rely on Network Watcher tools all the time when I'm wondering, for example, why is my virtual machine not routing through the firewall the way it should? Or why is this virtual machine still having connectivity issues? Oh yeah, it looks like there's two network security groups instead of one. I'm glad I found that in Network Watcher, this kind of stuff. So more specifically, some specific tools in Network Watcher include IP Flow Verify. This is where you are working with an Azure VM. I want to state that at the outset, that in Network Watcher, we're assuming that we're testing network connectivity starting from Azure. Now, you can provide any public or private IP as a destination, but we're going to start from an Azure VM. And IP Flow Verify is a way to verify connectivity using the 5 tuples or properties that operate at OSI layer 4 and are processed by your network security groups. In other words, source and destination IP address, source and destination port number, and protocol. Either that flow will be allowed or the access will be blocked, and the tool will tell you which NSG rule is relevant. Next hop is great for verifying that your user-defined routes are functioning correctly. Effective security rules allows you to do essentially a resultant set of policy analysis, but focusing on your network security groups. Connection Monitor gives you a long-running test suite between an Azure VM and a remote system. Now, when I say a remote system, that could be another Azure VM in the same virtual network. It could be another Azure VM across a peering. It could be a machine across an express route or site-to-site VPN. Or it could be an internet-based host. Like I said, you're starting in Network Watcher from Azure VMs, but you're going out to any other endpoint. And lastly, like I said, you can do a timed packet capture. Now, you're going to find that the packet capture tools that are built into Azure Network Watcher and Windows Admin Center, I mean, it'll get the job done. There's some basic capture filtering you can do to, increase the signal to noise ratio to have a better mapping there. But if you want some really detailed and powerful packet capture, you know what I'm going to recommend, Wireshark. But nonetheless, packet capture in this context is what we need to know for the exam. And it's a great convenience that we can run this capture directly from Azure or, as I said, from WAC. All right, so let's take a look at some Windows Server network services that we're running on-prem. Now, dynamic host configuration protocol is generally not going to be a concern in Azure because the Azure Wire Server virtual IP address handles private IP address distribution in your virtual network subnets. But on-prem, I almost guarantee you're using DHCP. Are your servers all authorized? Have you identified any rogue servers that are messing up IP address allocation? If you have a routed internetwork on-prem, have you enabled and verified that you can pass DHCP broadcast traffic through router interfaces? Recall that DHCP is largely broadcast-based, and one of the functions of having virtual local area networks is to separate broadcast domains. We need to remember the ports that DCP uses, UDP 67 and 68, and keep that in mind. We can always look at the event logs on the affected Windows systems. There's the system log, speaking of which. There's DHCP server, DHCP client. And then ultimately, if a client machine comes up with an address in the automatic private IP addressing range, 169.254/16, then that's an indication to me immediately that that Windows system is unable to obtain a lease from a DHCP server. What's nice and kind of clever about the APIPA range is that machines that are on the same subnet will be able to communicate with each other with those APIPA addresses. Those are not internet routable addresses, but they do allow peer-to-peer communications within a single subnet. Of course, you're not going to get through a router with APIPA, though. Now, I'd mentioned some PowerShell commands like test net connection. I find still day to day, I sometimes rely, maybe it's muscle memory, but I'll rely on the old compiled executables like ipconfig to do an ipconfig all to see a Windows system's complete TCP IP configuration. And then testing DHCP, you can release your lease, renew a lease, and go on from there. What about DNS? If you're older like me, you remember Mark Manasseh. He's a friend of mine. I'm grateful to say that now. Mark at one time was one of the world's foremost authorities on Windows Server, and one of his big catchphrases was, the problem that you're having in Windows is almost always DNS. And I can buy that for $1 or buy that for €1 or a rupee, whatever your currency is. When it comes to domain name system name resolution on-prem, we're going to assume for the purposes of AZ-801, we're talking about Active Directory integrated DNS zones. You want to verify domain controller replication and make sure that any DNS updates that are being made on, say, DC1 are making it to DC2. This is particularly relevant when you're in a multi-site Active Directory infrastructure. Again, event log is going to leave nothing to the imagination. There's the DNS server application log, and you can also, in the context of your server, enable verbose logging. This isn't something you'd want to leave running indefinitely, but it's going to give you the most verbose data stream in terms of the transactions your DNS server is doing. Specific tools, I had already mentioned ipconfig. It's a really great Swiss Army knife. You've got display DNS to see your client DNS resolver cache. You can purge the cache with flush DNS. You can force a client DNS registration. ipconfig is just, like I said, it's part of any Windows system administrator's toolkit, and if you have years of experience, it becomes a muscle memory thing. NSLOOKUP is an excellent way to query and verify DNS servers and individual host records. NSLOOKUP has the advantage of being cross-platform. In the PowerShell command set, we've got a command that I've really come to love, resolve DNS name, which is essentially a PowerShell wrapper of NSLOOKUP. There are a number of PowerShell commands that end with DNS client cache that enable you, again, to mimic the capabilities of ipconfig, but you're doing it in a PowerShell context. And really, I would say to you that if you have a choice of running these diagnostics with PowerShell versus ipconfig and NSLOOKUP, I would always go with PowerShell because the PowerShell uses an object-based model and also supports a pipeline. So instead of just flat text output, we have data coming out of your commands as objects that have properties and methods associated with them. And the beauty of the PowerShell pipeline is that you can take output from one command and feed it into input for another one. It's a really powerful way to do business with administrative automation. Lastly, there's a command called test DNS server that again mimics some of the NS lookup behaviors. Let's do a demo. In this demonstration, we're going to work with troubleshooting hybrid network connectivity, and we'll start here in Azure. So what I want to do is take us over to Network Watcher. I described it as a Swiss Army knife or a tool set. One nice thing you can do is go to Topology and load up a resource group and a virtual network, and you can see a vector diagram that shows you exactly what's happening in that VNet. You can see the VNet, the subnets, the network interfaces, the virtual machines, the network security groups. In this case, I have some VMs that are behind an Azure load balancer with a public IP address. And what I want you to see is that this is an interactive diagram. You can download it as an SVG file, and then you can import it into Microsoft Visio, and you can actually ungroup the shapes and you can rearrange them. You can't re-upload it to Azure, unfortunately. But it's a convenient way to help you make a network topology diagram based on a real live infrastructure you've got, all right? Now, we don't need to know every single one of these tools. I'm just going to cover a few. So like I mentioned in the earlier part of this lesson, IP flow verify is going to check to see if a packet is allowed or denied to or from a VM. So let me dial up my DC1 virtual machine. We remember that in Azure VMs, it's always the network interface that contains the TCP/IP configuration. And we can test inbound to this machine or outbound from the machine. It populates the private IP for us automatically. I'm going to start by attempting a connection to another Azure VM I have running in that same virtual network that's 10.90.1.6. And let's test connectivity using, say, port 80, TCP port 80. So we're going outbound from DC1 into my MEM1 server, providing those 5 tuples, source and destination IP, source and destination port number, and protocol. Now it says access allowed, and it tells us the security rule that's allowing it. That happens to be one of the default network security rules, allow VNet outbound. And that makes sense because these machines are actually on the same subnet. And if you're familiar with network security group rules, the default rules by default, unless you override them, will allow unrestricted traffic between virtual machines in the same VNet, or even across VNets for that matter. Now let's test connectivity from my local machine to a remote system, like maybe one of the Google DNS servers, 8888, and we'll try TCP port 53. And again, you probably know the answer to this question already if you're aware of the NSG default rules and how they work. Yeah, so access is allowed. The only complaint I have about IP flow verify is that it doesn't tell you specifically what NSG is being called into play, just the specific rule. And it's not helpful because every NSG has those default rules. So we've got some other tools. We've got NSG Diagnostic. This is going to give you more detailed information. So again, we can dial up, say, a virtual machine and call up our DC1. And we can try TCP, again, outbound. And in this case, it's assuming the public IP of the load balancer that the VM is behind. And that's fine. I'll leave that alone. And I'll try, again, a public destination IP address, port 53. And let's just compare what the NSG diagnostic gives us back as opposed to IP flow verify. Let me scroll down here. So the traffic is allowed, and here it is giving you more detailed or more verbose options. Next hop, like I said, is great for testing routing paths. Once again, let me come back to the DC1 machine I've been testing, and let's again try to go out over onto the internet and see what our next hop is. This comes into play particularly when you take over routing from Azure System Routes and you start to use routing tables or the Azure Route Server to create those. In this case, I'm not using any user-defined or BGP dynamic routes, So the next hop is internet, and we're using the system route. So that's just validating what I already know. Effective security rules is a way to model what is exactly affecting a machine in terms of NSGs. Recall that a network security group can be associated at the subnet level as well as the network interface level. And so that can be an unpleasant surprise when you're troubleshooting and you realize that you've doubled up your NSGs without necessarily knowing about it. In this case, it looks like we've got just one subnet associated NSG, and then we can expand to go in and analyze the specific rules there. In a hybrid cloud context, you may want to take a closer look at your site-to-site or express route connection. And what you need to do the VPN troubleshoot, this is actually looking at the Azure side of the VPN. You need to have a VPN gateway and a connection and also a storage account where the logs will be kept. And this is a longer running operation that you can see under the hood what's happening in the virtual network gateway in Azure as it communicates with the other side of the endpoint. And then lastly, we have this packet capture capability. And what we'll do here is specify what virtual machine we want to analyze, give the packet capture a name, and you can store the capture file. It uses the Wireshark type format. I know CAP is not necessarily just Wireshark, but I've used that format and varieties of the CAP format in Wireshark a lot over the years. You can put the CAP file centrally in a storage account. You can put it in the file system of that virtual machine, or you can actually put a copy in both spots. There's a time limit here. There's maximum bytes per packet and per session. None of these are required except the storage account. Same with filtering. You may want to cut down on noise. Instead of vacuuming up all frames, you can do a definitely simple compared to Wireshark capture filter here to specify and cut down maybe your IP addresses and ports that you want to include in the capture. And then the idea is that you can load that cap file into Wireshark and parse the frames one by one. It's great that we get that because, normally one of the trade-offs of using a public cloud service is that you lose that level of granular visibility because you don't own the infrastructure. You're basically paying for consumption, and you'll never get within miles or kilometers of the actual hardware. It's nice that Microsoft gives us the ability to capture packets. And lastly, there's connection troubleshoot. I know I said lastly for packet capture. This time I really mean it. And this is going to do a longer running evaluation of checking a TCP connection from a VM to some other endpoint. So they're all kind of variations of the same theme here, as you see in Network Watcher. They're all, generally speaking, hovering around OSI layer 4 with IP addresses, ports, and protocols. Now let's turn our attention to local networking in Windows Server and Windows Client. Here we are on a Windows 10 domain member workstation, and you can see in my PowerShell console here, I'm client 1. However, if I run ipconfig, I've got an APIPA address, and that's telling me that I don't have a connection to a DHCP server. So I'm a little bit in trouble here. Now, I could attempt to apply a static IP configuration. I could do ncpa.cpl. Of course, the problem I'm going to have with that is I'm running as a standard user here. So who knows? I probably don't have domain credentials to make that change. So what's the problem? Well, I can tell you what the problem is. There's not a DHCP server available, so let's sort that out quickly. Here we are on our mem1.contoso.com Windows Server 2022 member server. I do have a scope, and I don't have any server level options, but I do have, I'm quite sure, some scope options. So I'm providing a default gateway, that's the router. I'm providing some DNS addresses as well as our domain suffix. However, see the little down arrow? I haven't activated the scope yet. So I'm going to right-click and activate. And to verify our authorization status, we can right-click the DHCP node. And let me make sure that I'm authorizing mem1.contoso.com. I'm signed in here as an administrator, a domain admin. So I shouldn't have any issues with that. Great. Well, let me, instead of flipping from desktop to desktop, let me open up a terminal services connection to client 1 directly here. And I guess I'll authenticate as myself. That way I don't have to worry about user account control. All right, let me maximize the RDP session and let me open up a PowerShell console. And you know what I'm going to do next. I'm going to run an IP config. Let's do an all. And verify we've picked up a configuration. Sure enough, we're communicating with our DHCP server now. We've picked up an IP address, a mask, a gateway, and DNS servers. So it looks like we're ready to rock here with this client configuration. Awesome. Now let me minimize my client session here. And let's come back to Mem1 and let's go into Windows Admin Center. Here I am. I have Mem1 set up as a gateway. Let's go into the gateway. And I want to show you how we can initiate a packet capture using Windows Admin Center. It's pretty cool. So in the server tools list, we'll filter for packet and select packet monitoring. And let's select new capture here and then add. So what's this going to be? A bunch of optional filters. Now we've got a filter condition here, and then if we scroll down, we can add additional filter conditions. I'm going to fill this out a bit because I want to constrain the traffic that's going to be captured. So my 2 IPs are going to be my one for this server, Mem1. Let me see, that's 10.1, 10.158. And then the client system is 10.1, 10. I actually forgot what it was. Let's go back to the client session here. 10.1, 10.190 it looks like. So let's put that one here. As far as ports, what we're looking at, I'm going to leave that open. And MAC address, just because I happen to have them handy, I'm going to paste them in here. So the one MAC address is for Mem1. The other MAC address is for the client. And I'm specifically interested in looking at DHCP traffic here. And I could go with just UDP, actually, come to think about it. I'll leave that at any just because. I will constrain us to Internet Protocol v4. I think that's good. So let's click Start. And so we're starting the capture, and we're capturing this all in the context of our Windows Admin Center server. So let's head on back over to the client. Let me clear the screen and do an ipconfig release. This is going to dump the IP configuration of this system. And that's immediately going to cut off contact between this domain workstation and the rest of the domain for sure. As a matter of fact, I should have realized it actually cut our RDP session. So hang on, let's switch over to my client 1 session that is not dependent on an IP configuration here. Okay, here we are. Sorry about all the dueling windows. It's just one of the things we have to deal with here. So this is, again, that client system. I did an IP config release, so I should just go back to having a PIPA address. Right, I sure do. So let's do an IP config renew, and that would generate some DHCP broadcast traffic that I assume is going to get picked up by my server. And before too long, we should have a new configuration. It's going to be the same address because I've got a completely quiet little LAN here in my lab. But anyway, that's that. Now let's switch back to the server one more time. We actually should be able to do it right here at the client, yes. Because I've got Mem1 set up as a gateway, let me head on over to that server here, and let's again look up our packet monitor. Because see this preview tag? This means that this capability is not in generally available or supported status. It's still under development. And frankly, I'm surprised that it's even mentioned on the AZ-801 objectives for that particular reason. But what we would expect to see here is a list of frames, and we can select the ones that we want to look at and view the packet details. Let me see if I can get to a log file. Nope, I can't even do that. It just totally bombed out on me. I could try to restart, and we could try it again. Maybe instead of DHCP, we can do some work actually with PowerShell. And it's actually a good experience. Let's take a look at some client tools. We're going to leverage this teaching moment. We really are. Let's try NSLOOKUP to do some DNS stuff. NSLOOKUP we can use against domains. So contoso.com is the name of my local Active Directory domain. And we're able to do forward and reverse lookups here because I have forward and reverse zones created on my Active Directory integrated DNS servers. So we can do NSLOOKUP on IPs, as I said. We can do a reverse lookup. We can do an NSLOOKUP to look for particular record types. If we want to, for instance, do a query type equals NS, contoso.com. Show me the name servers, show me the mal servers, this kind of stuff. And this is going to work. This machine doesn't have internet access yet, so I'm not going to be able to go out over to the internet, but it's the same idea. And then to compare that with some of the PowerShell capabilities, test net connection has a computer name flag where we could say test connectivity to dc1.contoso.com. And maybe instead of trying ICMP, let's try a connectivity on, say, port 443. Test net connection is a great alternative to ping for that reason, for sure. Now, it looks like that test failed to succeed for some reason. So that would be a good case for us to take a closer look, as a matter of fact. Interesting. I wonder why that could be. Let's just try a straight up test net connection. That one, the ping succeeded, but for some reason, connectivity on 443 didn't work. These are all methods of troubleshooting issues that can give us more intelligence than we had previously. You might be familiar with traceroute, where you trace a path, a router path to a destination. It's not very compelling here because my local machines are all on the same broadcast domain. But we can replicate the traceroute capability with test net connection, where we're testing connectivity to a remote machine. Just throw on traceroute at the end. And it's very similar to the traceroute exe command. Again, it's not compelling here because we're not traversing multiple hops, but hopefully you get the idea. To finish this out, let's take a look at some event logging capabilities built into Windows Server. We have similar capabilities on DHCP, but I want to take a look at DNS specifically. If we look at the properties of my Active Directory DNS server, we've got event logging, where you can adjust the verbosity of DNS events in your event viewer application. Looks like I'm capturing everything. And then as far as the verbose logging, also called debug logging, again, you only want to turn this on when you actually need it. But this, as you see here, gives you much deeper insight into DNS communications. You provide an out file here and a maximum size that the file can grow to. And then you can inspect that file to your heart's content afterward. Let me finish by opening up Event Viewer. And I also, while I'm here, I'm looking at the local computer. That's fine as far as DNS goes, but if I want to look at DHCP, I want to connect to my mem1 server that's running the DHCP server service. And we can get a filtered view here by going under Custom Views and taking a look here at our filtered DHCP server log. Again, this can immediately give you some explanations for some ghosts in the machine, as it were, that you might be seeing. Another place to look is under Applications and Services Logs, Microsoft, Windows. And then for both DHCP and DNS, we've got DHCP server and DHCP client logs that are going to leave nothing to the imagination. Admin looks like no operational yet for DHCP client. Just a few operational notes here. terms of noting when I activated that scope a few minutes ago, and so on. Welcome to Lesson 23, Troubleshoot Windows Server VMs in Azure. In this lesson, we focus on solving various Windows Server-related problems using Azure. We start by troubleshooting both deployment and startup failures. Then we move into diagnosing and resolving VM performance, extension, and disk encryption issues. Finally, we analyze Azure VM storage and connection problems, as well as their Microsoft-provided proven practice solutions. Let's get to work. Let's start by taking a look at the issue of you're attempting to deploy a VM in Azure, and it doesn't really matter so much whether the underlying disk, the virtual hard disk, comes from the marketplace or that you've generalized it. It just, the deployment bombs. What is the most likely explanation? Well, there's two types of failures that you may see that you need to know about, both for your AZ-801 exam success and also in your career as a Windows Server hybrid administrator. One is a provisioning failure. In this, the vast majority of cases is user error, operator error, that you've simply selected one or more invalid deployment settings. Now, if you do that in the portal, most of the time the portal UI will let you know that you're failing validation pretty obviously right out at the gate. However, it can be a bit more work to figure out what's gone wrong if you're doing programmatic deployments, if you're automating deployments through CI/CD processes, or if you're just deploying bicep or ARM template files. A good way to proactively fix possible provisioning failure is, rather than click around in the portal, which is much more subject to human error in my experience, make sure that you're defining all your deployments as code, preferably using Azure Bicep or the ARM template JSON in a last resort. And make sure that you've double and triple checked the validation status of those templates to minimize the likelihood of your deployment failing due to a provisioning failure. Now, an allocation failure is a problem squarely on Microsoft's side, that the region you're deploying to, due to capacity with other customers, that region may not have enough available hardware resources to complete your deployment. Another possible reason for an allocation failure is if the region doesn't provide or support the requested VM size. And again, the best remediation there is to perform due diligence and make sure that you're, in your deployment templates, using sizes that are available in your target region or regions. You know, in ARM template code, you can create an allowed values array, for example, that constrains your inputs only to your authorized regions. And you also can use Azure policy to enforce correct regions with correct VM sizes and so on. Some other remediation techniques provided directly by Microsoft are a reminder to look in the Azure activity log in Azure Monitor. Recall that the activity log records every REST API request into Azure Resource Manager. So it's a great place to see who did what when. This also records deployment operations. You know that you can go to the resource group definition in the Azure portal and you can look up a definition. In fact, I'll make sure to do that in the upcoming demo to make sure you know where to find that. If you are doing uploaded VHDs, again, it comes down to research and due diligence. Make sure that your uploaded VHDs are generalized properly. And when I say formatted properly, I mean that you're using Gen 1 or Gen 2, but it does have to be VHD and not VHDX. You can't do dynamically provisioned disks. You have to do fixed. So again, it comes down to the old carpenter's aphorism of measure twice, cut once, if that makes some semblance of sense. So if your Azure virtual machine doesn't start up, I know from my own experience, particularly when I was newer to Azure, I felt a sense of panic. How do I know, for example, if the server is in a blue screen state? Is there an issue with BitLocker drive encryption? These sort of things. And what was the root of my panic? the fact that I'm accustomed to being able to physically console to the servers that I manage, And when you're dealing with Microsoft Azure or any public cloud, you're not going to get anywhere near the physical hosts that your VMs are on, for example. So we need to be a bit more creative. Now, a key strategy here is to make sure you're enabling boot diagnostics for your Windows Server VMs. Doing so requires a storage account. Nowadays, you can let Microsoft manage that storage account. It used to be, it always had to be an unmanaged storage account in your subscriptions. But that boot diagnostics is going to store diagnostics data, but principally, you're going to get VM screen output screenshots. So you should see, if all else is going well on your Windows Server virtual machine, you should see the press Control-Alt-Delete to start on that machine. So that screenshot that's stored as either a PNG or a JPEG, I don't remember exactly what, we'll see in the demo, provides a nice quick check to see what the screen state of the VM is at any point in time. Now, the other thing that boot diagnostics unlocks is the serial console, and this is a big exam alert. Make sure you understand this. Now, the serial console gives you a backdoor access to the VM. This is particularly useful when your normal means of administering the Azure VM, particularly RDP, SSH, or Bastion, fail. And I'm going to walk you through how to use the serial console upcoming. But know for the exam that boot diagnostics is a prerequisite to enable the serial console. And you want to make sure that you've got that enabled on the front end so you're not scrambling on the back end if you have a problem with your VM. Well, performance is another whole kettle of fish. We could do an entire workshop just on this. Recall that the 4 key compute subsystems for any compute system, let's just narrow it to Windows servers. We're going to look at CPU, processor. We're going to look at RAM, memory. We're going to look at disk, and then we're going to look at network. And the baseline that we're looking to generate for our Azure VMs, hopefully that baseline will incorporate both peak and valley usage, will help us make strategic decisions like sizing the virtual machine, like choosing premium rather than standard storage, like choosing an Azure VM size that supports SRIOV or accelerated networking, you see. We want to be sure to take advantage of the seeming limitless compute that the Azure public cloud offers, such that we want to attain our desired performance goals, but of course we don't want to overpay or over-provision either. So how can we generate a baseline? Well, in terms of Windows Server, we can do performance monitor data collector sets all day long. Another technique that we cover elsewhere in this course is System Insights, the AI-driven predictive analytics monitoring solution that is available in Windows Admin Center. And then we have Performance Diagnostics that's available right in the Azure portal. Long story short, we must never forget that with the public cloud comes the privilege, I guess, for lack of a better term, to take advantage of Microsoft's huge data sets and vast, whatever term you want to use, data corpuses of signal logic. So Microsoft winds up training machine learning models that can give very accurate predictive analytics. And why not take advantage of that intelligence because it's available to us as customers? That's what I'm trying to say. I'm using 100 words when 10 would do, but hopefully you got the point. Let's continue. Recall that the extension model is how we service our Azure virtual machines. And it's the VM agent that is the heartbeat, for lack of a better term, between your Windows Server VM running in Azure and the Azure backplane. We can use the PowerShell command get AZVM -status to observe what the current connectivity status is between the VM agent and Azure, and that's certainly useful. This agent status is also revealed in the portal, among other places. In the VM's own file system, if you're troubleshooting issues with extensions specifically, you'll want to know the default location where those extensions get loaded in. See Windows Azure Logs Plugins and see Packages Plugins. Now, first of all, here we recall that although Windows Server VMs in Azure do use BitLocker drive encryption in Azure, it's implemented somewhat differently. First of all, the technology is called ADE, or Azure Disk Encryption. And second of all, we're storing our BitLocker drive encryption key in Key Vault. I had mentioned elsewhere in the course, I'll mention it again now, you want to be sure that if you're delivering group policy to your Azure VMs, say you've got a site-to-site VPN or an express route, you want to make sure that you're not enforcing TPM-based protectors on those Azure VMs, because the Azure VMs are being handled in terms of Azure Disk Encryption quite differently indeed from what you're doing with your local servers. Now, some more Azure-specific wrinkles here in terms of troubleshooting Azure Disk Encryption is that ADE is not available on all VM sizes, and ADE supports only Generation 1 VMs. I keep repeating myself, that term due diligence. There's a lot of architecture involved here, isn't there, in terms of studying those VM sizes, making sure that the appropriate sizes are available in your region or regions, making sure that those sizes support the features that you need, including ADE. And the question of Gen 1 versus Gen 2, that can get tricky because, as you know, some of the main selling points, so to speak, of a Generation 2 VM are things like secure boot, trusted platform module, this sort of stuff. And it's a bit disappointing that we've got this restriction, but it also makes sense given what I said a couple minutes ago, that ADE doesn't work with trusted platform modules. So I guess Microsoft hedges their bets by not supporting Gen 2 VMs at all in that way. Here's that guidance I already mentioned about GPOs. You also want to think about firewall concerns, particularly in a hybrid cloud environment. You know that in Azure VM, you've got the software firewall that's built into Windows. You have potentially one or more network security groups. You have potentially Azure Firewall. And you want to think about, at the least, your Azure VMs have to reach the appropriate Azure endpoints so that ADE can do its work in unlocking the drive at boot. Specifically, there's 169.254, 169.254. That's the instance metadata service endpoint. And then there's the Azure Wire Server, 168.63, 129.16. So those aren't IP ranges. Those are well-known IP addresses. It's critical and actually required that your Azure VMs can communicate with those endpoints. In terms of Azure Virtual Machine Disk Storage, the first bit of guidance, just to avoid troubleshooting possibilities, is to make sure you're using the managed disk system as opposed to unmanaged. Now, way back in the day, when we used to walk to and from our Azure administrative workstations uphill both ways, we would store our Azure VHDs in the blob service of a storage account. This is the unmanaged disk system, and it's fraught with all sorts of security issues that we don't need to go into. But it is possible to still maintain VM storage as VHDs in unmanaged capacity. We don't want to do that. We want to use the platform-hosted managed disk service. It just makes availability and security and ease of use so much better. You also want to be aware that you can always flip the switch to go from standard to premium. That would be mechanical to SSD storage, or SSD back to mechanical, depending upon your cost, availability, and performance concerns. If you need to delete Azure disk storage and you're running into failures, the most common culprit there is an errant lease or lock. And you'll find, just read the error text quite carefully in the Azure portal. You'll find in many cases the portal will link you exactly to where you can delete the SAS token request. Maybe there was an export or a download that one of your colleagues initiated and forgot about. Or for some reason, like I said, there's a rogue or errant lock that you can force break, hopefully without having to file an Azure support ticket. Ways to troubleshoot VM connectivity. Again, this can cause panic in newer Azure administrators when you're unable to get an RDP session to an Azure VM and you really need to complete some high priority work. Recall that Network Watcher is an Azure cloud-based tool set for network connectivity diagnosis. There's the connection troubleshoot tool that's also surfaced in the Azure Portal Connect blade. I'll show you that in the demo. This just will run a quick routine to see if there's anything from the client side, that is in your VM, that could be standing in the way of the connection. There's also a Network Watcher effective security rules, and this can help unpack a possible blockage, a port blockage, IP address blockage that is happening with, say, network security groups. Remember that Remote Desktop Protocol uses TCP 3389 by default, and Secure Shell uses TCP 22. The Azure Portal has a series of PowerShell scripts that you can just inject directly, including some really helpful ones like verifying RDP settings, changing the RDP port, enabling a disabled local administrator account, and maybe temporarily disabling NLA for RDP sessions. I have a feeling, and I'm just kind of speculating here, that the purpose of those run commands is to help Microsoft's own support people because they really center on the 80% scenario in terms of if somebody's having problems RDPing into their Azure VM, and it's not something obvious from a networking level, from a firewall level, then the chances are pretty good that running one of these management scripts will sort you out. In this demonstration, we're going to tour several of the troubleshooting techniques that we looked at previously. I just want to associate a proverbial face to a name. So I'm signed into the Azure portal here, and I actually want to start by browsing out to my resource groups. And let's take a look at my Contoso RG resource group, and I want to come down under deployments. Now, we can always follow an existing deployment, even if we haven't initiated it, because as you can see, here in the context of the resource group, Azure keeps a running total of every deployment, no matter whether it was made in the portal or with PowerShell. It doesn't matter what the method is. It will show up in this list. And fortunately, all of these are actually succeeded. Let me go out to another resource group that's been around a lot longer. And let's see if I can look for a failed deployment here. There we go. So here's one right here that happened on the 10th of January. And you'll notice that the actual deployment ID is linkable, but then for failed deployments, we can go to error details directly. Let's see, what's this actually telling us? Let's go to the raw error. And when it's raw, it's pretty raw. It's just the naked JSON. This one, unfortunately, is not a good example because it's telling us essentially nothing about what actually happened. That's kind of disappointing. How about this policy deployment from January 9th? Cannot modify extensions in the VM when the VM is not running, operation is not allowed. Well, that was definitely a helpful error detail. It's pretty clear that I tried to modify Azure policy and the VM needed to be in a running state, so there you go, okay? So the deployments, if you actually click the deployment link, allows you to, again, look step by step down here. This is a definite record of exactly what happened when. We can go to operation details and look at the messages and properties. If there were any inputs passed into the deployment, if there's any outputs that were emitted by the deployment, and then ultimately we can see the underlying JSON. Now what you'll find here is that if you or your colleagues deployed the template yourself, like maybe you authored your own bicep or JSON template, that'll be preserved in here, which can be convenient because as you see, you can build an Azure portal-based template library that can help avoid some of the troubleshooting issues that we've surfaced so far. You can download the JSON of any deployment, or you can run a deployment based on that template right here in the portal. And if you don't like just the parameters that are surfaced in this UI definition, you can go to Edit Template, and you can modify the code and then go ahead and complete the deployment. So those are some techniques here that we can get a handle on when things have gone wrong in the past, or maybe even they're going wrong right now. Because like I said, the resource groups list here, this deployment list, will show deployments that are actually going on right now. I had mentioned that in Azure Monitor, another source of authority for any Azure Resource Manager control plane action is going to be in the activity log. So as you can see here, no matter who did what when, that operation is going to show up here. So I started a virtual machine 4 hours ago, and we can see all of the associated step-by-steps, including the original start virtual machine action. As a convenience, notice that we can create an alert rule that will fire whenever this particular entry shows up again in the future. The downside, if I could say there is one to activity log, is that outside of just the high-level points that you can see here, the timestamp, the operation, and the event initiated by, you need to get down into JSON to see more verbose data. Now, here's a good tip for you, that if you're going to use Log Analytics as your monitoring platform, you can surface your activity log and actually write queries that go across all your activity logs and all your subscriptions. So it's a convenient tip for you to be aware of. Okay, so let's hone in more carefully on virtual machines. So I've got a number of VMs here, several that are running. And to check the agent status, I'm going to bring up the Cloud Shell here. And I'm going to switch the container over to the PowerShell environment. One nice thing, among many, with Azure Cloud Shell is that it just gives you a fast command prompt where you're already authenticated. I do want to do a get, if I can get my cursor down there, get AZ context, and I'm going to format that output as a list just to do a double check to make sure that I'm hooked into the correct subscription, which I am. I'm going to do a get AZ VM where the resource group name is Contoso RG, and the name of the VM is DC1, and here I'm importantly going to include status. And we can see here power state is running, so we're seeing everything we need to, that the Azure VM agent is running, it's operational. Let's see, agent cannot connect to the Operations Management Suite service. Okay, well that's a little bit concerning because that deals with monitoring. I'm actually using not Operations Management Suite as such, it's Log Analytics, that's the old name for it. So that's actually a little worthwhile to see. Okay, well let's dig in. Let's go to the DC virtual machine here in the portal and let's take a look at some other options. If we come down here, let's see, networking, disk size. Really we want to come down under monitoring and automation. So we've got, let's see here, log search, diagnostic settings. That's fine. Let me go down even further. Here we go. Yes, this is what we want to look at. Support and troubleshooting. Okay, so depending upon what problem it is that you're dealing with, at least in terms of if you have some general idea, maybe you're not concerned about the internal state of the VM. You're wondering if there's a problem on Microsoft's side that's affecting the availability of it. You can go to Resource Health, and this gives you a running list of the availability from Azure's perspective of your VM. And we can see the health history over time here. And a lot of this, hopefully, is innocuous. The virtual machine is starting as requested by an authorized user. So the information isn't as useful, but certainly if you get any warning or error messages, that could be useful. And I just want to throw a heads up here that you can create an alert so that you don't have to remember. I mean, if you have, I don't know how many Azure VMs to manage, you're not going to come into the Resource Health Blade manually. Why not set an alert that whenever any of your virtual machines has a warning or an error resource health message, you trigger automation and get notified. That's what I want you to think about. If we go to Boot Diagnostics, I have it turned on here, so you can see there's the screenshot I was talking about. It tells us the last time and date. Unfortunately, I'd have to convert the UTC to my local time, 42 minutes after the hour. Well, let me check my time. That's current. That was just a minute ago. And then if I download the screenshot, what does that come down as? Just for grins, I'm wondering. BMP, it comes down as a bitmap. Wow. Come on, Microsoft, that's not an efficient space savings. If we go to settings, there's really nothing to do here other than turn off Boot Diagnostics, and instead of using a Microsoft managed storage account, use your own. Let me show you. Hopefully I can find a machine that does not have Boot Diagnostics turned on yet. Let me go over here to Mem1. Nope, that one looks like I've done my due diligence pretty well here. How about RODC1? Hope I'm going to not strike out here. Oh boy, looks like I've done my work too well. Let me try one more. client 1, come down to boot diagnostic. Okay, it looks like I've got it enabled globally, but all it is simply choosing the settings option of how you want to handle this with a storage account, okay? All right, so we were focused on DC1, weren't we? And that is running, so we can test connectivity to it. A couple ways I want to do that with you. If I come down here, as long as we've got boot diagnostics enabled, we then can use the serial console. And we see an important message saying that serial console requires, here it is. This is talking exactly what I mentioned a moment ago, nuts. Click to view and change your boot diagnostic storage account configuration. Click here. Well, I know exactly what it's saying. It's saying that it looks like there's currently a compatibility issue. And although I thought I was being forward-thinking using the Azure Managed Storage account, it's incompatible. So sometimes, and I'm leaving this in the training here, I don't want my demos to be all glistening because that's not how the real world works. Sometimes you get dead-ended temporarily when you see that kind of stuff. But now we know how to remediate it. We can come over to settings and we're going to enable with a custom storage account. And I'm going to use my TIM Storage 001 general purpose storage account. So let's save our settings there. And let's see what happens next, shall we? All right, that configuration is complete. So let's step out, go back to Serial Console. Here we go. Let me minimize our settings. Okay, so there's a bit of a learning curve to the serial console. Now, if you're old like me, you might remember RS-232 serial cables and plugging said cable and a monitor into a system to do some low-level work, some diagnostics work, or you'd serial into a laptop, whatever the case may be. This is a similar kind of idea. The controls here are very similar. It's probably shared code with the Cloud Shell. Text size, font, we can do a function key, we can restart the VM, we can send a command. I'm going to simply do CH to get a channel list. Again, this is so retro, it's kind of funny. It brings back floods of memories of, well, I'll spare you the details, you don't care. Let me type CMD, this is really what you want to know. You want to type CMD to create a new cmd.exe channel, okay? So it says a new channel has been created. Let's do CH to get a list, and we can see that we now have our CMD channel on channel 1. Well, how do you switch to channel 1? You can do channel help by doing CH minus question mark, and see we have CH minus SI number to switch to a channel by its number. So that's exactly what we'll do. Let me get my cursor back down there. CH minus SI1, okay? We are going to be forced to authenticate to the VM. Hopefully that makes sense. In a moment, I'm going to press return or enter to view that channel, and I'm going to authenticate as, let me see, Tim, and then my domain is contoso.com, and my password is, let me think for a minute, hoping I'm typing the right password. Good. And now we have a CMD session. At least we did. Did you see it? There we go. And the idea here is that we then are going to probably get much more work done if we switch to PowerShell. There are some commands that are available to us like bcd edit and so on, but the normal guidance is to bring up a PowerShell command. And now you can do things like maybe you think that you can't sign into the VM because there's a service failure. So we can use get service to enumerate services, start and stop service. What we do from here totally depends on our needs, all right? I just wanted to come this far to show you how to enable and access the serial console. So out of there we go. And then to finish up our troubleshooting, there's a couple more things. If we go to the Connect dialog here, let's go to Connect RDP. We can come down under Can't Connect. And I'd be the first to admit that I normally ignore all of this extra text, but I don't think you should. These are actually pretty useful options. Test your connection kicks you into the Network Watcher connection troubleshoot. And so you can test inbound and outbound connections, actually. I would be concerned with inbound. And it defaults to my IP address. So this is my public IP that I'm coming over the internet into this machine on, but I can override it. And the destination port in this case is going to be, let's see, it's going to be RDP, isn't it? So let me find that in the list. Looks like these entries are alphabetized, which is good. So yeah, that's TCP 3389. So let's check connectivity here. It may take a little while to do if you haven't used Network Watcher, because Network Watcher will need to install the extension on the machine. And once the connection test finishes, we can see that network connectivity is in fact blocked by a network security group rule, deny all inbound. Now that makes perfect sense, because the truth of the matter is I am currently unable to reach this virtual machine, actually for a couple reasons. I mean, you see that there is a public IP address here. That's actually a load balancer. This machine is behind a load balancer. And we would definitely want to check the networking blade and see what the status of those inbound and outbound port rules are, and then make accommodations from there. You see how that works? All right, so let's check out two more options. Actually, just one more option. It's the run command. So if I do a search for run command under operations, and as I mentioned, this is simply a small collection. We'll call it a curated collection of PowerShell scripts that allow us to inject the script via the VM agent, the Azure VM agent, to run once and terminate. And what's cool about this, what's different, I should say, about this option from the custom script extension in the extensions library, is that with the CSE, when you do a custom script extension, it's quite difficult. You don't get immediate console level feedback, but you do here, which is pretty useful. So you can see there is an analog to the custom script extension. We can run a command script. In fact, I need to remember to use this more. This is awfully convenient. Let me actually demo this. Let's do a get Windows feature. We're wondering, let's say, if the IIS web server is installed on this machine. It doesn't have to be a fully fleshed out script. It can be as simple as a command here. Let's click run. And then while we wait, we can come down here and take a look at the output. And we can see that the IIS components are in fact installed on this machine. Nice. So if we scroll down a little bit, we can enable PowerShell remoting. I don't need to read these, but it would be worth your while to check these out. And if you want to know in more detail what they do, you can always search them out in the Microsoft docs. You can see, if you expand the scripts pane, what they're doing. This shows the actual script itself, but the docs gives you some additional elucidation. Welcome to Lesson 24, Troubleshoot Active Directory. We conclude this AZ-801 Cert Prep training course with a lesson on diagnosing and resolving various Active Directory-related problems. First, we restore deleted objects by using the Active Directory recycle bin. Next, we recover the Active Directory database and SYSVOL by using Directory Services Restore Mode. Then we finish up by troubleshooting Active Directory replication, hybrid authentication issues, and lastly, on-premises Active Directory domain services itself. Let's do this. Now, if you're old like me, you remember the days that if you deleted an object in Active Directory, you were in some trouble. That is to say, if you didn't perform an authoritative restore, well, first of all, you'd have to reboot the domain controller into Directory Restore Mode, Directory Services Restore Mode, or DSRM to be technical. And you'd need to use ntdsutil to bring back that object, but only if it was within its tombstone lifetime, its retention period. Well, those rules still apply. They've been relaxed a little bit. But for quite a few years now, we've had the Active Directory recycle bin, which is something you can turn on in your forest, in your domains, that allows you to recover deleted AD objects like organizational units, user accounts, and group accounts. We can enable the AD recycle bin either graphically using Active Directory Administrative Center, or you could use PowerShell. You do need to have enterprise admins privileged to do this, because you're really extending the forest schema by enabling this. You should know that the AD recycle bin is a one-way operation, just like you know that when you normally extend the AD schema, you'll never be able to delete that extension. You can disable it, but you can't delete it. Well, with AD recycle bin, once it's enabled, it's on forever. The retention attribute that is most pertinent here is called MSDS deleted object lifetime. And by default, it picks up the default value of tombstone lifetime, which is 180 days. Now, I'm going to show you in the demo that if you want to extend that retention period, we can modify the MSDS deleted object lifetime attribute, and we can boost it out to 365 days, which seems to me uniformly to be a good idea, so that you have a catch bucket, as it were, for your deleted objects. You might have an employee leave your organization, and one of your colleagues deletes their account, and then the user comes back to the organization. Or you realize, wait a minute now, for retention, for compliance purposes, we need to retain deleted objects. In fact, we can't delete them. Can we recover it? Well, yes, we can, fortunately. This is a good feature. Now, if there's a downside or a criticism that I just want you to be aware of with AD Recycle Bin, it's that its use and enablement means that you've got a little bit extra load on Active Directory because your AD domain controllers will be replicating the deleted objects in addition to the live objects. So that's just something to consider. Like I mentioned in my introduction, DSRM provides a way to recover Active Directory. It's a safe mode startup environment. Now, back in the old days, I remember having to reboot servers more often than I wanted to. And if we needed to do something like an Active Directory maintenance or recovery operation, it was pressing F8 at boot and then choosing DSRM as our startup environment. And again, that's still possible. But fortunately, the Windows Server engineers have taken many steps to minimize the times where you actually need to boot your server, particularly your domain controller. This has to be a domain controller. I didn't mention that explicitly, but the only machines in your environment that are going to have directory services on them are Active Directory domain controllers. I also want to be explicit. Although this lesson does touch on Azure Active Directory a little bit when we're doing hybrid authentication, everything else here is limited to Active Directory domain services, although regardless of whether your domain controllers are running on-prem or in the Azure cloud. So as I was saying, DSRM is indicated when you need to perform either restorations of the entire AD directory, or maybe just individual deleted objects, or you're looking to performance tune Active Directory. You can defragment and compact the AD directory, but hopefully it makes sense that that directory needs to be unlocked and offline in order to allow Windows to do that kind of work. You use the ntdsutil.exe. It's an old command line tool. And what I'd mentioned a moment ago is that the Microsoft engineers now have Active Directory domain services running as a service itself. And as you know, with Windows services, you can stop, start, and restart those services. It's called Restartable Active Directory Domain Services. And so this means as long as your domain controller isn't in a completely stuck state where you literally cannot manipulate the ADDS service, in that case, you would have to force a DSRM startup. But if your machine is not that bad off and you need to take the directory offline on that domain controller, you can simply stop the service. This is a really great convenience. Now, of course, if you only have one domain controller, that's going to immediately present issues, present a denial of service for your users and your applications. I hope it almost goes without saying that you have redundancy, that you have one or more live and functional domain controllers when you're taking another one down for maintenance. SYSVOL stands for the system volume, and it's a special directory under C Windows SysVol that's replicated among domain controllers using DFSR. Now, we cover distributed file system and DFSR replication elsewhere in this training course. The old replication protocol, FRS, I hope you're not using that. You really want to be using DFSR. This is the current proven practice with Active Directory replication in terms of its performance, and if nothing else, its compatibility with features like DFS, file share trees, and so on. What does SYSVOL contain and why is it so important? Why do you care about recovering it if there's a problem? Well, if you're using group policy for your configuration and desktop management, you probably are. Well, the SYSVOL is how those group policy templates and support files are replicated among your domain controllers. Also, if your users are reliant upon logon scripts for things like drive mappings and so forth, again, those are delivered and replicated via SYSVOL. So therefore, at the least, a corruption of SYSVOL and then a propagation of that corruption due to Active Directory replication is going to show up with group policy application problems big time. So you definitely want to make sure that you're backing up SYSVOL regularly. The out-of-box way to ensure that you're backing up and protecting your system volume is to run regular system state backups on your Windows Server machines. We can use the Windows Server Backup GUI tool, or, this is an exam alert, the WB admin command line tool. And this is really the preferred way to go, of course, because you can create scripts and then run those scripts on a schedule. Specifically, if your SYSVOL is corrupted and you need to recover or restore it, you want to make sure that that recovery is authoritative. You can do that when you restore by providing the auth SYSVOL switch to the WB admin command. That's what's called an authoritative SYSVOL restore. And authoritative simply means that that newly restored SYSVOL, and what authoritative means in this context, is that that copy of SYSVOL that you've just restored is considered to be the canonical version in the domain. And so all of the replica peer domain controllers need to overwrite their local copies with that authoritative copy. That's what that means. And there's some additional work besides just setting the auth SYSVOL flag in your recovery. You'll also need to set the MSDFSR options attribute to 1 in Active Directory users and computers. We don't need to get too far into the details here for our AZ-801. We just need to know more than anything else, the tools, the use cases, etc. Now, if you make a change on one domain controller, we just assume as a matter of course, I think, that that change is going to be picked up within seconds on some or all domain controllers in the forest. At the very least, you want that change propagated to other domain controllers in that domain. Recall that the Active Directory database is divided into what are called directory partitions that have different scopes of replication within a domain, between domains, and across the entire forest. Domain, configuration, schema, and application. And that last one, application, is the one that we as administrators can use in terms of replicating custom data to suit our use case. The tools that we use here to troubleshoot AD replication problems, now remember that the exam is covering only Microsoft technologies and even more to the point, Microsoft in-box Windows Server features. So we've got the Active Directory Sites and Services console. We also have a long-standing command line utility called repadmin that's available on your domain controllers. And then we can always fire up good old Event Viewer and look at the AD DS server roles custom view. Another important and valid AD replication troubleshooting technique is to just run a quick check to make sure that your flexible single master operation role holders, your FSMO role holders, are proper and you're not experiencing replication failures as a result of a misconfiguration or a key role holder being offline, in which case you can transfer or seize the role as necessary. Here's a screenshot of repadmin command line output. We don't need to memorize all of this. I just wanted to give you the flavor that repadmin is not PowerShell. It's one of those old school compiled executables with its own syntax. But if we take a look at some of the common commands in this help output, KCC, of course, is the knowledge consistency checker. That allows us to run a test focusing. This allows us to test specifically, is the KCC able to see our replication topology? Has it been able to generate those connection objects? And if not, what's going on? Q shows inbound replication requests. We can actually trigger replication with rep-admin. That would be /replicate. REPL summary is a nice get type command where you can just get a fast view about what's happening in terms of the relative health of your forest Active Directory replication. So this is a great, in sum, this is a great command to have in your toolbox, just in terms of running quick diagnostics and verification. Now, in our context, hybrid identity refers to extending our local Active Directory domain services identities into the Microsoft Azure cloud, where the identity store in Azure is Azure Active Directory. Now let me bring out my drawing tools here. And I want to walk you through this diagram I created for us. First, on the left-hand side in our local environment, we have our local domain controller fabric that contains our user account. So here is the fictional Tim user. And now that we're beginning our cloud journey, we have apps running in Azure or that use Azure AD authentication at the least. These could be line of business apps. They could be connection opportunities to Azure infrastructure and platform services, or they could be single sign-on flows to Microsoft 365 or other software as a service apps, you see. And what we want to avoid at all costs is having the user's local credentials wind up getting different in the cloud from what they are on-prem. You want them synchronized, don't you? And then there's the question about password change. That gets too far into the weeds. I'm going to leave it at that. But the secret sauce to hybrid identity is a service called Azure AD Connect. Now there's two versions of this. Azure AD Connect proper is a client-side service that you install and configure locally. And it goes over the internet on HTTPS TCP 443 to synchronize those identities locally into Azure AD. Now there's a more recent version of Azure AD called Cloud Sync that runs, by contrast, almost exclusively in the cloud. That's really the future direction of hybrid identity, but at least as of this recording in spring 2022, there's enough of a feature disparity to where I normally recommend clients to start with Azure AD Connect because it's a mature, fully functional synchronization topology. So what does that give us at the end of the day? Well, at the end of the day, that means that we've got a copy of that user as well as their credentials stored in the cloud. And then when we instruct the user to sign into SaaS apps, we can tell them to use their on-premises credentials, their user principal name, which hopefully you've done work to make sure that that format matches the user's business email address, and then their on-premises directory password. So we're giving them a single sign-on experience. And yes, we could split hairs and say, unless you're doing something like ADFS with federation, this isn't exactly single sign-on. Yeah, okay, I'd love to have that talk with you, but bear with me here, okay? We are, in a sense, simulating a single sign-on situation for our users. So the exam speaks specifically with, given that you have a topology like this set up, what do you do tool-wise to troubleshoot problems? Well, the main parts of the exam objectives, I think, deal with the front end of things where you're planning hybrid identity. There's a free tool Microsoft publishes called IDFix. You can do a streaming run of it directly from its GitHub repo. And this is a great tool to scan your Active Directory to look for potential account synchronization errors. Specifically, the user principal name on-prem is going to be the sign-in name that you use in Azure AD by default, but there's some other fields like proxy address and email address that you might want to use as a unique identifier. And you want to think about, if you're going to replicate multiple domains and forests, you might have aliases and alternate UPN suffixes. You don't want to run into collisions here with those names. Now, it's true that Azure AD Connect does have some ways to override, but it's best to solve this kind of stuff on the front end, and IDFix can show that to you. Another tool is the Azure AD Connect troubleshooting tool. This is available in the Azure AD Connect bits. Once you install the service on one or more of your local infrastructure servers, you can invoke the troubleshooting tool. That is a PowerShell-based tool set, so you'll want to make sure that on your Azure AD Connect server, you have your script execution policy such that you can run the scripts. And then lastly, there's Azure AD Connect Health. This is available in the Azure portal and gives you a bird's eye perspective of synchronization issues. Well, isn't that what we've been doing pretty much this entire lesson, Tim? Yes. But these are the skills as they are listed on AZ-801. And I want to make sure I'm covering every one of those objectives. So we've got DC Diag. This again is a long-standing compiled executable. We have setting directory services logging to its highest level. Again, that's not something you'd want to leave on, but for diagnostics and troubleshooting, certainly. And you do that by editing this registry value here. You can implement event tracing for Windows, or what Microsoft calls ETW, to trace low-level lightweight directory access protocol, or LDAP communications. You use the tracelog.exe executable that's on your domain controllers already. And then, as I mentioned a moment ago, you have rep admin. So here is a screenshot of some output from DC Diag. If you do a /C, that just runs all of the built-in tests. And it's a very comprehensive test suite for sure. I mean, it's going to look at replication, it's going to look at DNS name resolution, you name it. It's going to take a look at your domain controller and its environment within the domain and within the forest. So I think that's why it still exists in the product. It's still very useful. All right, well now I want to spend the rest of our time together in this lesson in demo. Let's take a closer look at some of these technologies. All right, in this demonstration, we'll take a look at some Active Directory maintenance operations, and I'm going to do quite a bit of our work here in PowerShell, and that solves a couple problems for me as an instructor. One, I want to repeat for perhaps the 100th time that you need to have an intermediate PowerShell skill to be successful on most of the Azure certification exams. And number two, if you're not using PowerShell anyway, what's wrong? Come on, right? So here we are in Visual Studio Code, and I'm actually on a domain controller called dc1.contoso.com. So anyway, I've got here on line 13, enable AD optional feature, recycle bin feature. The scope is forest. The target is the name of my local domain. And I've added what if to that. That's a nice little check that you can add to your command to see what would happen. And it looks like we're going to see a warning that this operation is not reversible, and then it will perform the operation enable. And that's what I want. So why don't we get rid of that what if flag, and let me select that command. We'll right click and run the selection and turn the bin on. Now it's asking us, are you sure you want to do this? I'm going to say yes to all, and then that's all we have to do. We can take a look, for example, if we have the feature enabled. Let me just change enable to the well-known verb get, and I'll select this part of the command and we'll run that. And that gives us an indication of what's going on here, where it's enabled. Is disableable false? Well, we knew that. And there you have it. Okay, now as far as customizing the behavior, I'll show you how we can recover objects next. But to get rid of some of this technical stuff first here, you see in my script I've got some manage tombstone lifetime. So I'd mentioned that the default is 180 days. So let me show you how we can make that change. First, we have this command up here. Let's run this, and that'll just tell us the default output here. In other words, what is the tombstone lifetime set for right now? And we can see that that is set for 180 days. So what I'm going to do is update that conf name context variable. I basically took the existing tombstone lifetime, created an object out of it, and packed it into this variable. And now on line 20 and 21, I'm going to bring in that variable, I'm going to redefine it, and I'm going to set AD object to replace the tombstone lifetime to 365 days instead of 180. Now, as far as working with the AD recycle bin, again, we can do that programmatically or we can do it graphically. If we're going to do it graphically, it has to be in the Active Directory Administrative Center. So why don't we go into my HQ Staff Organizational Unit, and I'm going to delete my Jerry Walls user right here. Right-click, delete. Are you sure you want to delete user? Uh-oh. I'm actually going to delete a group too. If we go into the group, take a look, its members are, looks like there's nobody in there right now. It's empty, so why don't I add in, let's see. The Jerry account's gone, so it can't be Jerry anymore. How about Pat Smith? So let's come back here and let's add in Pat Smith and click OK. And now I'm going to promptly delete it. Right-click, delete. Are you sure you want to delete it? Yes. So how do you get to the recycle bin? Well, what we want to do here is come into the domain, come down into the system container. How do we view those objects graphically? Well, we select the domain, and then we'll see the deleted objects container that's available because we enabled the recycle bin. By the way, if you wanted to enable the recycle bin graphically, we select the domain, and then we have over here, enable recycle bin. Now it's grayed out because I've already done it. And if we go into deleted objects, we can right-click groups and/or users. We can locate their parent, we can view their properties, we can restore in place, or we can restore to an alternate location. And those same controls are available for users as well, you see. So if I come back, we can do the same thing programmatically in PowerShell here. First of all, we can verify that the container exists. And then we can run a check here on line 26. This is quite a long pipeline, but what this is doing is going to fetch all of our deleted objects in the container and then list them out. So we can see there's Jerry Walls right here. And let's see. Interestingly, the output isn't giving us a group. Oh, that's because the object class is set to user. Okay, well, if we did group, in fact, let's try it right now. Let's add group, and now let's try the same pipeline. Right-click. Yeah, there we go. It was just a question of editing it. We could also do something like this, where we're just doing a filter using like. So you can get as creative as you want with that. Let's come back and let me resurrect these users. Right-click, restore. You see how fast and easy that is? And then if we come back, we can check out our group membership again. Let's go back to members. And it's important to see that looks like Jerry was originally in the group and then we deleted him, so AD took him out of the group. And now that I've resurrected both the group and the user, you can see that the group is back with all of the users who are supposed to be in there. So that is the AD recycle bin. Now, how about directory services restore mode and some system state type operations? What's going on with that? Well, let's see what we've got in my script here. As far as DSRM, or Directory Services Restore Mode, if your server is totally down, you may have to do the press F8 to start, and then when you get your safe mode screen, you can go into DSRM. If your server is not that badly off and you can get to msconfig, another way to do it is to come into the msconfig system configuration, go to boot, and we can specify, I want to do a safe boot Active Directory repair, and that will bring you to a console where you can start to work with NTDS util, and it's implied that the ADDS directory is offline at that point. But with restartable ADDS, we don't have to do that most of the time. In fact, let me show you. I've got some of that scripted out as well down here. So we can take a look at the service with get service. The short name of the service is NTDS. The display name is Active Directory Domain Services. And if we're going to do something like an authoritative restore of an object, we would need to stop the service first. And then once we stop the service, let me actually do that. Well, actually, before I do that, I may want to check something in the directory. So let's hang on. Once we've stopped the directory, then we can invoke NTDS util immediately. And it has a fairly terse syntax. It's an interactive tool, as you'll see. So we can activate instance NTDS to connect to the directory on that domain controller. and then we can do an authoritative restore. Okay, here's an example here, restore object. I want to make sure I have an object there. So Roger Carr OU is IT. So let's go back to the admin center and see, do I even have an IT OU? Well, I'm going to quickly take care of that. I'm not so good with admin center, to be honest with you, so I'm going to do a dsa.msc. And I'm going to open up the Active Directory Users and Computers MMC console. I'm much better with that, to be totally honest with you. So let me right-click here and do a new organizational unit called IT. Now you notice here that protect container from accidental deletion. It's not even going to be deletable if I have that flag turned on. I'm intentionally going to override it there. And you can see that flag, not when you're in a normal view. You have to be in advanced features. And then when you take a look at your OU again, I think you find it on the object page right there, protect object from accidental deletion. So in that OU, let's just create the Roger account really quickly. Roger Carr, and let's say that this fictional user's log on as Roger at Contoso. Set temp password for the user and confirm it. Okay. Looks like I misspelled it here, so let me rename and fix it here in the last name field. Okay, so far so good, I think. So anyway, so let's stop the NTDS service. Note I need that force to really force it offline. And now I'm just going to echo some of the commands you see up above. NTDS util will put us into the interactive environment. Activate instance NTDS, right? Authoritative restore. And then we've got, I could probably just run this selection, but I'm a little bit paranoid. I'm going to copy and paste. So we're providing the distinguished name for the object. So the common name is Roger Carr, the OU is IT, and the domain is contoso.com. And remember that doing this means that all replication partners will use this as the authoritative canonical copy. Are you sure you want to do this? Yes. Okay, good. So we did that, that's fine. Now we also, if we had deleted the OU, there's a restore subtree command where we can bring back the OU as well, but I think we're good. So I'm going to quit a couple times to come out of NTDS util. And then lastly, I want to start the NTDS service. So this is a good example, a good demo of using restartable Azure, of using restartable ADDS. Now I have some additional code here. We can just take a look at this briefly. To do compact and defragment operations, we can NTDS util, files, compact to your destination volume, integrity for integrity checking. And this process, when you're defragmenting, let me bring my drawing tools out again. The reason why you specify compact to is what's happening is that you have your live database, and then ADDS will create a compacted version of that database and put it in your out location. And then as a final step, you need to restore the file. The actual ADDS directory is a file called ntds.dit. And it needs to be on the path C Windows NTDS in order for the domain controller to function. And then we can trim out, get rid of our excess event logs, and then we can start our service. And then in terms of system state, this would be in reference to the SYSVOL stuff that we were talking about before. As long as you have the Windows Server Backup feature installed on your machine, you can invoke wbadmin. And notice that there's start system state backup, and you provide a backup target. It could be a universal naming convention path or whatever. Now check this out here. To do a SYSVOL authoritative restore, wbadmin start system state recovery, you need to give the time and date stamp of your backup snapshot, where your backup snapshot is, the machine that you're restoring on, and then auth sysvol marks the restored sysvol as authoritative. Nice. All right, I think we're just about done here. Last thing I want to do is go out to Azure. First of all, I want to just drive by that IDFix utility. As I said, nowadays IDFix is available out at GitHub. Let me see, I was hoping to find the canonical download here. Let me see. Install ID fix on step 1. Select setup.exe. Well, that's an install link, isn't it? Anyway, I'm just rolling with it in this demo here. It is, in fact, a streaming click-once application, as you can see. So it gets streamed right out of GitHub. And so you'll always have the latest version of the app. And the text here is a little bit hard for me to read. The UI here, I'm colorblind, so it's awfully difficult to look. But you can just send that in to your directory. There's a settings up here where you can domain or domains you want to analyze, what credentials you want to use for the analysis. And this gives you a great heads up of any possible account sync problems that you may have when you're configuring that hybrid identity. And then in the cloud, we have in our Azure Active Directory tenant, we can come down under Azure AD Connect. And nowadays, the portal is assuming that you want to use Cloud Sync rather than the old Azure AD Connect. If you want the Azure AD Connect, just go to the Microsoft Download Center and install it. But this is where you can centrally manage that hybrid. And in terms of troubleshooting and getting visibility, that again is where the exam is going to focus. You've got Troubleshoot right here, which is going to take you into an interactive troubleshooter based on what Microsoft's identified to be their most common issues. Another thing you can do is, well, verify how you're doing. Sign in, but then ultimately you have Azure AD Connect Health, as I said before. So this is our health and analytics engine. And you can see at a glance, you can look at sync errors as well as your synchronization meta. I don't have hybrid identity set up right now, so it's just showing all zeros. But this is a clickable interface that you can click into. If you are using Active Directory Federation Service Federation, you can view federation status here. So that's a good tool for you to be aware of as well. Well, there you have it. By now we've reviewed every skill on the AZ-801 Configuring Windows Server Hybrid Advanced Services Certification exam. Congratulations! You now know the core skills involved in being a Microsoft Windows Server Hybrid Administrator. Specifically, you can secure Windows Server both on-premises and in a hybrid environment. You can implement and manage Windows Server High Availability. You can implement disaster recovery as well as migration. You can also monitor and troubleshoot your Windows Server hybrid cloud environment. These skills will carry you a long way in your career. I've said it before and I'm sure I'll keep saying it. Windows Server administration skills, especially in a hybrid cloud context, are applicable to any cloud vendor, not only with Microsoft Azure. Are you now ready to register and sit the AZ-801 exam? Well, as most IT consultants reply, that depends. In counseling my certification students, I stress a healthy balance between three interdependent pillars: theoretical knowledge, hands-on experience, and practice exam drilling. With respect to picking up the theoretical knowledge, you're here in this course, so you have that base covered. For the hands-on learning front, there's always Microsoft Learn. Microsoft hosts a sandbox environment for some of its Azure IaaS labs. What's more is that Microsoft Learn is free. For AZ-801 practice exams, check out what Pearson has to offer. I also recommend you look at MeasureUp. They're Microsoft's only official certification practice exam vendor. MeasureUp provides you with highly realistic exam simulations that include all the interactive item types you'll see on the live exam. In conclusion, I want to personally thank you for investing the time and effort in studying this course. I appreciate you very much. Thanks again. I wish you all the best in your Windows Server hybrid administration journey.